Hello, Olympiad Corner. How are you guys? Okay, some of you are here. Hello, sir. There, Rakshit is there. Aditya is there. Like, quite a less, but yeah, there are. So yes, uh, let me introduce myself. My name is not Ayush Patni. Yeah, it might sound like that. Yeah, it spells like that. Does it? That's not anybody's mistake. That's the spelling's mistake. So my name is Ayush Patni, or I'm not the brother of Disha Patni, Disha Patani, or I have no relation with Disha Patani. That all I can tell you for now. Yeah, I'm new here. I'm new at Olympiad Corner. Some of you might have seen me earlier. I was there on an Academy English channel as well as right now. I'm some of you might know me from JEfinity also. And if you are enrolled into any of the plus, I'm currently taking the courses for the plus and VIP courses for our Unacademy JE students, right? The students who are appearing for JE 26 or 27 and who appeared for 25 also. Uh, they were part of the combinatorics. Combinatorics, right now I was informed and I'm supposed to start with recursive series. Okay. Obviously, there are going to be more topics. Sir, is this course of sequence and series? Mm, uh, Obviously, sequence and series, recursive series, when we are saying, no, when we are saying recursive series, any sequence with a pattern. When I'm telling you, no, any sequence with pattern, or I shall say rule, anything which has a pattern or a rule. Sir, Hindi में बोलिए मातृभाषा. No, I'm not going to speak in Hindi. Because PJ sir only told me that these sessions are for the students who have trouble speaking or understanding Hindi. So Ayush Kumar, there are many there is a lot of content already on YouTube which is already in Hindi. All right, here it's fine. Okay. Right now, let me speak in English and let me help the students who are preparing for Olympiads like IOQM, PRMO, or any other Olympiad, and let me help them with the their concepts. Sir, are you the brother of Disha Patni? No, I told you in the starting itself. Okay, any sequence which follows a pattern or a rule can be called as a recursive series. So now, if you ask me, sir, are you going to teach sequence and series in in these sessions? So I would say, kind of yes. Sequence and series. Now, sequence and series, when we study it in class 11th as a topic for JE or for class 11th, we only study about a few type of sequences, like we study about arithmetic progressions, we study about geometry, we study about harmonic progressions, we study about the progressions which involve AP and GP both, and there are many things in sequence and series of class 11th which we are not going to include in these sessions, and there are many things in these sessions in recursive series uh, uh, sessions that are not going to be in JE syllabus also. So I must tell you that a question which can be from recursive series in IOQM or in PRMO might be of the level of JE advanced, but you won't realize it. So now we are going to study any sequence of numbers which is going to involve a rule or a pattern. Simple thing. Rule means recursion. Rule means recursion. Like anything which is following. Now, if you are, or if you have studied computer science, if you have taken some classes of computer science, or if you have computers in your syllabus, then you must have heard about something called Fibonacci. It's not Japanese. Fibonacci sequence. So what is Fibonacci sequence? Looks like something Japanese. Some of you might have heard about these type of sequence. Fibonacci sequence is something like this. If I write 0 and 1, right, it starts with only two terms. Now you keep adding one term. So 1 plus 0 is 1. Now, every next term, this term is going to be obtained by adding these two, right? Now this term is going to be obtained by adding these two. So 1 plus 1, 2. Now 2 plus 1, 3. Now 3 plus 2, 5. Now 5 plus 3, 8. 8 plus 5, 13. Like that, it will keep going on. But you know that every term which is being obtained after the first two terms is being obtained by a rule. Kushal Jain is saying, sir, please say my name. Kushal Jain. What happiness do you find? Sir, how many lectures will it take to finish? Let's see, I will try to complete it in somewhere around 5 to 6 lectures. That must be enough. Okay, Fibonacci series. There is a rule. Now, you must in the earlier classes, or in the, if you are solving mental ability or logical reasoning also, then you must have seen a lot of these type of sequence. A lot of these type of sequences. For example, let me give you a simple example. Like for when we were small, no, my teacher made me do a small activity. Right? What was the activity? That you take matchsticks. Right? He gave me a lot of matchsticks. Sir, what did she want you to do? To burn down the school? No. Or to light up something? No. सर क्या आप कॉम्बिनेटोरिक्स करवाओगे? देखते हैं, ठीक है? आप अभी first let's study this. Okay, so what I'm saying, that if you have a lot of matchsticks, let's suppose that we have a lot of matchsticks, and what are we supposed to do? We are supposed to make squares like this. Suppose we need matchsticks and we are just going to arrange these matchsticks in form of combined squares. Suppose for this square, for one square, I need how many matchsticks? How many matchsticks would I need to just make one square? 4 matchsticks would be enough, right? 4 matchsticks would be enough. Now, if I want to make more squares using these matchsticks, I have a lot of matchsticks. I have a lot of matchsticks. I have a pool filled of matchsticks. Nothing, please. Okay. Okay. So now, if you want 2 squares like this, how many matchsticks? 7. You need 7 matchsticks to make 2 squares. If you want one more square to be attached to it, right? If you want one more square to be attached to it, right? So you can make attached squares using these matchsticks. This is some activity which I remember doing in school. Very lame activity, obviously. But this activity was being taught to make you understand 2 things. First is algebra, and second is the recursion or formula making. Whenever something is making a pattern, whenever numbers are making a pattern, suppose if I just simply put the numbers 1, 2, 3, 5, 3, 2, 9, 7, 6. Now there is no pattern over here. There is no pattern over here. But if I am writing like this, half, 0, half, 1, 3 by 2, 2, 5 by 2. Now there is a pattern. Half is being added. So now I can tell about the next term. But here I cannot tell about the next term. I can just guess. That guess might be right or might not be right. So it's not, this is a sequence, this is also a sequence. Both of them are sequence. This is a sequence and this is also a sequence. But this is recursive. Recursive means the pattern, the rule is being followed to get the next term every time. For every time, here I'll have to, I don't need to guess the next term. I can find the next term. I know that the next term is going to be, my next term is going to be 3. Correct? But here, can you tell me what will be the next term? There is no pattern. So I cannot tell. What about this? What about this? For one square, I need for making one square using matchsticks, I need 4 matchsticks. To make 2 squares, I need how many matchsticks? 7. Till here, I've used 7 matchsticks. How many matchsticks do I need to make 2 squares? 7. How many matchsticks do I need to make 3 squares? 10. How many matchsticks do I need to make 4 squares combined together? How many? 13. And you know that this is going to be 6. Why? Because I know every time I'm adding 3 matchsticks. Now, if I tell you how many matchsticks, how many matches sticks to make 100 squares, you tell me, how many would you need to make 97 squares? How many matchsticks would you need to make 97 squares? 97 squares. You tell me about it. Can you calculate it? Do you need to guess it? Or you can do it easily. You know that you can do it easily. 97 you need to make. Now how? For first one, I needed 4 matchsticks. Correct? For first one, I needed 4 matchsticks. So first thing which comes into my mind is, sir, I can do one thing. 4 multiplied with something. 4 multiplied with something That means 4 into 1 plus 3, or this I can write as 4x plus 3. Now this x ka value will give me terms. Now let's see, will this work over here, right? For example, if instead of x, I'm just writing 4n. Now let's see this formula works for every term or not. I'll have to check, correct? Will 4n plus 3 work? What do you guys say? Is 4n plus 3 working? Now on 4n plus 3, if I observe this 4n plus 3, then n is equal to 1. That means first term, I'm denoting first term as T1. What is T1? T1 is 4 into 1 plus 3, that means 7. Wrong. Okay, let's say it's starting from here only. What else? I can say n is equal to, if I take n is equal to 2, then I should get T2. That means second term I should get. This is the second term, this is the first term, this is the second term, third term, fourth term, fifth term. I am making a recursive sequence of numbers basically. Correct? So this is T2, second term. What is the second term? Am I getting the second term on this formula? 4 2s are 8, 8 plus 3? No, 11. This is not working. So basically but we know from the bottom of our heart that this particular series is recursive. There is a pattern, 3 is being added. What formula can we make it over here? What formula can we give it over here? Now, if you observe carefully, 7, 10, 13, 16 and 4, these all of these numbers are 1 ahead of a multiple of 3. 3 ones are 3 plus 1, 4. 3 twos are 6 plus 1, 7. 3 threes are 9 plus 1, 10. 3 fours are 12 plus 1, 13. 3 fives are 15 plus 1, 16. My God. So that means the formula is here. 3n plus 1 should be the formula. On n is equal to 1, I am getting the first term. What is my first term? Put n equal to 1. 3 into 1 plus 1. I am getting second term on n is equal to 2. So that means my T2 is 7. 3 into 2 plus 1. I am getting all the terms, correct? Now can you tell me what will be the 90s? How many sticks would you need to make? How many total number of sticks will you need to make 97 square? All additions, bacha. All additions. One student is asking, sir, which edition of PJ sir's books is best? All of it depends, like what are you targeting? Which, for example, for algebra, like if every edition is for different that, but I think I wouldn't comment on this. So it's not always correct, and it's not appropriate also to compare the compare the knowledge or compare the books. Some people say Cengage is good, some people say sir, NCRT is also good. So every book is good at its own place. What you need to learn, that a book depends on that, right? For one student, HC Verma could be good because he wants conceptual knowledge and gradual solving, and for one student, Irodov can be good because he wants to, or any other higher level of book can be good. It depends what you need. Okay, did you understand my point? Yes or no? What I'm trying to explain, I'm saying recursion is happening, a pattern is being followed, correct? A pattern is being followed so 97 squares, how many sticks do you need to make the 97 squares? I don't know. I just know that when I'm putting n is equal to 97, I'm getting 97th term. Till here I've used 16 sticks. So till 97th square, I'm going to use 3 multiplied with 97 plus 1. 97 into 3. How do you multiply? How do you multiply? Start multiplying in your brains like this. I don't know how do you multiply. Maybe you are using this, but I generally use this trick to multiply. I'll tell you how. Whenever I'm multiplying 2-digit number with a single digit number, I do like this. 9 threes are 27. In my mind only I do like this. 7 threes are 21. Right? I just add the first digit of the second number into the first number. 27 plus 2, 290. And this one as it is. 1 will come as it is. 27 plus 2 I'll do. And in my mind only, it will happen very easily. So 291 plus 1. Right? 291 plus 1 is going to be my answer. That means 292 sticks I'll be using in my 97th square when I'm going to make my 97th square. Alright? Did we understand this? right? You have to understand recursion. Now let's start the chapter. Okay, this chapter, entire chapter, recursive series, sequences, series, arithmetic progression, geometric progressions, uh, arithmetico-geometric progressions, Fibonacci sequence, or we can call telescopic series. There are many types of sequences which follow a pattern, and we are going to explore almost all of them. We are going to explore the pattern formation, recursion formula formation, how to make this formula which we spoke about just now, 3n plus 1, how to come up with this formula 3n plus 1. So this is what we can call it, we can call recursive formula or recursion formula for this particular recursion. A sequence is nothing but a recursion only. Easy to understand, calculative topic. Questions from progressions, geometric progressions. Generally, questions will be from progressions. Okay, different type of progressions. From 11th, 12th, and competitions, this topic is very, very important. And for IOQM, obviously, as well as J. Now, one question arises when somebody just spoke about sequence and series. Sir, what is a sequence and what is series? And especially, what is recursive sequence? So, general difference between sequence and series is if you randomly write the numbers. If you randomly write the numbers, right? If you randomly write numbers, for example, 2, 3, 5, 7, 9, 11, 13, 15, 17. Is this is this recursive? Can you tell me the next term? You are from which college? Anna University, Chennai. What happened? Okay. Is this recursive? Do you call it recursive? Next term will be 19. Are you sure? How can you say? Yeah, somebody is saying 35 also. Now, you cannot. These are not odd numbers. Da. 2, 3, 2 is also there. Not even prime numbers. Are these prime numbers? These are not prime numbers. 15 is there. This is not 18. Okay. This is 15. Huh? 15 and 17. We cannot say until and unless we are 100% sure. Why? Are these odd numbers? Sir, these are odd numbers because 3, 5, 7, 11. No, these are not odd numbers. Who is there? No fixed pattern. Are these prime numbers? No, these are not prime numbers. 15 is there, 9 is there. Not even prime numbers. Correct? So there is no fixed pattern. There is no fixed pattern. So how can we comment about this? This is just a sequence. Now, if I add these terms, if I write in addition, if I write the same numbers with an operator, addition operator between them, then this thing is called a series. This is called a sequence. This is called a series. Understood? None of them are recursive. Both of them are either a sequence can be either recursive, either a sequence will be recursive or non-recursive. Right? Either it will be recursive, either it will be recursive means by recursion or by recursive, what do we mean? What do we mean? This is following a rule, following a rule. This will always follow a rule. Right? This will always follow a rule or there will be a pattern and you can always obtain a formula out of it. But here, no rule, no pattern, nothing. You cannot comment about the recursive formula because randomly numbers are just put, they are not following a pattern. So, non-recursive, recursive, right? Now, these recursive series only are further called progressions then, progressions. Because if there is a pattern, right? If there is a pattern, two types of pattern can be there. One is this 1 1 1 1 1 1 1 1. I'm just writing one. What will be the next term? 1 only. But if I'm writing 1 2 3 4 5 6, next term will be 7. I can tell. But this is increasing. Or if I'm looking from this side, then this is decreasing. Progression, the word itself suggests either it should increase or decrease. But yeah, this is also a recursive. This is also a recursive sequence. This is also a recursive sequence. Both of them are recursive. But this is progressing, increasing. This is constant, fixed. So recursion, by this we just understand that it should follow a pattern. Now, just now we spoke about Fibonacci, right? We wrote this, no? So write any two numbers. For example, I want to make a Fibonacci sequence of 1 and 3. So 1 and 3 are the first two numbers. Next terms I'm going to obtain 3 plus 1, 4, 4 plus 3, 7, 7 plus 4, 11, 11 plus 7, 18, 18 plus 11, 29, like this. I'm going to go. Okay, like this. Now terms. Now in any sequence, obviously this is following a pattern, this is following a rule. You can always tell the next term, yes or no. You'll always be able to tell the next term, na? Ha, Baba? Are say yes or no. You'll always be able to tell the next term. You just have to add the last two terms and you can always obtain the next term. But the question is, rule. What is the rule? How do you write the rule? Or if a rule is written, how do you read it? If a rule is already written, how will you be able to read it? For example, if this is called Fibonacci. This is just now I named it, but this is called Fibonacci. Fibonacci sequence or Fibonacci sequence. I don't know. I've never found the correct pronunciation of this, but yeah, something like this. Okay. So now suppose if this is my first term, let's say T1 or A1, right? A1 or T1, anything. You can denote it with first term. A1 also means sometimes they'll use A1, sometimes they'll use T1, something like this. Right now, let's say we are using T1. This is your T2. This is your T3. This is your T4. This is your T5, fifth term. This is your sixth term, seventh term, and so on. And here somewhere there will be some term. Let's say 100th term, 200th term, 500th term. So I am just assigning a variable to it. Let's say nth term, some term. N can have any natural value. Yes or no? Can n have any real value? Can there be a, sir, can you tell me 4.5th term? Will you be able to tell me 4.5th term? 4.5th term? Or can you tell me, huh? No, right? The position has to be natural number. If we are telling position of a term, then that position has to be a natural number. There is no other go. It has to be a natural number. Yes or no? Yes, it has to be a natural number. This Tn is here, n has to be a natural number. First of all, we should understand this. Now suppose I know that T3 is being obtained by doing T2 plus T1. Yes or no? And I also know that T4 is obtained by doing T3 plus T2. I also know T5 is being obtained by doing T4 plus T3. So yes, I can write a rule, man. Why not? Sir, can you explain it again? Sudha, I'm saying, acha, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now suppose I want 99th term. I want 99th term. I would know that T99 is going to be T98 plus T97. Yes or no? T99 means 99th term. T98 means 98th term. T97 means 97th term. Similarly, T1 means first term, T2 means second term, T3 means third term, T4 means, hai na? Understood, Sudha? Correct. So Tn means some nth term. Okay, some term. Some n. N is just a position. Right? For example, T99 would be T98 plus T97. Why? Because look, T3 is 3 plus 1. 4 is 3 plus 1. T4 is 4 plus 3. T5 is 7 plus 4. T6 is 11 plus 7. Pakka na? Correctly understood? Everybody? Simple to understand. But we are defining a rule. We are making a rule. We have to, if we want to generalize things in mathematics, it is but obvious that we need to use variables. Right? We need to use, what are variables? Variables are holding boxes. We need to use variables. That variable is n. This n, it can be any natural number. N belongs to natural number. N can be any natural number. Any natural number. Very good, Kumar. Rakshit has given one answer. Tn is equal to Tn minus 1 plus Tn. Very good. So any term Tn will be equal to Tn minus 1 plus Tn minus 2. Okay, that. This is the recursive, because this is what we'll call it, recursion formula, RF. This is what we can call a recursion formula anytime. Now here, but we'll have to define, we'll have to mention, bacha, that n has to be greater than or equal to 2. Yes or no? not greater than or equal to, just greater than 2, not even equal to. N has to be greater than 2 because first term cannot be obtained in a Fibonacci sequence. If I want to make, if given n is 9, n is a natural number greater than 2. N is a natural number for sure, but n is a natural number greater than 2 na. Why greater than 2 sir? Arey yaar, can I find t1? By t1 तो I cannot find from this rule na, because I don't have t0 and t minus 1. But t1 and t2 should be given for a Fibonacci sequence. That does series follow a pattern? Series means sum of the terms of a sequence. Series is the sequence, the term of sequence only with the addition operator between them, multiplication order between them, anything, right? Right. So see, if sequence in sequence only, if we add the operators, that becomes a series. So if sequence is up forming a pattern, then series will also a pattern, form a pattern. So that's what I'm talking about. We are in recursive series, we are going to look at or study or solve any number sequence which is following a pattern. That is what we are calling recursive series or recursive sequence. Okay, recursive, if they are recursive, then pattern. If not recursive, just a sequence, simple sequence. Clear, Aditya? So recursion formula, did you understand? We had to completely, a recursion formula has to be completely defined for every term. Now obviously a Fibonacci sequence will always start with two given terms. If two given terms are not, if 0 and 1 are given to me, form a Fibonacci sequence whose first term and second term are 0 and 1. So I can make na 0, 1, 1, 1, sorry, 2, 3, 5, 8 like this. First two has to be given. So when we are writing the recursive formula for Fibonacci sequence, we have mentioned that Baba n is greater than 2. Because if n is equal to 2 also, our formula, what will become our formula? If we take n equal to 2, then we'll have t2 is equal to t1 plus t0, but t0 we don't have, right? That is why. So recursive means terms are dependent on a pattern, on a rule, not the previous term. This is one kind of a recursive series. There can be many kinds of recursive series. For example, if I just simply say, if I just simply say 2, sorry, 1, if I say 1, 2, 4, 8, 32. Tell me the 10th term. Is this a recursive sequence? Is this a recursive thing? Is this a recursive sequence? Na Baba, into 2. Na. The rule is not into 2. The rule is 2 to the power n, where n belongs to whole number. Where n belongs to whole number. GP, enga GP. Rule I can find na. 2 to the power n only, no? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power. Why are you getting into AP, GP and all that? No need. Right now, let's just try to understand how are we going to how are we going to put a formula over our recursion. Okay, bilkul. 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Okay, ji. So next term is going to be 2 to the power 7. 128, no? Huh? What will be the answer? Sir, what is recursive series? Whatever is following a pattern, memes ka tadka is, did you listen beta? I'm just saying anything which makes a pattern, which is following a rule. Series means if we put addition in that, it will become a recursive series. If we don't put addition, if we are just putting a comma between them, it is a recursive sequence. There should be recursion. Okay? Bhai, yes or no? Understood? No. So here 2 to the power n, where n belongs to a whole number. And if we say n is a natural number, then 1 cannot be obtained in that. Right? Suppose if I write the recursion formula, which is 2 to the power n, and n belongs to a natural number, this will be wrong, because you cannot obtain the first term from this formula, because 0 is not a natural number. Na? Natural numbers start from 1. So your formula has to be intact. Recursion formula has to be intact, fully intact. That this is what is going to be the formula. It should not confuse anything. Okay, are we clear? Are we clear? Okay, let's do a question on this. Yeah. Okay, what is a progression? One more term came right here. What is a sequence? What is a series? And third thing was, what do we mean by a progression? So progression which is increasing or decreasing on a fixed pattern, increasing or decreasing on a fixed pattern. Following. So this is a sequence. This is what? This is a sequence of numbers. This is a sequence of numbers following a fixed rule. Following a fixed rule. A fixed pattern, or we shall say fixed rule. That's it. What's the problem? Many types of Fibonacci series. Sir, is that a progression? Yes, it is a progression. Sir, how can I develop thinking for number theory? By solving a lot of questions. Practice, bacha. Practice. Okay, try to understand numbers. Like, practice a lot. Whenever you are stuck in a problem, suppose you are getting stuck in finding a big power of a number, so solve that type of questions. Suppose if you are getting stuck in some algebraic manipulation of numbers, then solve. You'll have to solve a variety of problems. Whenever you are getting stuck, try to understand everything related to that question. Suppose one question came which is asking me to calculate a very high power of a number, or compare high powers of numbers. So if it needs cyclicity of powers, then I should understand entire cyclicity, everything related to cyclicity. If it is including divisibility rules, then I should understand all the divisibility rules. Then come back to that problem. Learning math and enhancing your math can be done only by one way. That means that way is by solving problems. There is no other go, beta. There is no other go. Only 3 months left. So what? So what? Study hard for 3 months. Crack it. 3 months is more than enough, bacha. Sequence of numbers following a fixed pattern is called progression. Now, progression can be increasing or decreasing. Okay. Progression can be increasing or decreasing. General term. Let's talk about general term. Now, there are some certain types of. Now, this general term can be anything. For example, just now we did no. Just now when we were doing that matchsticks, so 3n plus 1. Suppose Tn is given by general term. Something like this will be given to. Tn means any term of this particular sequence is going to be obtained by this particular recursive sequence is going to be obtained by this. Now, whenever there is a rule written, that means that particular thing is going to make a recursive sequence. It won't make just a sequence. If there is a rule itself means that the sequence is recursive. Okay, correct? Right? So first term is 4, second term is 7, third term is 10. You must have understood. Right? Right? Like that. Okay? So this is how it's going to go. Any general term. Some general term can be anything. Suppose if I write Tn is equal to 4n square minus 1. Okay. So now what will be T1? T1 will be 4 minus 1 equal to 3. T2 will be 4 into 2 square minus 1. That means 15. Okay. Understood? Are you getting my name? This is recursive or not? You tell me. If I write Tn is equal to 4n square minus 1, what will be the first term? 4 into 1 square minus 1. That means 4 minus 1. Second term will be 4 into 2 square minus 1. That means 4 into 4, 16 minus 1, 15. I can find T3 also. 4 into 3 square. That means 9 minus 1. So that will be 35. Is this so if I randomly write 3, 15, 35, right? If I'm writing like this, by looking at the sequence, you cannot say easily, is this a recursive or not? You cannot directly say like that. But when you look at this, that every term of this sequence is going to be obtained by a single formula, and this is our recursion formula. Also, we can call it a general term. Okay, this you can also call it a general term. Correct? General term meaning you guys understood, right? What do we mean by general term? So general term means the formula. General term means any term, first term, second term, third term, but one formula. General term, any term of this particular sequence is general. Now let's suppose if we talk about this, simple 1, 2, 3, 5, you know, this is natural numbers only, simply. But if I write 2, 4, 6, 8, 10, 12, 14, now this is increasing. Correct? If I write 14, 12, 10, 8, 6, 4, 2, this is decreasing by 2. Every term is decreased by 2. Something is being added up. Suppose if I write minus 1 by 2, 0, 1 by 2, 1, 3 by 2, 2, 5 by 2, 3. This is also increasing. Correct? This is also increasing. So all these are recursive, but all these are some special type. That is called not Ayush Patni, but arithmetic. Somebody just asked my name, telling again, it is Ayush Patni, arithmetic progression. This is what we call arithmetic progression. This is what we are going to call arithmetic progression. Every term is going, now here, if you add minus 2 to the first term, you'll get the second term. If you add minus 2 to the second term, you'll get third term. If you add minus 2 to the third term, you'll get fourth term. If you add minus 2, this is how you're going to get. Here also, if you add plus 2, plus 2, plus 2, plus 2, plus 2, plus 2, plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. Here, plus half, plus half, plus half, plus half, plus half. So this difference is constant. All in all these examples, what is fixed? There is a difference between what? Difference between Tn and Tn minus 1. What is which difference? Which difference? Tn. Any term, any general term, we'll call it Tn. The previous term will be Tn minus 1. This difference is what we are calling the common difference, or this difference is fixed. Right? Just this you must understand. What do we mean by Tn minus 1? Tn means any term, and Tn minus 1 is previous term. 10th and 9th, 8th and 7th, 6th and 5th, 5th and 4th, 100th and 99th. The difference will always be fixed. You take any two terms, right? Suppose this is your 1, 2, 3, 4, 5, 6, 7. T7 minus T6 is 2. T5 minus T4 is also 2. T3 minus T2 is also 2. Everywhere, the difference is fixed. Right? This type of thing we are going to call an arithmetic progression. Are we clear? Did we understand this? Now, let's attempt this question. Take a look at this question and tell me third, fourth and fifth term of a sequence where instead of T, they are using A. Don't get confused, okay? Instead of T, they are using A. Okay, so T1, T2, instead of T1, T2, they are using A1, A2. If you have trouble looking at this, this is nothing but Tk plus 2. Instead of N, they are using K. Now, at this level, if you are preparing for an Olympiad and if you are aiming higher mathematical concepts, then variables shouldn't bother you. They are just data boxes. Okay. So, we were using T and N. They are using A and K. No problem. Okay. Come on. Tell me third, fourth and fifth term of this sequence. Come on. Very good there. Amazing. Wait, huh? Here, right? Wait, what is this saying? This is saying, if I write in T and N terms, this is saying Tn plus 2 is equal to Tn plus 1 plus Tn. This is what it is saying. Correct? What? Right? And T1 is already given to me and T2 is already given to me. 2 is already given to me. 4. And I also know that K or N is greater than equal to 1. N is either 1 or greater than it. Okay. So if I put T, N is equal to 1, let's say. If I put N is equal to 1. So T1 plus T1 plus 1, that means T2 is equal to T1 plus 2, that means T3. So what will be T3? T3 will be equal to 4 plus 3. That means 7. So T3 means third term. T3 means third term. T1 means first term. T2 means second term. A1 means first term. Here, I don't get confused. I'm just doing this to make you familiar with what we learned. Okay. So T1, T2, T3 we have. Getting my point? So we have T3 now. Now what will be T4? T4, put n is equal to 2. If I put n equal to 2, then T 2 plus 2 will be equal to T 2 plus 1 will be equal to T 2. This becomes what? T4 will be equal to T3 plus T2. And we have T2. We have T3 also. So T4 will become what? T3 we have 7 and T2 we already have 11. What will become T4? T4 will become 11. This is my T3. T3 I got as 7. What is T4? T4 I got as 11. Can you now tell me T5? What will be T5? T5 will be T4 plus T3. T4 is 11 and T3 is 7. My T5 is going, this is nothing but Fibonacci only. Are you getting it? This is nothing but Fibonacci only, starting with 3 and 4. Huh? This is Fibonacci only. So Fibonacci can be written in any form. Rule is fixed. Correct? This is nothing but Fibonacci only. That's what we just saw it. Okay. So 3, 4, 7, 11, 18 and 18 plus 11, you can as many terms as you want. So T5 will become your 18, 11 plus 7. Right? So you must be able to understand the rule and decrypt the rule. Right? Also to be able to write the rule. All the things we have to get good at. All right. Now let's study type wise, so that some of the sequence will some of these sequences and some of these recursive sequences will be in the form where you'll have to understand them type wise. Right now there can be a complete study on different types of series. The most used or the most commonly occurring type of progressions or recursive series. Arithmetic progression is also recursive sequence or recursive series. Why? Because it is going to depend on a rule. What rule? Just now we discussed, where successive terms are obtained by adding a fixed constant number to the preceding term. The preceding term. A fixed constant number will be added. Just now we saw no minus half, 0, half, like that. Okay, 2, 4, 6, 8, 10, 3, 6, something like that, right? 2, 3.5, 5, 6.5, 8. This is also an arithmetic progression. What is the common difference? Common difference is 1.5. Common difference is 1.5. Every next term, every successive terms is obtained by adding a fixed constant number to the previous term. That's it. Okay, getting my point? Right? A fixed term to the previous term. So this is how. Now let's generalize this. Now what are we going to do? We'll just generalize this thing. For example, let's say if my first term has A, let's say this is what I'm calling as my first term. Let's say this is my first term. Okay, this D is my common difference and D is my common difference. Okay, so first term, if my first term I'm taking as A, next term will be A plus D. Third term will be A plus D plus D. I'll again add D. Common difference is D, na? Yes, you can crack in 3 months. Not a problem. Okay. A, common difference is D. So I added D. Again, I'll have to D. So next term will be A plus 2D. Again, I'll have to add D. A plus 3D. Again, I'll have to add D. A plus 4D. Right? 3D plus D, 4D. Like this. So this is my first term. This is my second term. This is my third term. In third term, 2D is coming. In fourth term, 3D is coming. In fifth term, 4D is coming. In 10th term, what will come? 9D. Correct? In 11th term, what will come? In 20th term, what will come? A plus 19D. This will be my 20th term. This will be my 20th term. Yes or no? This will be my 10th term, T10. This is what? This is my fourth term, T4. right? Okay. Now this, if I want to generalize this, let's say I want to write 100th term. So 100th term will be a plus 99d. This will be my t100. Yes, this will be my 100th term. Correct? This will be my 100th term. Any general term. Now I am going to write general term. General term means any term. General term. So what will general term become according to you? What do you think? What do you think? What will general term become? What will be a general term? If I want to just, so first term a, second term a plus d, third term a plus 2d, fourth term a plus 3d, 10th term a plus 9d, 100th term a plus 99d. So nth term will be nothing but a plus n minus 1 into d. A plus n minus 1 into d, na bacha? Why? Because see, 100th, for 100th term 99 is coming here. If I take n as 100, so 99 should come here. If I take n as 10, so 9 is coming here. If I take n as 4, so 3 is coming here. Okay. If I take n as 20, so 19 is coming here. If I take n over here, then n minus 1 should come. N minus 1, correct? Right? So any general term, if I want to write, that will look like this, a plus n minus 1. Right? That has to look like this, a plus n minus 1. Okay. This is, what is this? This is an, or we can call it tn. Nth term, general term. If I put n as 1 over here, if I put n as 1, this will become a plus 1 minus 1 into d. That means a plus 0d. That means a, first term. If I want second term, then I need to put n as 2 over here. So it will become 2 minus 1. That means 1 into d. So a plus d. If I put n as 3, that means I want third term. Here what? Here n is equal to 1. Here n is equal to 2. Here n is equal to 3 in the same general term form. Okay. Okay, ji. This is here what? N is equal to 4. Correct? Every term can be obtained by this formula. What does A represent here? A is your first. And what does D represent here? Common difference. Common, we'll call it common difference. Now the question is, what does N represent? N represents the position. N represents position of the term. So can your N be 0? Can there be 0th position? No. N cannot be 0. Can N be fractional? Can you tell me where is 1.5th term over here? Or can you tell me where is 10 and a half term over here? No. N has to be natural. N has to be a natural number. Always. Always N has to be a natural number. There is no other go. Did you understand my point? Yes or no? You are going from two basics. I liked it. Obviously, beta basic. N has to be a natural number. Now, if N is a natural number, can you check that, suppose if this is an AP, is this an AP? Yes, we can check. 18 minus 21. How to check if there is an AP or not? You just check the difference of any two successive terms. So 18 minus 21 is minus 3 and 15 minus 18 is also minus 3. So difference is constant and fixed. This is an AP for sure. Now you have to check, will minus 351 come in this AP or not? So we know that any general term of an AP is a plus n minus 1 into d, where n belongs to a natural number. N has to be a natural number. Okay, okay ji. Now if n has to be a natural number, now I want to check whether minus 351 is here or not. If I put, let's say minus 351 is a term, right? Let's say minus 351 is a term. For example, here I know a is equal to 21. Here I know d is equal to minus 3. What is d? D is minus 3. It is a decreasing progression. It is a decreasing progression, right? It is decreasing. So d will be negative, right? It is decreasing, so d will be negative. Correct? Here you can write increasing AP. If we have an increasing AP, Increasing AP means D is greater than 0. Okay. Decreasing AP. What do we mean by decreasing AP? Decreasing AP means D will be less than 0. And constant AP. What do we mean by constant AP? If only 2, 2, 2, 2 are written, then D will be equal to 0. That means D will be equal to, Arey bhai, if I write just 2, 2, one number only, what is this not an AP? It is also an AP. Common difference is 0. Da. Not a problem. Okay, ji. Uday is saying 125th. Okay. So minus 351 will be there or not, we have to check. For example, here, if I want T1, T1 will be what? A, that means 21 plus N is what? What is N? N is 1. So 1 minus 1 into D. D is minus 3. So it is equal to 21. T1 is 21. You can check. T2 is what? T2 is what? A, A in this formula only. A, that means 21 plus N is 2. So 2 minus 1 into D. D is what? Minus 3. Okay, so this is 21 minus 3, that means we are getting 18. So you see T2 is 18, T1 is 21. So now I'm saying, let's say that Tn some term is minus 350. I'll say some term is minus 351. A is 21 plus N, I don't know which term, I don't know the position. N tells you what? N tells you the position of the term. N tells you the position of the term. Getting my point? Yes or no? N is the position of the term. This is a strong point. Looks very easy to grasp, but yeah, sometimes we forget the idea that n is telling you the position of the term. It cannot be fractional. It cannot be negative. It has to be natural number. Okay, ji. So now we'll see. Now what is D? D is minus 3. So we'll multiply minus 3 over here. Let's solve this. Minus 351 minus 21 divided by minus 3 plus 1. This should be your, this should give you your, this is your n. This is what? This is your n. And check whether this is coming a natural number or not. So what are we getting? 372 minus 372 divided by minus 3 plus 1. Check. Minus minus cancelled. 1, 2, 1. Very good, Uday. 125th term. Yes. Minus 351 is there in this AP and it is going to be 125th term. Okay. 125th term. Minus 351 is going to be there in this AP and it is going to be at the 125th position. It is going to be at 125th position. Now in the similar way, can you check, is 0 a term over here? Is 0 going to be a term of this AP? Come on, check it quickly. Is 0 going to be a term? Is your next class on next Monday? Yes, bacha, next Monday. Not next, I'm not sure. Okay, it can be in this week also. I'll have to check the schedule, how they have scheduled it. I have no idea. So I'll check. Okay, is 0 going to be a term over here? No. Very good. Very good. ये तो सर देख के ही पता चल रहा है ना, सर देख के ही पता चल रहा है. 0 is not going to be a term because you see odd even is going to be followed. What is A over here? A is equal to 31. What is D over here? D is equal to minus 3 again. So we'll check. 0 is equal to A plus N minus 1D. That means 31 plus N minus 1 into minus 3. And this is going to give us N 31 minus 3N plus 3. That means 3N is equal to 34. N is not natural. 34 by 3 will not be a natural number. Na? So 0 is not a term. 0 is not a term. 0 is not a term. Okay, ji. Now let's, okay. Now suppose if they form a word problem out of it. When did a polynomial? You'll have to check on the channel. Anji, if fourth term of an AP is 3 times the first term and seventh term exceeds twice the third term by 1. This is the statement. Okay, ji. Find the 11th term. Come on, I'll give you a minute for this. Take your time, I'll give you a minute for this. You can take a minute for this question. Why? They have said fourth term. Now you start writing like this. Hai na? You start writing like this. Fourth term means T4. A4 or T4. Fourth term of an AP is equal to 3 times the first term. 3 times the first term. What is the first term? T1. This is one thing. Okay. Fourth term of an AP, that means T4, is 3 times the first term. This is an AP. This is also given to us. This is an arithmetic progression. Okay, this is an arithmetic progression where the difference is going to be fixed. So T4 is 3 times T1, and seventh term exceeds twice the third term by 1. If you have difficulty in understand, sir, can we assume n will never come? Obviously. Arey Baba, Arnav, hey, what are you doing, man? How many times I repeated, bacha? N is position. N is position, so n will never be decimal, never be fraction, never be zero, never be unreal. N will always be natural. Remember that. Okay, n has to be natural. N is position. By first, second, third, fourth, fifth, 5.5th term. What does that mean? Minus third term. No. Zeroth term, zeroth position. No. N has to be natural only. So T4 equal to 3 times T1 is given to me. Second thing which is given to me, pay attention. Seventh term exceeds twice the third term by 1. Acha, tell me, 10 exceeds 4 by 6. So how will I write this? 10 is equal to 4 plus 6. When I'm saying 13 exceeds 8 by 5. So how will I write? 13 is equal to 8 plus 5. If I say 10 exceeds 4 by twice of 3. So how will I write? 10 is equal to 4 plus 2 into 3. Correct? Correct, correct, correct. Or if I say 10 exceeds 6 by twice of 2. So 10 is equal to 6 plus 2 into 2. So when I'm saying seventh term exceeds twice the third term by 1. That means twice the third term by 1. Okay, by 10 exceeds 8 by 2, so 10 is equal to 8 plus 2. 10 exceeds 5 by 5, so 10 is equal to 5 plus 5. है ना? Minus 7. I don't know. Not, I don't remember the answer. Let's see. Third term by 1. Did we clear? Did we understand both the statements? Both the statements we understand. Now it's the game of just the solution. T4 will be what? A plus 3D. How will we write fourth term of an AP? A plus 3D. How will we write first term of an AP? A only. First term is A. Okay. Okay. And from here, what will we write? T7 means A plus 6D. Right? Is equal to 2 times. T3 means A plus 2D. Right? Third term, that means 3 minus 1D. General term is what? What is the general term? A plus n minus 1 into D. General term. Right? So T7 will be A plus 7 minus 1 into D. That means 6D. T3 will be A plus 3 minus 1 into D. So A plus 2D plus. This is one. So let's solve. So from here, what are we getting? From here, we are getting 3D is equal to 2A. Okay. This is what we are getting. 3D is equal to 2A. Let's do over here. So A plus 6D is equal to 2A plus 4D plus 1. Okay, ji. So this will become 2D. This side is equal to A plus 1. A plus 1 and 2D. Aha. Okay, so this will become 4D if we multiply this by 2. Just multiply same thing by 2, na? If I multiply same thing by 2, what will I get? 4D is equal to 2A plus 2. Both sides I have multiplied with 2. Why did I do that? Because I know 2A will be equal to 3D. And now I'll substitute over here. So my 4D will become 2A is equal to 3D. So it will become 3D plus. So from here I am getting that my D is nothing but equal to 2. If my D is equal to 2, if my D is equal to 2, my A will be equal to what? A will be 3 times, what, correct? This again I am putting over here. So D is equal to 2, that means A will be equal to 3 into 2 divided by, that means 3. A will be nothing but, first term is 3, common difference is T. For any arithmetic progression, you just need first term and common difference. Now, if my common difference is positive and first term is positive, you only tell me, can my 11th term or any term be negative? Can any term be negative, da? No. Understood? Where did we do the mistake? Or have I done the mistake? You only tell me. I don't think. All good, na? A is 3, D is 2. How are you giving negative answer? Find 11th term. 11th term means T11. That will be equal to A plus 10 into D. That means 3 plus 10 into 2. That means 23. Positive, na? No, I did wrong calculation, I think. Uday, negative 23 or positive 23, da? Huh? Mm-hmm. एक minute, let's see. 6 minus 4, 2D. 2A plus minus A. Correct only. Answer checking, huh? Answer is 23. Yes, positive 23 only should be. D won't be negative. Okay, ji? D won't be negative. Correct answer is 23. Are we clear? Are we clear? Or do we need any explanation ahead? Let's go ahead. Now, this is one type of question which is frequently asked, or which now obviously IOQM is not a piece of cakes. They are not going to or it's not like JEE means, or if it's not like a Olympiad which is going to give repeated type of questions. Okay, every time they are going to change the pattern of their questions. But the questions, how do PYQ help in IOQM? How do PYQ help in IOQM? When you do PYQs, you understand the connection. You understand the mapping, that if this type of thing comes, I have to use this trick, or I can do this. For example, try doing this question. If sixth term of AP is 5, then I'll tell you a short trick to do this. If sixth term of an AP is 5 and fifth term of an AP is 6, then what will be the 11th term of that AP? What will be the 11th term of that AP? This is what you're supposed. What will be the 11th term of that AP? If sixth term of an AP is 5 and fifth term of an AP is 6, then what will be the 11th term of an AP? It's from Hall and Knight. Yes. Yes. Hall and Knight for algebra is the best. Okay, T6 is equal to 5 and T5 is equal to 6. This is what is given. So this is what tells me, this tells me A plus 5D is equal to 5, and this tells me A plus 4D is equal to 6. Okay. What will be the 11th term? I need to find T11. What will be the 11th term? What will be the 11th term? So I have two equations, first equation, second equations, two equations, two variables. Shouldn't be any problem to solve. Just subtract both of them. You are getting D is equal to minus 1. Subtract 1 and 2. First minus second if you are doing. You know how to do this, right? First minus second, A minus A 0, 5D minus 4D, D 5 minus 6 minus 1. Okay, D is equal to minus 1. If D is equal to, very good. I think Aditya's and Kumar's answer should be correct. Okay, D is equal to minus 1. Now, if D is equal to minus 1, I'll put anywhere. A plus 5D is equal to 5. So, A plus 5 into minus 1 should be equal to 5. So, A should be equal to 5 plus 5, that means 10. If A is 10, then 11th term will be A plus 10D. That means 10 plus 10 into minus 1, that means 0. That means 11th term is going to be. Okay, now the trick. Now the trick. Note it down that in any AP, if pth term is given to you as Q and qth term is given to you as P, then P plus qth term will always be equal to 0. Will always be equal to 0. See, sixth term is 5 and fifth term is 6. So 6 plus 5, that means 11th term will be equal to 0. Okay. Suppose if there is an AP whose third term is equal to 2 and second term is equal to 3, then T6 will be equal to 0. T5. T5 will be equal to, okay, if T10 is equal to 11 and T11 is equal to 10, then T21 will be equal to 0. Getting my point? When will the class end? Beta, I'll end when I feel like, don't worry. Not very long I'll take. I'll not take very long, hardly 1.5 or 2 hours. 1.5 or 1 hour 45 minutes, somewhere around that I've planned. Don't worry, I won't stretch it, right? But please stick and learn. Okay. Suppose if T21 is equal to 25 and T25 is equal to T is equal to 21, then T46 will be equal to 0. Understood? But T10 is 11, T11 is 10. If Pth is Q, Qth is P. T21 is 25 and T25 is 21. Then T21 plus 25 will be equal to 0. T46 will be equal. T10 is 11, T11 is 10. So T11 plus 10, that means T21 will be equal. So always, you can prove this. T3 is equal to 2, T2 is equal to 3, then T5 will be equal to 0. You can prove this also. Very easy to understand. Okay. One rule. Will you remember this? In any AP, if this condition comes, then the sum. Okay. This is one trick. Now another type of question. Suppose if pth term is Q, suppose they are giving you T10 equal to 11 and sorry is equal to let's say 15 and T15 is given to you as 10. Pth is Q and Qth is P. Now they are asking you some random term. Suppose they are asking you any term. And if they are asking you T26, so T26 will be nothing but P plus Q minus 26. That means 10 plus 15 minus 20. That means T26 but minus 1. You can see it is a decreasing DP, decreasing GP. Sorry, decreasing AP. 10th term is 15, 15th term is 10, so it is decreasing. Only for AP. Yes or no? This rule, these both rules are applied only for AP. What is written? If pth term is Q and qth term is P, then rth term of same AP, any term, any general term, rth term of that AP will be P. Any general term, Tn will be equal to 10 plus 15 minus n. हाँ बिल्कुल yes Viju. Differentiation, chain rule, product rule, basic differentiations, if you know, then you should start AOD. Definitely you can start. Huh? You can start continuity differentiability basic also if if you have, then it's okay. You can. Good evening, sir. Anji, Ayush Sharma. Good evening, Ayush. Correct. This trick, very these both of these tricks, you know, can save a lot of your time. A lot of your time. Right? If there is any AP who's, let's say, one more example, let's say T27 is equal to 54 and T36 is equal to 20, and T54 is equal to 27. Suppose this is the, then what will be T100? T100 will be nothing but 54 plus 20 minus 100. Yes, and it will be decreasing. You can see 27th term is 54, 54th term is 27. Correct? Understood? A lot of examples I've given you. This is a good trick. Let's suppose T12 is equal to 5 and T5 is equal to 12. Then what will be T10? T10 will be nothing but 12 plus 5 minus 10. That means for this AP, T10 will be nothing but 17 minus 10. That means direct answer you can get. Direct answer you can get. Okay. So two tricks. Now, which term of this sequence is minus 403? They also find which term, if any, will give minus 500. Chali, solve this. Solve this. Right? There is a sequence. They didn't tell us that it's AP or GP. They are only saying sequence. So first we have to check whether this is recursive AP or not. I mean whether this is AP or not. Okay. After checking, you need to check minus 403 will be a term or not. Right? If minus 403 is a term, then tell us minus 500 is there or not. Come on. -3, -7, -11. -7 minus -3. How much? It is, na? It is. It is AP. Is it AP? -3 plus -4 is -7. -7 plus -4 is -11. -11 plus -4, -15. AP. Irka. This is an AP. -3, -7, -11, -15. This is an AP. Okay. A is equal to -3. D is how much? -7 minus -3. That means -7 plus 3. So D is minus. Okay. D is -4. Preceding term, succeeding, term minus previous term. Okay. So this is the case. So now we'll check -403 is equal to A plus N minus 1D. A plus N minus 1D. This is the formula for general term, any term. So we'll check -403 is equal to -3 plus N minus 1. We don't know N. What is the position? We don't know. D we know -4. Okay, not a problem. -403 plus 3. So this will become -400 is equal to -400 divided by -4 is equal to N minus 1 will get minus minus cancel 100. N is equal to 101. It is completely natural. That means 101th term will be 403. Now we'll check -500 is there or not. Check. Okay. In one question only. So -403 is the 101th term. And which term will be -500? Which term is -500? You can check that also. Which term is -500? When we'll put -500 in the formula, N will come out to be as 501 by 4, which is not natural. That means -500 is not a term. It is not a term in this particular AP. 124 tha. How? Are you serious? Let me check. Hey, these people are wrong. Kya? -500 is equal to A, that means -3 plus N minus 1 into D. D is -4. Okay, ji. -500 plus 3, that means -497 divided by -4 plus 1. This thing cannot be natural. -497 won't go by 4. This is not natural. How 155th? 125th? Hey, Kumar, Aditya, what are you doing? How is this? Oh, not natural, na? Not natural. -500 won't come. D is -4. -500 plus 3 -497 divided by -4 plus 1. This plus 1 will be equal to N. Okay, ji? Now, there is one more type of sequence. We are going to go on sum of sequence. But before that, the other type of sequence which we'll start with is geometric progression. So now in the upcoming classes, we'll understand some of these sequences, some of the terms. Basically, sequence is just numbers separated with comma, right? Recursive sequences, numbers separated with comma, but following a rule. Recursive series is numbers separated with addition sign, okay, separated with addition sign and following a pattern. Okay, recursive series. So series means addition of terms. Sequence means just terms. Recursive sequence and recursive series along with that. Okay. So from the next classes, from the coming classes, we are going to study about the sums, how to add the sums and other different types of series, other different types of sequences which we can have. Like one is geometric type of series we can have, arithmetico-geometric, or there is a lot of it. There is a lot of it which I have planned. All the types of series and some PYQs of IOQM are also going to be there. Some PYQs also have attached, which are from the sample papers or previous year papers of PRMO and IOQM. We are going to completely research this topic, recursive series. So last class we learned about arithmetic progression. We started learning about arithmetic progression. We learned how do we write a common term of any type of series. We learned how do we uh, generalize a series. Sir, can you give the proof of sum of first n terms of AP? Definitely, Shreyansh, we'll do that. We'll do that. Okay, don't worry. We'll do everything. Okay, now let's So we saw a lot of type of sequences, and then we jumped on to arithmetic progression, which is a very commonly known and which is very useful arithmetic progression. All right. So now we know that Tn, we'll get this formula, guys. We'll get this formula which is written so for sum of n terms. We'll get it with a lot of means. Right. Stick with me. You'll get to learn a lot today. Now, general term of any arithmetic progression. What is arithmetic progression? In which there is a first term and there is a common difference. What happens? We keep adding the difference, right? So terms are like this: a plus 3d, right? Just like this: 3, 7, 11, 14, 17, 21, like this. Okay. First term is 3, common difference is 4. So 3 plus 4, 3 plus 8, 3 plus 12. Oh, sorry. Wait. Did I make a mistake over here? 3 plus 4, 11, 15 would be here. 15, 19, 23. Right? So this is A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D. What is D? D is over here is 4 and A is nothing but 3. This is what we learned in our last class. Remember? Sir, from Alan, missing you. Arik. Nice. Nilajit. Uh, great. Thank you, man. That's a good thing about a teacher. This is the most gratified thing we find in this job or this career, that our students do remember us. Anyway, come on, let's see. So A and D, understood, right? This is how it works. So common term, any general term, A plus n minus 1 into D. This is what we learned. Correct? This is what we learned. What is A over here? First term of AP. D, common difference. A and D can be anything, right? Real numbers, any real numbers. N has to be a natural number, right? N is the term. For example, of this series, if I want a sixth term of this series, so sixth term will be T6 will be 3 plus 6 minus 1 into 4, right? So 23 would come. You can see that. This is what we learned. Now let's understand what if we have to add the terms. Okay, first term is A again, right? Second term is A plus D. But now this time I'm not separating them with commas. I'm going to use this A plus D, then A plus 2D, then A plus 3D. This is how I'm going to add these terms. Are you getting the point? A plus n minus 1D till some general term. I don't know what is n. I don't know what is n. Sir, which center did you teach in, Alan? I've taught at many centers, bro. Sikar, Kota, Bangalore. Chodo na, leave it. That's not the topic right now. Leave it. Even out of India. Okay. Yeah. Okay. So A plus D, A plus 2D, A plus 3D, A plus n minus 1D. This is what we write the sum as, right? These are the terms. Okay. Any n is, I don't know what is n. N can be 10, 20, 50, 30. N has to be a natural number, obviously, because number of terms will be natural only. So sum of n terms, this is what we have. This is how we are going to write. Now what am I going to do is, I'm just going to write the same thing but ulta. Why? I'll just change the order of these things, and how magically something good will come out. How? See, if I write first term as A plus n minus 1D, I'm writing it ulta, I'm writing from there. Second term would be A plus n minus 2 into D, obviously. Correct? No? No? Second last term, what will be second last term? N minus 2D, no? Do you get this? Correct? Second last term will be n minus 2D. Yeah, sir, no problem. We can understand. A plus n minus 3D would be your third last term. No problem, sir. This is what it is going to be. So, see, in this series itself, if I do n minus 2D, right? So, 6 minus 2 would be 4, 4 into 3, 4 into 4 would be 16, 16 plus 3 would be 19. So, this term would come, second last would come, right? You can realize it like that, n minus 2D. So, now like this, chalte chalte, we'll have A plus D, and last term would be A, right? Last term would be A, correct? No. Now what am I going to do? You see, now I observe that yaar, over here, bro, there is something good. There is something which I can use if I club these terms. Look at this. I'm adding the first term with the last term, second term with the second last term, third term with the third last term, right? Fourth term with the fourth last term. I don't know fourth last term, which one is that? But last term, I'm going to add with the first term. But how did I get this idea? Why did I get this idea? Sir, who told you that, how would a person would come up ki yaar ulta likh do? We'll write it ulta and the terms will add up and some formula will come. First, let's see what's happening. Okay, first let's see what's happening. Why are we writing ulta and what benefit is it giving us? Right? So this side, if I add, I have two equations, same thing only. No, I can double it. I can add this side. If I add everything up, this side I'm getting 2 times of sum of n terms. Right, you understand, right? Sn means sum of n terms. I'm representing this sum as sum of n terms. Tn is a term, general term. Okay, 2 times of sum of n terms would be equal to, what is this plus this? Sir, this is 2a plus n minus 1 into d. No problem. What is this plus this? Just check. A plus a, 2a, d minus 2d minus d. Okay, so again I'll get nd minus d, that means n minus 1d, right? 2a plus n minus 1 into d. Correct? What is this plus this again? A plus 2d plus a plus n minus 3d. This will also come out as 2a plus n minus 1 into d. All these sums. In fact, the last one also. 2a plus n minus 1 into d. Magical, right? Amazing thing. So now what is this? Okay, this is same thing getting added with itself. How many times? We have n terms. So this same thing is getting added to itself n times. N times it is getting added to itself. Correct? So sum of n terms. Now, okay, I'll write 2 times sum of n terms. So say if you add 4 100 times, it will be 4 into 100. If you add 10 20 times, it will be 10 into 20. If you add 1 n times, it will be n into 1, that means n. If you add the same thing n times, how will you write that? How will you write that, guys? N multiplied with this same thing, 2a plus n minus 1 d. You got your formula. Sn, sum of n terms is nothing but n divided by 2 multiplied with 2a plus n minus 1 into d. Wow. Correct? You got this. How simple? Nothing we did. But the question still remains the same. No, divide both sides by 2. Yeah, divide both sides by 2, or you are just simply taking this 2 because this is in multiplication over the left side. So you are taking it in the division over the right side. Nothing major you are doing. Okay, but you are making a formula for sum of n terms of a sequence, of a recursive sequence, which is AP, where first term and common difference is there. Correct? Right? Getting my point, guys? But again, my question remains the same. How this idea came? How this idea would have come? And what is this idea telling you? Now, this same formula I can write one more way. Right? I have 2a, no? I have 2a. I have twice of a. So, I'm going to write n by 2 and I'll split this a as a plus n minus 1 into d. 2a was there. So, I write it like this. Now, why did I do this? Because I realized that this thing is nothing but any general term. This was the formula for any general term, right? Tn. So yes, correct. You guys are, if you are thinking what I'm thinking, then you are correct. N by 2 multiplied with a plus. Now some people think that this is a plus l, last term. Not last term, I would say. I would say any term. Suppose Tn, write it as Tn over here. So suppose if we are finding sum of 20 terms, okay, if we are finding sum of 20 terms, we are coming to it, Darsh, AGP also we are coming, okay, just hold on, okay, understand this thing very carefully, because this formulas, this derivation is telling you a lot of things. It is a lot of things which this formula is going to tell you. How? I'll tell you. See, you realize n by 2 into a plus tn. Now, if you are finding sum of 20 terms, it will be 20 by 2 into a plus t20. T20 cricket wala nahi. T20 means 20th term. Okay, T20 means 20th term. If you are finding sum of 100 terms, then it will be S100 will be equal to 100 by 2 into first term plus 100th term. Okay, learn it like this. Understood? Now again, coming back to the question, how this idea came. Now when I look at that any AP, if I look at any AP, I realize that, yeah, this particular term and this term, if I add them up, I get 26. If I add these two, also I get 26. I get these, add these two, I get 26. Oh my God. This is how I realize that I can derive a formula for sum of n terms. Why? Because equidistant terms in any part of the AP. Achha, chalo tell me, if this AP, it has 100 terms. If this AP has 100 terms, 6 terms will also make an AP, na? If I take a part of AP, that will also still be AP, right? If I take a part of arithmetic progression, it will still be arithmetic progression. So any part you can take, that will still be arithmetic progression. You realize that equidistant terms are always the sum of equidistant terms are always equal. If I write some more terms, 3, 7, 11, 15, 19, 23, 27, 31. Okay, if I do this, then also this thing is same. Equidistant terms. 3 plus 31 is 34. 27 plus 7. 34, 34, 34. Equidistant terms, the sum of equidistant terms in arithmetic progression will be same. And this is how I realized, arey yaar, I'll just write it ulta. What's the problem? Okay, I'll just write it ulta. What's the problem? I'll get sum of n terms formula. And then comes a question. Try this. This came in mains. Okay. Now, for this question, one more information you'll require. What? Sir, one more thing we need to observe about AP. Okay, one more thing we'll need to observe about AP. Suppose if I write just terms like this, A plus n, A plus D plus A plus 2D plus A plus 3D, or let's say like this, A plus D, A plus 2D, A plus 3D, okay, A plus 3D, A plus 4D also I'll write, no problem, A plus n minus 1D. Okay, this is an AP, right? These are the terms of an arithmetic progression. I realize that. Now you see, one more thing you can notice. What, sir? What will be sum of n terms? We just now realized, sir, it will be n by 2 multiplied with 2A plus n minus 1 into D. Correct? Okay. Let's 3. Some terms also I'll write so that you'll realize very better, right? 11, 15, 19, 23, 27 and 31. Okay. Now you see, if you add 4 terms, how much is it? 15 plus 11, 26, 26 plus 7 would be 33, 33 plus 3 will be 36, right? Sum of 4 terms is equal to 36. Sum of 3 terms is equal to what? 7 plus 11 plus 3. That means 21. Okay. What if I do sum of 4 terms minus sum of 3 terms? What am I getting? 36 minus 21 equals 11. 15. Right? Do you realize that? Sum of 4 terms minus sum of 3 terms is 15. That means S4 minus S3 is giving me 4th term. Why is it happening? See, if you add 4 terms, right? If you add 4 terms, sum of 4 terms will be, sum of 4 terms would be, in this formula also if you will do the same thing, no, sum of n terms minus sum of n minus 1 terms will always give you the nth term. This is the formula. This is what I'm trying to tell you. If you get the sum of 10 terms minus you do the sum of 9 terms, you'll get the 10th term. Obviously, bhai, if we are adding, suppose how many terms are there? 3, 3, 6, 8. If I'm adding 8 terms, till here I'm adding, till 31 I'm adding, and I'm subtracting the sum till 27. Which term I'm going to get? I'm going to get 31. That means if I add sum of 8, if I find sum of 8 terms, and from that if I subtract sum of 7 terms, I am going to get the 8th term. So sum of n terms minus sum of n minus 1 terms will always give you the nth term. Amazing. This is also beautiful. This is also something which we can realize, and we can derive this also. We have Sn formula. Just in this formula only put S of n minus 1. So you'll get this form. Okay, you'll get same formula. Nothing, no problem. Directly you'll get the same formula. Right? Now, yeah. Okay, it is saying sum of n terms denote the sum of first nth terms of an arithmetic progression. Okay, Sn denotes the sum of first n terms of an arithmetic progression, and it is saying that sum of 10 terms is equal to 530, and it is saying sum of 5 terms is equal to 140. Okay, it's just equation solving. Can you find S20 minus S6 for me? Can you find S20 minus S6? Yeah, Shreyansh. Can you find S20 minus S6 for me quickly? What would you need? Sum of 10 terms, you'll put 10 by 2 multiplied with 2a plus 10 minus 1. That means 9 into d. Correct? N minus 1, so n is 10. Then you'll do S5 equals 5 by 2 multiplied with 2a plus 5 minus 1. That means 4d. Not a big deal. Okay, this is also 5. Right? This is given to you as 530. This is given to you as 140. You'll just solve and get your answer. So from here, at what are we getting? 530 divided by 5. 10s are 53, 106. 106. So you'll get 2a plus 9d is equal to 106. And you are going to get 2a plus 4d is equal to 18. Oh, 28. Sorry. Right? You'll just subtract it and find d. Subtract both the equations and find d. You know how to do it. What will be d? 5d will be equal to 106 minus 28. Alright. Can you find your answer? A is equal to what? Come on. Okay. 78 by 5 will be your d. And then A is going to be, as Shreyansh is saying, 8. Correct. This should be your answer. 1862. Most of you said the same answer. Correct, 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 correct. Not a problem. Arey, D is 10. Did we do a mistake? 106 and we didn't do anything here. We solved it. Acha, 5 by 2 it was. 280 by 5. So 280 by 5. Here we did a mistake. 280 by 5 it will be, no? 56. Now it's correct. 5D is going to be, D is 50. D is your 10. D is coming out to be as 10. Right? If D is 10, then 106 minus 90, 16 will be your A. 8. 8 will be your A. Right? You got A and D. Now you can do anything about this. S20 minus S6. Again, you can find with the formula. Right? Understood? Correct, 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 correct. Any problem? See how easily we could solve this question. Just a simple manipulation of some formula and we could solve an easy question. Right? This was definitely an easy question. Now the thing is that let's move on to a different type of question. Just a minute. Okay. Let's try and do this. How many more days will sequence and series finish it? I think 2 more classes max. All right. Sum of n terms. Realized? Understood? Now, this is saying in a sequence Sn is given to you. Sum of n terms is given to you. Then find the nth term of that sequence for a sequence where Sn is given to you. Now, first question which should come into your mind is, sir, how do we know that it is arithmetic sequence or arithmetic progression? Obviously, that question should come into your mind. Yes or no? Sir, it's written for a sequence. We don't know which type of sequence, no? We don't know which type of sequence, do we? Do we? We don't know. Obviously, we don't know. Okay? Do you know? We don't know, but we recently found a formula for sum of n terms of an AP, n by 2, multiplied with 2a plus n minus 1 into d. Now, in this same formula, if you see, if we take n common, then we have 5n plus 3. And 5n plus 3 can be a general term of an AP only, arithmetic progression only. Why? Because a general term of an AP will always be linear and sum of n terms of an AP will always be quadratic. The formula, the expression for sum of n terms of an arithmetic progression will always have a degree 2. That means it will be quadratic. Understood? Remember this. Sometimes they might give you directly sum of n terms of a sequence and it will be written like this, something like this. You have to realize that, yeah, if it is quadratic, then definitely AP, right? And in this also, this particular thing, 5n plus 3 is the general term. AMG, everything, bacha, everything will study. Okay, this is the general term. 5n plus 3 thing, no? This is your general term of that particular AP. Okay, this is how you know, right? So by looking at the expression only, you can say, yeah, this is an arithmetic progression sum of n terms formula. And if they are asking you to find the nth term of the sequence, then we also know one more thing, that Tn is nothing but Sn minus Sn minus 1. Sum of n terms minus sum of n minus 1 terms. So Tn will be nothing but in the same formula, 5n square plus 3n is my sum of n terms. What will be sum of n minus 1 terms? 5 into, instead of n, I'll just replace it with n minus 1. Sum of n terms, sum of n minus 1 terms. What's the problem? Right? So this ka square plus 3 into n minus 1. And when I solve it, I'll get the formula for Tn and definitely it is going to be linear. Okay, we can check also. This is what 5n square plus 3n. Okay, let me write it here only. So this will be 5 into n square plus 1 minus 2n plus, okay, 3n to n, 3n minus 3. Okay, so now 5n square plus 3n minus 3n gone. This will be 5n square minus 5n plus 10n plus 3n minus 3. 3n gone, 5n square gone. This is nothing but 5n minus 3. 5n plus 3. Here minus minus became plus, no? 5n plus 3. You see, that's what we realized. We could have given it directly. The answer could have been given directly over here. N common, 5n plus 3. Correct? है ना? Bolo, yes or no? Yes, yes, yes. Are we clear? Direct answer we could have given if the formula is written, if some expression of Sn is written. We got our marks. All right, Ji. All right. Okay, one more thing, and then we'll talk about what if a sequence has common terms, because they can ask you about common terms, questions on common terms also. Before that, an easy question again. First and last term of an AP are 1 and 11. If the sum of its term is 36, then the number of terms will be equal to what? Wow. It's an easy peasy. It's an easy peasy, yes or no? First term and last term are given to you. Sum of 11 terms will be equal to what? Sum of 11 terms I taught you. It will be equal to 11 by 2. Two formulas we learned. 2a plus n minus 1d and first term and last term. That means T11, 11th term. That's why I'm saying. Remember this formula like this. So sum of 11 terms is nothing but 11 by 2 multiplied with first term is given 1 plus T11. T11, 11th term. Okay, 11th term. T11 is given to me. All right. And sum of first and last, first and last term are 1 and 11, and sum of its 36 terms. If the sum of its 30, if the sum of its terms is 36, not 36 terms, sum of its terms is 36. That means 11 terms are only there. If they are saying last term is 11, so do we know that have I written it correctly? Whatever I have written. Acha, of last question. Have I written it correctly? Can you tell me if this is correct or not? According to the question. Again read the question. First and last term of an AP are 1 and 11. And the sum of its terms is 36. I don't know how many terms, so I have not written it correctly. I'll write it again. Sum of n terms is nothing but n by 2 multiplied with first term and nth term, last term or nth term. Okay, this is what I know, right? This sum of n terms is given to me. I don't know what is n right now, but sum of n terms is given to me. First term is also given to me. Last term, that means this nth term is given to me. 11. Last term, that means this nth term. If last term means nth term, T11 only. Correct? So this is given to me 11. Now, have I written it correctly? 36 is equal to n by 2 multiplied with 6n. So n is equal to 6. 36 by 6, that is 6. So it's just that you have to interpret your question correctly. Okay, it's very important. Right? Last term means nth term. How many terms? I don't know. Okay, last term. Last term given to me is 11. Right? Chaliye. Let's go ahead. Now, suppose something like this. Sum of n terms of two arithmetic progressions are in ratio 3n plus 8 and 7n plus 15. Find the ratio of their 12th terms. Now see, how will we solve it? They are saying sum of n terms of two arithmetic progressions. There is AP and AP dash. Let's say two arithmetic progressions are there. AP and AP dash. Two brothers with a different hairstyle maybe. Okay. So AP and AP dash are there. And the ratio of n terms, sum of n terms. Ratio of sum of n terms. So sum of n terms of first AP, this AP, and sum of n terms for the dashed AP. Both n terms only. 20, 30, but in both 20 terms ratio or in both 30 terms ratio or in both sum of 50 terms ratio. Sum of n terms ratio is given to me. This is given to me as 3n plus 8 divided by 7n plus 15. You see? Okay. Now what is sum of n terms? I know n by 2 multiplied with 2. Let's say capital A is the first term of the upper AP and small a is the first term of lower AP. Okay. So 2a plus n minus 1 into, let's say, capital D is the common difference of upper AP. Right? In both n terms sum only we are finding. So this will be 2a plus n minus 1 into D. Small d and small a are the first term and common difference of the lower AP, dashed AP. Okay. N by 2 obviously will get cancelled because sum of n terms only we are talking about. Right? Correct, G, correct. Okay. Now let's see. So 3n plus 8 divided by 7n plus 15 comes out to be equal to 2 times of a. Can I write it like this? I'll divide by 2 also, no? In the numerator and denominator, do you mind? I'll write like this. N minus 1 by 2 into D, capital D, divided by a plus n minus 1 divided by 2 into small d. Not a problem. What's the problem? What are they asking us you to find? They are asking you to find the ratio of their 12th terms. That means T12 and T dash 12, the two APs. The ratio of their 12th terms. Ratio of their 12th terms they are asking. Oh, small a over here. Ratio of their 12th terms they are asking. You realize that? Okay. And what do we have? We have this. What will be the 12th term of this AP, the upper AP? T12 for the upper AP will look like this, a plus n minus 1 into capital D. And for dashed AP, the term will look like this, a plus n minus 1 into small d, because this is the general term. Right? This is the general term. N will be 12, so it will become a plus 11 capital D divided by small a plus 11 into small d. Right? This is what I want over here. Do you know Arjun Sen sir from Alan Pune? Na bacha, I don't remember. I've never been to Pune, Alan. Okay. Understand? T12, T dash 12, a plus 11d and small a plus 11d. Can I create it over here by putting some value of n? Can you create same thing? Can you create a plus, I'll write more neatly, 3n plus 8 divided by 7n plus 15, right? This was there, no? 7n plus 15 is equal to a plus n minus 1 divided by 2 into capital D divided by small a plus n minus 1 divided by 2, complete division by 2 into small d. What do I need? I need T12 divided by T dash 12. T12 will be capital A plus 12 minus 1, that means 11, into capital D divided by T dash 12 will be A plus 11 into small d. Now you tell me, I want this on this side. If I get this on this side, I have my answer. So what should I put as n so that I can create this? So that I can create this. Obviously, n is equal to 23, sir. Put n is equal to 23 and you are sorted there. If you put n is equal to 23, you have to put n is equal to 23 everywhere. So 3 multiplied with 23 plus 8 divided by 7 multiplied with 23 plus 8 will be equal to a plus 23 minus 1, that means 22. 22 divided by 2 will be 11 into capital D. Small a plus 23 minus 1, 22. 22 divided by 2, 11 into small d. This is what I wanted. This is what? This is T11 divided by T dash 11, isn't it? And I have a numerical answer over here. 69 plus 8, 78 divided by, what will this be? 2 7s, 14, 3 7 that 21, 161 plus 8, 169. Something like this. Calculate again to check. Okay, you got how to do? All right. Okay, let's go ahead. Now, about common terms. Sometimes common terms also we can get, right? Now, it's very simple to understand that if there are two APs, these are two APs, 3, 7, 11, 15, and 19 is one AP. It is going like this. And 1, 6, 11, 16, and 21. It is going like this. Now, whenever this happens, that why do you put n is equal to 23? Acha. Why did you put n is equal to 23? Here, na? Oh, yeah. Beta, what did I want? I wanted to create this ratio. I wanted T11, the 11th, 12th term, the ratio of 12th term of upper AP and lower AP, these two APs. This is what I wanted. Find the ratio of their 12th terms. So if I wanted the ratio of 12th term, that would look like A plus 11D upon small a plus 11D. I wanted 11 with D. So I just put, I solved n minus 1 divided by 2 should be equal to 11. In this case, what will n come as? N will come as 23. Na? Wouldn't the numerator be 77? 3 3 9, 3 2 6, 68, 78? 77. 69, 78 only. 70. Acha, this, yeah. Okay. I told, right? Check. Sir, I came just now. Don't we put 2n minus 1 instead of solving it? Huh? Where? Okay, ji? Clear now? 77. जो भी calculations you guys do. Now, common terms. If common terms start occurring, you just know. See, common terms are there, right? You can see the common term. No, 11 is the first common term, for example. Now, if we stretch this AP, 7, 11, 15, 19, 23, 27, 31. Okay, here also if we stretch it, difference is 5, 5. Right, 11 plus 5, 16, 16 plus 5, 21, 21 plus 5, 26, 26 plus 5, 31. So second common term also we can see now. Right, if we keep writing, we are going to get common terms. Are you sure? Right, we are going to get common terms. Definitely we are going to get common terms. If we are going to get common terms, we should know that, see, now if we write the common terms, first will be 11, second will be 31. Can you tell me what will be the third one? What will be the third common term? Can you see, can you tell me? What is going to be the third common term then? This is how it is going to be like. Obviously, 51, 71, 91. Why? Because you see, here also, this is also an AP. A is equal to 11 and D is nothing but equal to 20. This is also an AP. What did we understand? Hello Aditya. What did we understand? We understand that if common terms occur in 2 different APs or 3 different APs, the common terms will also form an AP, definitely. And the common difference of the common term AP, what is the common difference here? 4. What is the common difference here? 5. The common difference of this common term AP will be the LCM of common difference of the 2 or 3 APs, how many ever you have. Nothing but the LCM of 4 and 5 is 20. Correct? So they are asking you 10th common term of this AP. So 10th common term of this AP will be T10. T10 of the T10th term of common terms AP. That means 11 plus 9 into 20. 191. Correct? Getting my point? Yes or no? You see this? Yeah, we have covered basics. One class also, one more class has happened already. Dekho, 3, 7, 11, 15 till 403 this AP is going, and another AP is 2, 5, 8, 11 till 404 this is also going. Till 404 this AP is going. Now they are saying be the 2 arithmetic progression, then the sum of common terms in them is equal to. Sum of common terms in them will be equal to. Obviously these are 2 finite progressions. We know till where they are going. These are 2 finite progressions. Are you sure? Correct? Do we understand? These are 2 finite, limited number of terms. Na? So 3, 7, 11, 15. Right? Next, we know we have used this AP a lot many times. Right? So now there should not be any problem. Okay. Let's write a couple of more terms. Here, this one 2, 5, 8. Okay. So first common term we have is 11. Second common term is 23. Okay. So common term AP, with this let's call it CTAP. Common term AP will be 11, 23, 35, 47. Correct? Correct, no? What is D over here? D1 is nothing but 4. What is D2? D2 is nothing but 3. So our common term AP is going to have first term as this and common difference as 3. Sum of the common terms in them. How many terms? But we need to know how many terms are there. By sum of common terms, till where are they going to go? Till where these terms are going to go? That's the question. So this AP is going till 403. This AP is going till 404. Can there be a common term more than 403? No. Can there be a common term which is greater than 403? No, obviously no. If the last term is common and it is 403, we'll check. We'll check. How do we check? We know that if 403 is the common term of this AP, we'll check. A plus n minus 1 into D. We have A and D both, right? So I'm going to write 403 is nothing but equal to 11 plus n minus 1 into difference is 4 into 3. That means LCM of 4 and 3. That means 12. And I'll solve this. I'll see what is n. I'll see what is n. Okay. So I'll solve. I'll say 403 is equal to what? 11 minus 12. That means minus 1. 12 and minus 1. 12 and minus 1. And from here I get 404 divided by 12. Now you tell me, is this a natural number? Is this cancelling? 2 6 are 12, 101, no, 202. 101 by 3 is not a, okay, not a natural number. But what does this mean? If n is not a natural number, this means that 403 is not a term of this AP. But whatever is the common term, okay, it will be below this. What is the value of n over here? Calculate. 33 point something. What are we getting? 33 point something. 2b इज इक्वल टू a प्लस सी लगा लो. अरे ठीक है, या व्हाट इज द वैल्यू ओवर हियर? 33 पॉइंट समथिंग. कम ऑन टेल मी. 33.3. N is nothing but equal to 33.3. That means this AP has 33 terms. That means my common terms AP has just 33 terms, which is right below this. Only 33 terms can be there because 403 is coming at 33.3. That means this is not a term. This is not a term, but terms are ending only at 33rd term. So this AP, which is 112335, common term AP. This is my common term AP. Correct? This is my common term AP. This has how many terms? This has 33. This has nothing but 33 terms. So I'll find the sum of 33 terms. So 33 divided by 2 multiplied with 2 into 11. You can find the 33rd term and apply A plus L, or just simply do this. This will be your answer. So 2, 3, 5 aren't consecutive. When did I say 2, 3, 5 are consecutive, bacha? 2, 3. 11, 23, 35. This is common term AP. 32.66 आ रहा क्या? Let's see. 33 आना चाहिए. 33 it should be. 33 it should be. Yeah, it should be 33 only, right? Correct only. Correct, no? Understood? 33 terms are going to be there. Nothing else. Okay, okay. Right? Now, let's move on to next thing. Let's just revising our key points which we need to remember for AP. Common terms of two AP form an AP. Yes, we know. Right? If we multiply every term of AP with a constant, if we multiply K to every term, this will also form an AP. If we add or subtract a fixed thing, a constant thing in entire AP, in every term of AP, that will also form an AP. Okay, that will also form an AP. If I have 3, 4, this one, 3, 7, 11, 15, this AP. If I multiply every term with 3, let's say, or 4, so that will also form an AP. No, multiply with 4, 12, 28, 44 and 60. This is also forming an AP. Difference is 16. Okay. So if you multiply every term of an AP with a fixed number, fixed real number, that will also form an AP. If you add or subtract something, a constant thing from an AP, the resulting series will also be an AP. Sum of terms equidistant from beginning and end is same. Very important property. Okay. Suppose if you have to choose sometimes. Now this thing is, suppose you have to guess or assume. Suppose you have to assume terms for doing some question. Suppose you want 3 terms to be in AP. For example, something like this, right? That digits of a positive integer having 3 digits are in AP and their sum is 15. The number obtained by reversing the digits is 594 less than the original number. Then find the number. Okay. So in some cases, sometimes you need to assume terms in arithmetic progression. Now suppose if I assume like this, A plus D, sir, assume that means okay sir, no problem. 3 terms. Any 3 terms of AP will be like this. A term plus difference plus 2 times difference. Okay, this is what's going to happen. But if I'm adding these, right, suppose what is it saying? The digits of a positive integer having 3 digits are in AP and their sum is 15. Okay, so let's say these are the 3 digits. Let these be the digits, right? Let these be the digits. So when I'm doing A plus D plus A plus 2D, this should be equal to 15, correct? So this is 3A plus 3D is equal to 15. That means I get A plus D is equal to 5. Okay sir, sorted. There must be some more information given to solve. The number obtained by reversing the digits is 594 less than the original number. We know how a number is formed, right? If a number has digits A, B, C, then number is formed 524. How do we form 524? 100 into 5 plus 10 into 2 plus 4 into 1, right? So A, B, C are the digits, then number will be 100 into A plus 10 into B plus C into 1, correct? This will be the number. If a number is there, suppose 736 is the number, so 100 into 7 plus 3 into 10 plus 6 into 1, correct? That's how we form a number, no? By 631, how is this formed? 100, if digits are 6, 3 and 1 in this sequence, 100 into 6 plus 3 into 10 plus 1 into 1 by unit place, tens place, we have learned this. If I want to form 136, then it will be formed as 100 into 1 plus 10 into 3 plus 6 into 1, right? This is how I will form the number. So if my digits are these are my digits now. So how will the number will be formed? 100 into A plus original number in this sequence. If this is the sequence of the digits, 100 into A plus 10 into A plus D plus A plus 2D. This will be the original number. Reverse number, this is original number, and reverse number will be what? 100 into A plus 2D plus 10 into A plus D plus A. This will be the reverse number, correct? This will be my reversed number in the reverse order. But yeah, this got too complicated. Two equations I'm eventually going to get. A plus D is equal to 5, and another information is the number obtained by reversing the digits is 594 less than the original number. That means this number is this minus 594. This is equal to, curved equal to. Okay. But yeah, how much complication will solve? So one more thing, that is why we say whenever you have to guess. Okay, I hope you understood this. I was just doing this to prove my point. Whenever you have to guess, whenever you have to guess 3 digits in AP, right? Whenever you have to guess 3 numbers in AP, let the 3 numbers, or in this case, let the 3 digits be A minus D, A and A plus D. Choose it in a way so that you can solve your question more efficiently. Why? Because now when you are doing sum of digits, A minus D plus A plus D, right? And when you are putting this equal to 15, what is happening? You are now one more thing. See, this is AP only. A plus D minus A, D. A minus D, D. Right? A minus D, D. So whenever you have to choose 3 numbers in AP, choose it like this. What should be the rule for choosing the numbers in AP? What should be the rule? Rule should be that there should be a common difference. Yeah, these 3 terms are in common difference. The common difference is there. This plus this divided by 2 is equal to A. Correct? So no problem. But when I'm doing this, I'm directly getting 3A is equal to 15. Because minus D and plus D is getting cancelled, and I can directly say that A is nothing but equal to 5. That means first, the middle digit is 5. That means I can say the middle digit is 5. Correct, no? Sir, this actually solved my problem a lot. Now what am I going to do? I'm going to use the second information. The number obtained by reversing the digits is 594 less than the original number. By 15 is 10 less than 25. So 15 is equal to 25 minus 10. Right? Number obtained by reversing the digits. That means 100 multiplied with A plus D plus 10 multiplied with A plus A minus D. This is the reversed number, which is 594 less than the original number. Original number would be 100 into A minus D plus 10 into A plus A plus D minus 594. Okay ji, 10A directly gone. Okay ji, this A directly gone. Okay ji, 100A directly gone. Okay. What do you get? From this side you are going to get 100D minus D is equal to minus 100D this side, right? Minus 100D, what is left? Plus A also gone, no? Achha, A I didn't, plus D. A was gone, minus D will remain here, plus D. minus 594. A तो I already have ना, A I already have. A got cancelled also, but A I already have. See, D is also getting cancelled. Everything is getting cancelled. So what will be D? 99D is equal to minus 99D minus 590. Are we doing correct or is something wrong? Tell me, value of D. Value of D. Minus 3. Are we getting? Yes. D is equal to minus 3. Awesome. D is minus 3 and A was equal to 5 already. That means my digits, what is the number? These digits. These are nothing but 5 minus minus 3. That means 8. Then second digit is A, that means 5. A plus D, that means 5 plus minus 3. 5 plus minus 3 would be 2. So original number is nothing but 852. And reverse number is nothing but 258. And you can see 852 is exactly 594 less than the 852. 258 is 594 less than 852. What if D is greater than A? So A minus D would be negative. Yeah. No, that won't come only, na beta. That situation won't happen only. Right? That cannot happen. The question will be framed in such a way. They'll also check the data while making the question. It won't happen only. Impossible. That won't happen. Okay, they'll not give you a situation like that in which this thing is happening. Okay, that means question is incorrect. That means that the information given in the question is incorrect. Okay, ji? Understood? So original number is 852, reverse number is 258. Okay. All right. Now, suppose if you have to choose 4 numbers, then choose it like this. A minus 3D, A minus D, A plus D, A plus 3D. Why? Why did we not do A plus 2D, sir? If we do, suppose if we did like this, A minus 2D, A minus D, A plus D, and A plus 2D. What is the common difference in these two? D. Okay, no problem. What is the common difference in these two? The common difference in these two will be 2D. The difference over here is D. Here the difference is becoming 2D. Not same. You can clear, definitely. Not same. So that's why we choose 3D. So that difference over here is 2D. Here also difference is 2D. Here also difference is 2D. And here also everything minus 3D plus 3D is getting cancelled. Minus D plus D are getting cancelled. 5 terms, choose like this. A minus 2D, A minus D, A plus D, A plus 2D. Okay, 3, make it 5. For 4, start with A minus D, A plus D. Whatever is the difference, create it on the both sides. Okay. All right. Let's go ahead. This thing I told you, nth term of nth odd number, any odd number, nth odd number you can write it as 2n minus 1. And the sum of first n odd numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11. How many odd numbers? 6 odd numbers. This will be equal to 6 square. Okay, 1, 3, 5, 7. How many odd numbers? 4 odd numbers. Sum will be equal to 4 square. First 4 odd numbers is equal to 4 square. First, and how is this coming? Sum of n terms, sum of n odd numbers. So n by 2 multiplied with first odd number 2 into 1 plus n minus 1 into common difference. What is the common difference between odd numbers? 2. When we are solving this, this is coming out to be as n square, nothing else. Okay, this is coming out to be as n square. This will be equal to n square. This is how we are getting. So sum of first n odd numbers will be equal to n square, and sum of first nth odd number, any odd number, general term for odd numbers, general term for odd numbers, right? General term for odd numbers will be 2n minus 1. Okay, chaliye, let's go ahead. Now let's come on to another type of progression. Okay, another type of progression which is called geometric progression. This time there is no common difference. there is common ratio, something like this, 2, something like this, 2, 4, 8, 16, 32, 64, 128. It is progressing like this. Let's study this now. Right? Common ratio, 4 by 2 is 2, 8 by 4 is 2, 16 by 8 is 2, 32 by 16 is 2, this is 2, this is 2. Common ratio is there. Okay, common ratio is there. Very good. Amazing. So common ratio, how will we write it first of all? How will we write a GP? First term let's say is A. This is your first term. And let's say your common ratio is R. This is your common ratio. Okay, something which is getting multiplied in every subsequent term. So how will you write it? How will you write a GP? Your GP will look like this. A will be the first term, second term will be A multiplied with R. Third term should be A multiplied with R multiplied with R. Fourth term should be A multiplied with R multiplied with R multiplied with R. That means AR cube. Then AR to the power 4. Right? So first term is A, second term is AR, third term is AR square, fourth term is AR cube, fifth term is AR to the power 4. Right? What will be 10th term? AR to the power 9. What will be nth term? AR to the power n minus 1. Correct? Tn divided by Tn, Tn divided by Tn minus 1 is equal to R. Very good, Aditya. Correct? AR to the power n minus 1. This will be your nth term. So general term Tn comes out to be as AR to the power n minus 1. This is your general term, any term. Suppose for this GP, you need to write the 10th term. So 10th term will be nothing but 2 into 2 to the power 9. This will be your 10th term. That means 1024 will be your 10th term. Obviously, right? 2 to the power 10. Okay, 1024 will be your 10th term. Now, about this is your general term of an AP. We can also understand one thing, that any term divided by its preceding term is equal to R. Just like in AP, we had Tn minus Tn minus 1, which was equal to D. Just like this, right? This was for AP and this is for your GP. Any term divided by its previous term will give you the common ratio. Okay. So now this is general term. General term we realize is nothing but AR to the power n minus 1. Okay. Now what about sum of terms? Second question comes is, what about the sum of terms? So sum of n terms, we'll try to realize how we'll find that. A plus AR plus AR square plus AR cube till AR to the power n minus 1. Till here. AR to the power n minus 1. Now in just like in GP, no? Just like in, sir, please find a method to find the sum of HP. Nobody could find, bacha. Nobody could find. Sum of harmonic progressions is not there. Okay, it's not defined. And there is a reason why it is not there that I can explain when we go to HP. Okay, ji. Okay, this is sum of n terms of a GP. Alright? HP is harmonic progression. Don't worry, don't worry. Stay with me. Stay with me. We'll learn step by step. Okay, now one more thing, no? Here. When I'm writing this, no, 2, 4, 8, 16, 32, 64, 128. Okay, whenever I'm writing this, no, what I see is the product of these two. What is it? 256. Product of these two, 256. Product of these two, 256. Square of 16, 256. Just like in arithmetic progression, where the sum of the equidistant terms was fixed, common, okay, constant or same, equidistant terms. Equidistant term, this is a small part of a GP. GP can be very big. But when we write this part, in this part, equidistant terms product will be fixed. Right? Whatever is 2 into 128 is 4 into 64 is 8 into 32 and is 16 square. So by this I realize that, yeah, why don't we just multiply the common ratio. Why don't we just multiply the common ratio in every term? What will happen? Let's see. Right, common ratio, if we multiply, and one more thing, that if I'm multiplying the equidistant terms, suppose by the same idea, if I do this, Sn is equal to, just like I did in AP, right? I'll write it reverse. AR to the power n minus 1 plus AR to the power n minus 2, like this, like this, like this, somewhere over here AR, and then final term is A. Is the ratio fixed? A square R square to the power n minus 1, it is coming. Nothing is happening. But how will I subtract? What will I do? How will I find the sum of n terms? By if I'm writing the same thing in reverse order and then I'm multiplying, here also I'm getting AR square to the A square R to the power n minus 1. Here also I'm getting A square R to the power n minus 1. Why 1 plus n minus 2 will be n minus 1 only. Product is coming, okay, no problem. But if I multiply, when I'm going to multiply these two, I'll get Sn square. Ayyo, Rama, I don't want that. Sn square, square of sum of n terms, then right side will be square root. Oh, no. What I'm going to do is, I'll multiply this series, I'll multiply this series with R, both sides. So here I'm going to get AR plus AR square plus AR cube plus AR to the power 4, okay, till AR to the power n minus 2. Right? What will this term become? This term, when I multiply with R, I'll get AR to the power n, right? And second last term will be AR to the power n minus 1. Because before this it will be n minus 2 multiplied with R, n minus 2 plus 1 will be n minus 1. Okay. Now what? If I subtract, you see, if I subtract, what is happening? Now if I write in reverse order, what do you see? Is there a difference if I write it in reverse order now? Huh? If I write it in reverse order now, R into sum of n terms, AR, right? Okay, first equation, and look at this equation, right? I'm writing the same thing in reverse order. Okay, I'm writing the same thing in reverse order, multiplying with n. Last term multiplied with R, it will become AR to the power n, plus second last term. What will be the second last term? AR to the power n minus 2 multiplied with R will become AR to the power n minus 1. Correct? So here I'll get AR to the power n minus 1. Here what will I get? AR to the power n minus 2. Okay, like this, AR to the power n minus 3, and last term will come as AR. I just shifted the series a little bit. Now subtract. Now these two. Now what I'm going to do is subtract. So Sn will come out as common. What will I have? 1 minus R. A minus AR to the power n, and AR minus AR to the power n minus 1. Right? If I do, getting my point? What am I getting? Same difference I'm getting. No, I'm getting this only. A minus AR to the power n. I'm getting this only. Right? Because terms are going to get cancelled. No, this term is getting cancelled. Second term last term is getting cancelled. This term is getting cancelled by this. All terms are getting cancelled. Can you see this? So I have a formula. Sum of n terms into 1 minus R is nothing but A into 1 minus R to the power n, and this will become A into 1 minus R to the power n divided by 1 minus R. This is my sum of n terms of a GP, geometric progression. Terms are getting cancelled over here, right? When you subtract this series with this series, AR minus AR will become 0. AR square will get cancelled with the second last term. Only terms which are going to remain is A minus AR to the power n. That's it. Only this is going to remain. Everything will get cancelled. Everything. All these terms will get cancelled. Only A and AR to the power n are going to remain. That is why I have a formula. Sum of n terms is nothing but A into 1 minus R to the power n divided by 1 minus r. Do we understand this? Come on, tell me. Are we clear? Yes, good. So for you the formulas. Okay, this formula I'll come to. The two formulas you have. Okay, any common term, any general term of a GP is AR to the power n minus 1, and sum of n terms of a GP is a into 1 minus r to the power n upon 1 minus r. All right, sir, summary once. Summary. Okay, this is the summary. Formulas. Okay, derivation you can see again. Right, try to do it by yourself. Gave you the idea, how the idea came, everything I explained. Right, this is the summary. Sum of infinite terms I'll explain how is it like that. But the two formulas you should note. Right, now in AP, suppose there are three terms, a plus d, a plus 2d, right? Three terms. The sum of these two terms, that means a plus 2d divided by 2 is always the middle term, right? If there are three terms in AP, the sum of a plus c divided by 2 will be equal to b. Okay, a plus c, this is called arithmetic mean, equal to b. Right, GP, if there are three terms in GP, then what will happen? The square of the middle one will be equal to the product of the two. Third thing we need to remember is that there cannot be any term in GP which is 0. Obviously, if there is any term of GP which is 0, whatever we multiplied that 0 with, every term should be 0. Right? So there cannot be any term in GP. Geometric progression is progression of your products. So there cannot be any term which is going to be 0, obviously. But obvious this is. Right? But don't forget to like and like and comment. You guys are not doing that. I saw the last one. I was like, yeah, what's okay? This is going to help you a lot with a lot of patterns. Whatever we are doing, no? Alright, B square is equal to AC. These two are the properties. General thing, right? This is called geometric mean. This is called arithmetic mean. We'll come to that. But for now, understand this. Note this down. Now, for the sake of general questions like these, if first term of GP is equal to minus 3 and the second term is equal to the fourth term, find the seventh term. Have I written correct? First term is minus 3. Second term will be AR. Fourth term will be AR cube. Geometric mean this thing only, bacha. This thing only. Geometric means suppose if there are three numbers, if there are two numbers 3 and 4, their geometric mean will be square root of 12. Right? Geometric mean 3 into 4 square root. Right? So GM will be equal to square root of 3 into 4. GM was what? B. So B square was equal to A into C, no? So B square will be equal to 12, then B will be equal to square root 12. And this square root 12 only is geometric mean. Okay? Right? Here, what to do? Baba, R cube, R square is equal to 1. This is what we are getting from here. A cancelled, R square is equal to 1. So R will be equal to plus or minus 1. Either R can be plus 1 or it can be minus 1. So seventh term, T7 will be equal to what? AR to the power 6. That means minus 3 into 1 to the power 6 or minus 3 into minus 1 to the power 6. Both are going to be same because power is 6. Okay, so minus 3. Right? Minus 3. Actually, all the terms of this geometric progression will be minus 3, 3, minus 3, 3, minus 3, 3. Either this will be your geometric progression. If the ratio is 1, then minus 3, minus 3, minus 3, minus 3. All the terms are these. All the terms are minus 3. There is no problem. 0 cannot be a term. Constant GP, no problem. Sign changing GP, no problem. 0 cannot be a term. Okay, 0 cannot be a term. Something we did. second term is equal to fourth term, correct? So r square is equal to 1, correct only video, no? Answer correct. हाँ अच्छा, square and the second term is equal to, हाँ सही, correct only we did, correct only we did, correct only we did. Suppose x, 2x plus 2 and 3x plus 3 are the first three terms of GP, then find the fourth term, right? These are the three terms of GP, then we have to find the fourth term. No problem, we know one thing, that 2x whole square, middle term whole square, geometric mean, no? 2x plus 2 whole square will be equal to x multiplied with 3x plus 3. This is it, this is what's going to be. We'll solve this. Let's see, 4x square plus 4 plus 8x is equal to 3x square plus 3x. Okay, so x square plus 5x plus 4 is equal to 0. Right? So x minus 4 into x minus 1 is equal to 0. X can be equal to 4 or x can be equal to 1. Now we'll check if x is equal to 1. If x is equal to 1, terms are, what will be the terms? Terms will be 1. Wait, 1 minute, minus 4 minus 1. No? Oh, no, something wrong. No, 4 plus 1. X plus 4, x plus 1. X plus 1 is equal to 0. So x can be equal to minus 4 or x can be equal to minus 1. Okay. So if x is minus 1, terms will be what? Terms will be 1, 2 into 1 plus, minus 1. Minus 1 will be the first term. Second term will be minus 2 plus 2. That means 0. Third term will be minus 3 plus 3. That means 0. So wrong. 0 cannot be a term of GP. If x is equal to minus 4, first term will be minus 4. Third term will be minus 8 plus 2. That means minus 6. Third term will be minus 12 plus 3. That means minus 9. And this is a GP. You can see minus 6 by minus 4 is 3 by 2. Minus 9 by minus 6 is also 3 by 2. So 9 into 3 by 2 you can directly do to find the fourth term. Okay. 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 Minus 9 into 3 by 2. Minus 27 by 2 will be your fourth term. डायरेक्ट सॉल्विंग जल्दी में करने में यही होता है. ठीक है. ओके. अभी स्लो, अभी ऑल राइट, कोई नहीं. ऑल राइट, अंडरस्टूड. So this is how you can check. Chalo, let's try this one. In a GP, let me remove this. In a GP, we have A1 plus A2 plus A3. That means first term plus second term plus third term. अच्छा, वो अपने आप को बोल रहा है. A1 square plus A2 square plus A3 square is 91. Find R. चलो, try this. Try this for a minute. I'll just have some water and come back. Okay, try this. Done? Any progress? A by R, A R. नहीं होगा उससे कुछ. Simply let's see, no, A plus AR plus AR square. Okay, this to we know is equal to 13. Okay, what do we have here? A1 square, that means a square plus a square r square plus a square r to the power 4 is equal to kitna? 91. This is what is given to me. All right. So what I can do is I can take a common from here. 1 plus r square is equal to 13, and from here a square common, then 1 plus r square plus r to the power 4 is equal to 91. Still no benefit. Let's do one thing. If I want to cancel a square, my brain says, my mind is saying, if you want to cancel a square, we can get rid of directly a square, no? We can directly get rid of this a square. If we write like this, a square multiplied with 1 plus r square whole square is equal to 169. Any problem? I squared both the sides. So I can cancel a square. Right? Now these two I'll divide. So I'll get 1 plus r square plus r to the power 4 whole square. Oh, sorry. R square. 1 plus r square. Sorry. This will remain 1 plus r square. 1 plus r. Arey yaar. What am I doing? Okay. Alright. Okay. So I'm going to go get, if I divide these two, what am I going to get? 1 plus r square plus r to the power 4 divided by 1 plus r square to the whole square. This is equal to 91 by 169. Not even cancelling. Not even cancelling. 7. No, 7 also not cancelling. All right. We'll do something. You got what I am trying to say. Actually, what you need to know over here is that x to the power 4 plus x square plus 1. Whenever you see this expression, no, you can actually write it like this: x to the power 4 plus 2x square plus 1 minus x square. Can I write it like this? I just added x square and subtracted x square, plus x square minus x square. So that plus x square I added with x square, so it became 2x square, and minus x square I wrote over here. Why did I do this? Because this particular thing I can write as x square plus 1 whole square, and this minus x square. And after this I know what to do. This is a square minus b square, so x square plus 1 minus x into x square plus 1 plus x. A plus b into a minus b. Okay, a plus b into a minus b. I can write like this. Any problem? No problem. What benefit am I getting? The upper expression I'm going to write as 1 plus r square multiplied with 1 minus r plus r square divided by 1 plus r square whole square. This is equal to 91 by 169. I cancel this with this. That's why I did this. Ulta, galat. This with this. Okay. So I have 1. What do I have now? I have 1 minus r plus r square divided by 1 plus r square is equal to 91 by 169. This is what I need to solve. That's it. Almost don't want to write the answer. Okay. This is what you need to solve. This we can solve. This we can solve. 169 r square plus, minus 169 r plus 169 is equal to 91 plus 91 r plus 91 r square. Okay. So this will become 78 r square, and solve for r. Can you solve for r quickly, please? Can't D, can D. Solve for r square over here. 78. This is how it's going to be. Use componendo and dividendo. Componendo, dividendo, very good idea. That also can be used. 1 minus r plus r square plus 1 plus r minus 9. Not much of benefit we are getting here from componendo, dividendo also. You'll have to solve for r. It's better. Okay, it's better we solve for r. By 13, you can divide it by 13, na? 13 into how much is 78 is 6. 1 3 are 3, 3 3. Sorry, 1 6 are 78. 13, 6 r square minus 20 r plus 6 is equal to 0. है ना? तो 6 r square minus 18 r minus 2 r plus 6 is equal to 0. Sum is minus 20, product is equal to 36. So 6 r into r minus 18 minus 2 I understand. R is equal to 3. Either it is 2 by 6 or 3, 1 by 3 or 3, right? R is 1 by 3 or 3. R is equal to 1 by 3 or R can be equal to 3. There will be two possible values of R. Okay? And once you have R, you will have two values of A also. You will have two values of A also. Let's check. Must have the answer. R is 3 or 1 by 3 and there will be definitely two values of A also. Achha, find R. We had to find R only. That's why. Now, let's talk about what if there is an infinite GP and in what case can we talk about infinite GP, right? So, there is some concept called sum of infinite terms of GP, S infinite of GP. Okay, when can this happen? Let's see. Sum of n terms, we write it as A into 1. Sum of n terms we write, no, A into 1 minus r to the power n divided by 1 minus r. This is how we write sum of n terms. Infinite GP means AR square, AR cube. It's going on. Infinite terms are there. We don't know how many terms are there. We don't know. Infinite terms are there. Too many terms are there. Whenever in this formula, if your R is between -1 to 1, between, not 1 and -1. If it is 1, if R is 1, then it's a constant GP, no. If R is -1, then it's a sign changing GP. So in that case, so we can find the sum. For a sign changing infinite GP, sum will be 0. For if R is 1, then sum will be infinite. Obviously, sum will be infinite. Only if your R is between -1 and 1. That means R is small. Or we can write it as mod of R. Correct. Mod of R is less than 1. Mod of R is less than 1 means R is between -1 and 1. Okay. This same thing. This is the same thing. In that case, what happens is, this R to the power n becomes R to the power infinity. And because your R is between 1 and -1, it will be 1 divided by something. 1 divided by something. Between 1 and -1, 1 divided by something. This 1 divided by something to the power infinity will become 0. 1 divided by a very large number is approximately equal to 0. That means this term is going to become equal to 0. That means your sum of infinity will be nothing but A into 1 minus 0 divided by A minus R. That means A by 1 minus R for GP. I hope you understand this. Correct? A is equal to A, sum of infinite terms will be nothing but A divided by 1 minus R. Very beautiful. Nice. Okay, sum of infinite terms also we are able to write over here. Now, let's go back to this question. Sum of infinite terms of a GP is 20. Sum of infinite terms of a GP is 20. Okay. And the sum of their squares is 100. Oh. Then find the common ratio of GP. Try doing this. Formula of infinite terms is A by 1 minus R. Very easy. By which thing? This thing? This thing? I am saying that if your common ratio is between minus 1 and 1, not minus 1, not 1, just between them, it will be 1 divided by something. All the numbers between minus 1 and 1 are minus 1 divided by something or 1 divided by something. Now 1 divided by something. What is the term over here? This r to the power n thing means r to the power infinity. N means sum of infinite terms means n is infinity. Right? So r to the power infinity. Now if your r is 1 divided by something, this to the power infinity will be 1 divided by something to the power infinity. That means 1 divided by something very big, which will approximately be equal to 0. It should be approximate, tending to 0. Okay. Now understood? Now understood? Sum of infinite terms will be equal to 0. Okay. Now based on this, try solving this question. Sum of infinite terms of a GP is equal to 20 and sum of their squares is equal to 100. Bhai, if there is a GP AR cube, AR to the power 4, square of terms will be A square R square, A square R to the power 6, A square R to the power 8, correct? What is the ratio over here? R square. Wait. Sum of their squares. Come on, tell me. This will be okay. Ratio will become R square, no? Right? The ratio of this is R. The ratio of this is R square. Okay. Any problem? Any problem? No problem, sir. Right? Sum of infinite terms of a GP is 20. Sum of infinite terms for the squared GP. Squared GP will be equal to what? First term of the squared GP will be A square. Okay. This is given to you as 100. Okay. This formula we know, A divided by 1 minus R. This formula is what? First term will be A square. Common ratio will be R square. Nothing else. Okay. Solve this. Same technique you can use. By A divided by 1 minus R is equal to 20. So A square divided by 1 minus R whole square will be equal to 400. Right? A square divided by 1 minus R whole square will be equal to 400, correct? And already A square divided by 1 minus R square, this is given to me equal to 100. This is my first equation. This is my second equation. I'll divide both of them. And what am I going to get? A square. I wanted to get rid of A square. That's it. So 1 minus R square divided by 1 minus R whole square is nothing but 400 by 100. That means 4. So just solve this, because this will be 1 plus R divided by 1 minus R equal to 4. One plus R will be equal to 4 minus 4R. All right. R is equal to 3 by 5. Simply. Somebody just gave also, I think 3 by 5. 3 by 5. Very good, Aditya Sharma. R will be equal to 3 by 5. Correct. So R is smaller than 1. You can see it is between minus 1 and 1. By factorize this, no? 1 minus R into 1 plus R. 1 minus R will cancel with 1 minus R. And 1 plus R upon 1 minus R will remain equal to 4. R is equal to 3 by 5 we are getting. Okay, and we can see also R is between 1 and minus 1. That is why sum of infinity is possible. Otherwise, sum of infinity is not possible. Correct? Okay ji, okay ji, okay ji. Okay, try this. Sum of n terms. You have to find the sum of n terms of, you have to try and find the formula or expression for sum of n terms of this particular sequence. Come on, try it. Take a minute, try. Look, come on, let's see. But directly we are not seeing anything. Obviously, we are not seeing anything directly. So nothing. Here also there is a square. Okay. Here also there should be a square. A square. Okay. So this is something like this. Then x to the power 4 plus 1 by x to the power 4 whole square will come. Okay. Terms are there. Terms are there. We have to find the sum of n terms formula. First of all, sum of n terms will be what? Let's write it. If I open this, if I open this, x square plus 1 by x square plus 2 into x into 1 by x, that means plus 2. Okay. If I open this, it will be x to the power 4 plus 1 by x to the power 4 plus 2 into x square plus 1 by x square. So plus 2. Wow. X to the power 6 plus 1 by x to the power 6 plus 2. Similarly, x to the power 8 plus 1 by x to the power 8 plus 2. Correct? I'm just opening these. I'm just squaring. Okay. I'm just squaring k square minus 2 k square minus. Okay. I'm just squaring. And as soon as I did this, I realized, yeah, this is nothing. I can write it like this: x square plus x to the power 4 plus x to the power 6 plus x to the power 8. Okay. This is going to be one thing. And these 1 by x square. So 1 by x square plus 1 by x to the power 4 plus 1 by x to the power 6 plus 1 by x to the power 8. This is one thing. Plus 2 in 2 plus 2 plus 2 plus 2 plus 2 n times. This is one thing. Three things I can separate this into. Can you see this now? Now you must have realized, yeah, this could be done. Right? These are all n terms. We have to find sum of n terms. Right? So these are n terms. Here also n terms. Here also n terms. Here also n terms. Okay. Sum of n terms of this. What is the common ratio? R is nothing but x square. What is A? A is nothing but x. This is GP, right? This is GP, x square, x to the power 4, x to the power 6, x to the power 8. This is GP. This is also GP. A is what? 1 by x square. R is what? 1 by x to the power 4 divided by 1 by x square. This will be 1 by x square. R is also 1 by x square. Okay, ji? Correct, no? Correct, no? Sorry, 1 by x square. A and R both are 1 by x square. Here, this is directly you can write. Here, sum of n terms will be 2 into n. 2 is getting added n times, so 2 into n. What will this be? Sum of n terms. This will be n terms, sum of n terms. A into 1 minus r to the power n, that means x square into 1 minus x square to the power n divided by 1 minus r, that means 1 minus x square, plus here a, that means 1 by x square into 1 minus r to the power n, that means 1 by x to the power 2n divided by 1 minus 1 by x square. Wow. Right? Plus 2 into n. This will be the entire formula. This is going to be your formula. When you solve this, your final answer should come like this. Right? Final answer should, our answer is also quite, just taking some things common, final answer will come out like this. My mind lagged while solving. No, you can solve it here. You have to solve, you have to now start realizing, acha, this is AP, this is GP, here I can use sum of n terms. Now you will be capable of solving a lot many types of series. Okay, there'll be a lot many types of series which you'll be able to solve. Okay, for example, one more I'm showing you just now. After that, we'll go on some more concepts. Okay, for example, something like this. मजे ले रहा है. Okay, something like this. Now we'll be able to crack a lot of types of series by breaking them into APs and GPs, different types of series, or just writing the general term. There are more methods we'll learn, but for now, this. Okay, for example, let's look at. I'm just giving you an example. Don't panic if you don't understand. I'll explain it again. Don't worry. I'll come at more things, but I'm just showing you that how are we going to use the concepts that we learned so far by you to and use them to solve the questions of IOQM. These are some of these questions, some of these series and addition and subtractions are from PYQs of IOQM only. For example, let's see this. What is this? 2 by 100? Oh, sorry, 2 by 10 plus 4 by 100 plus 6 by 1000. Okay, plus 6 by 1000, and it'll keep going on like this. Now, this is this AP? Check, is this AP or GP, something like that? What is this? Is this AP? Ha. Ye AGP. This is AGP. This is what we are going to call AGP. And about AGP also, there is nothing to panic. Okay. What is an AGP? AGP looks like this. Okay. Ha, question. Mayank Sharon, bolo. Tell me. Okay. The series just now we saw is neither an AP nor a GP. Instead, it's a mixture of both AP and GP. It's a combination. And we can solve these type of things also without any problem. Without any problem, we can solve something like this also. Okay. Obviously, it will be a bit complex, but with practice, we'll be very gelled up with it. We'll be very comfortable with it. Now, suppose we have to find by nth term. Nth term, so we can write no first term r is equal to 0. Second term r is equal to 1. Third term r is equal to 2. I mean like first term r to the power 0, second term r to the power 1, third term r to the power 3, fourth term r to the power fifth term r to the power 4, and nth term will have r to the power n minus 1. Right? R to the power n minus 1, a plus n minus 1 d. Now, okay, now let's see how will we deal with it. Suppose sum of n terms, I have a plus a plus d into r, right, plus a plus 2d into r square, okay, plus a plus 3d into r cube. Let's do it with a question only, no, this question. Okay, this is the question. Now this is AP and GP both. 2, 4, 6, 8, 10 is making a GP, is making an AP, and 10, 100, 1000, this is making a GP. 1 by 10, 1 by 100, 1 by 1000 is making a GP. How do we solve it? Sum of infinite terms we need to find. For example, okay, the first step to solve a sequence which is a combination of AP and GP both. Here first A is what? A is equal to 2. R is equal to 1 by 10. And D is equal to 2 again. Correct? Any term of this AP, any term of this sequence can be written like this. A plus n minus 1 D multiplied with R to the power n minus 1. Suppose I want to write the third term. This will be the general term. Third term I want to write. Third term will be 2 plus 3 minus 1, that means 2D, multiplied with r to the power 3 minus 1, that means 2. This is what? This is 2 into 1 plus d. Acha, d is also there, no? D is 2. 4 plus 2, 6. into r square. That means 6 into r is 1 by 10. 1 by 100. But, okay, getting my point. But here actually what the problem is, there is a problem. Let's solve a little bit easier version of it. For example, let's say we have something like this. Okay, something like this. Suppose Sn we need to find. So 1 plus 3x plus 5x square plus 7x cube. This is neither an AP nor a GP. Instead, it's a mixture of AP and GP both. Sir, एक और doubt है. Find the sum of n terms and also S infinity 3 by 5. ठीक है. AGP questions. Okay, right? 1 plus 3x plus 5x square plus 7x cube. This is kind of an AGP. You can see. What do we do is, the method is multiply with r. What is r over here? What is r over here? R is x. So multiply with x. So x into Sn will become x plus 3x square. Every term will get multiplied with x. 1 into x is x. 3x into x is 3x square. 5x into x is 5x square into x is 5x cube. 7x cube into x is 7x to the power 4. Right? To n terms, and this is also till n terms. What will be the nth term if I want to write the nth term? If I want to write the nth term, what will it be? By second term has x to the power 1, third term has x to the power 2. 1, 3, 5, 7. Odd numbers. Odd numbers are starting from 1. So 3n minus 1. How can I write? 2n minus 1. Right? 1, 3, 5, 7. 1, 3, 5, 7. The general term will be 2n minus 1. Do you understand directly now? General term. N is equal to 1 will give you 1. 2 into 1 minus 1 is 1. N is equal to 2. That means 4 minus 1. That means 3. So this will be general term. 2n minus 1 into x to the power n minus 1. Correct? What will be the first term, for example? 2 into 1 minus 1. That means 1 into x to the power 0. That means 1 only. Second term will be 4 minus 1. 3 into x to the power 2 minus 1. That means x. That means 3x will come. Okay. This is how we are going to deal with it. Right? 2n minus 1 into x to the power n minus 1. Why did I multiply with x? Why did I multiply with the common ratio? When I'm multiplying every term, this will become the second last term. Right? If I'm multiplying x in every term, the last term will be 2n minus 1 into x to the power n minus 1 multiplied with x. Right? Every term is getting multiplied with x. So multiplied with x will become minus 1 plus 1. That means x to the power n will become the last term. And second last term will be 2n minus 1 into x to the power n minus 1. Got my point or not? Why did we do so? When we subtract these two, we get Sn minus x into Sn. Sum of n terms minus x into sum of n terms is equal to what? I got 1 as it is, no problem, plus 3x minus x plus 5x square minus 3x square plus 7x cube minus 5x cube. Like this it is going. Okay. And what am I going to get over here? 1 I left. No, I just shifted it. This series just got shifted, nothing else. This just got shifted. Getting my point? How are we getting it? Right? This just got shifted, nothing else. So we are going to get 1 plus 2x plus 2x square plus 2x cube. Like this is going to go. What about the last term? Think about it. What about the last term? What about the last term? Think about it. Right? This term will get subtracted with what? this term. This will be not 2n minus 1, this will be 2n minus 1. No, second last term, this term. Okay. Second last term will be here also n minus 1 we'll have to put. No, so 2 into n minus 1 minus 1. So 2 into n minus 1 minus 1 will be into x to the power n minus 1 will be the second last term. So this is 2n minus 2 minus 1. That means 2n minus 3. And this is 2n minus 3. So you'll be able to see more clearly. Second last term will be 2n minus 3 into x to the power n minus 1. Now subtract these two. Again we are getting what? 2 minus 1 minus minus 3 will be 2. So 2 into x to the power n minus 1 will be the second last term. And this, because we are subtracting this from this, so here we'll get a minus. And minus may we'll have 2n minus 1 into x to the power n. Getting my point? Now this entire thing, it's a beautiful thing. We know what to do with it. 2 if we take common, it's nothing but x plus x square plus x cube till x to the power n minus 1. That means how many terms do we have over here? N minus 1 terms we have over here. Minus 2n minus 1 into x to the power n. Okay, 2 we took common. Now we can solve it. There is no problem. We can write it as 1 plus 2 into a is x into 1 minus r to the power n. R is what? X. 1 minus x to the power. How many terms are there? N minus 1 terms are there. Right? Divided by 1 minus x. Okay. Minus 2n minus 1 into x to the power n. This will be the, this is what? This is your x, this is 1 minus x multiplied with Sn. And now this 1 minus x we can shift over here. It looks very difficult. It looks very, difficult right now because we are finding the sum of n terms. So this 1 minus x will get divided everywhere over here. Okay, this 1 minus x will get divided. Finally, what we are going to get is Sn is 1 divided by 1 minus x plus 2 into this thing, 2 into x into 1 minus x to the power n minus 1, 2x into 1 minus x to the power n minus 1, and denominator mein we had 1 minus x, again 1 minus x came from here, so it will get squared, plus 2n minus 1 into x to the power n divided by 1 minus x. This will be your sum of n terms for that particular expression. Okay, but when we are solving, when we'll be solving something like this, this is not going to make it that complicated. Let's see how. So we know that it is an AGP. We just need to know the first step. That what is the first step? So first step is multiply with common ratio. Multiply with R. First step is always multiply with R. First step will be this only. First is multiply with R. Once you have multiplied with R, this S infinity will become what? Same thing. 2 by 10. R is what? R is equal to 1 by 10. R is equal to 1 by 10. R. Don't look at AP. Only R. Don't. AP is different and GP is different. There is a GP also 1 by 10, 1 by 100, 1 by 1000. AP is also there 2 plus 4 plus 6. Okay. What you do is multiply with R. Let's take it on another. Okay. Let's do it over here. Okay. When you multiply with R, you will get 2 by 10, 2 by 100, right? Plus 4 by 1000, plus 6 by 10,000. Okay. And it will keep going on like this. Okay, this is 1 by 10 multiplied with S infinity. Same thing we multiplied with 1 by 10. Same thing. S10, S infinity multiplied with 1 by 10. Every term got multiplied with 1 by 10. What benefit we got? When we are doing these two, when we are subtracting these two, what are we getting? S infinity into 1 minus 1 by 10 is equal to 2 by 10 as it is, no problem. But here we got 4 by 100 minus 2 by 100. Plus 6 by 1000 minus 4 by 1000. And this is how it is going to propagate without any trouble. Okay, so what do I have? S infinity into 1 minus 1 by 10, which is again 9 by 10, is equal to 2 by 10 plus, here there is a thing. For this thing I wrote, no, 4 by 100 minus 2 by 100 plus 6 by 100, 6 by 1000 minus 4 by 1000. Okay, and it is going to keep going on like this for infinite terms, right? Now s infinity into 9 by 10 is equal to what? 2 by 10 plus, from here everywhere 2 will come out to be common. What will remain? 1 by 100. 4 by 100 minus 2 by 100 is 2 by 100. This is also 2 by 1000, then 2 by 10,000, then 2 by 100,000, like that it will keep going on. 1 by 100 plus 1 by 1000, I mean same thing, this thing, 1 by 10 square plus 1 by 10 cube plus 1 by 10 to the power 4 till infinity. It is going to go like this, right? So sum of infinite terms into 9 by 10 is nothing but 2 by 10 plus 2 into sum of infinite GP. This is what? Infinite GP. This is what? Infinite GP. Nothing else, right? This is infinite GP. And we know one thing about infinite GP. Sum of infinity for infinite GP will be A upon 1 minus R. That means what is A? 1 by 100 is A. Divided by 1 minus what is R? In this GP, R is 1 by 10. 1 by 10 cube minus 1 divided by 1 by 10 square will be 1 by 10. So 1 minus 1 by 10. This is what we are going to have. Okay. So this is going to become 9 by 10, 1 by 100 upon 1 by 100 into 10 by 9, 1 by 90. This is just come as 1 by 90. Sorted. You have the formula, right? How easy is this? No, it's not time taking. It's just that you need to follow the formula. Now, in some books, they can give you a direct formula also. In some books, no, there is a formula for infinite terms of AGP, right? And this formula is like this. Okay, this formula is nothing but A upon 1 minus R plus dr upon 1 minus R whole square. This is the formula. Okay, this is the formula. How is this coming? I'll show you how is this coming, right? When we have this, no, A plus D into R plus A plus D into R square, right? These infinite terms, right? Infinite terms of an AGP. This is AGP. Okay, this is AGP. When I multiply with R, what do I get? AR plus A plus D into R square plus A plus D into R cube, and it is going to keep going on like this. Now subtract these two. So 1 minus R into sum of infinite terms is equal to what? This minus this. A plus D into R minus AR will be dr. A plus D into R square minus A plus D into R square will be equal to, sorry, A plus D into R square plus A, ये 2D है भाई. This is 2D. A plus D. Okay. A plus 2D into R square minus A plus D into R square will be equal to what? A plus 2D into R square minus A plus D into R square will be equal to what? dr square. Like this, next term will be dr cube, and it is going to keep going on like this. So what do we have? 1 minus R into sum of infinite terms is equal to A plus D common, R plus R square plus R cube till infinity. And here also it is necessary that R should be between minus 1 and 1. Here also mod of R is less than 1. Okay. So this thing becomes what? This thing is what? This is A upon 1 minus R, where A is R itself and A is R itself, right? This is A upon 1 minus R. A is R, first term is R itself. So R upon 1 minus R multiplied with D plus A. Right? When we solve this, we get sum of infinite terms is equal to A upon 1 minus R plus dr upon 1 minus R whole square. This 1 minus R came over. This is how this formula comes. But it's better that we know the approach instead of the formula. It's better that we know the approach instead of knowing this formula and mugging this up. Why not to mug this formula? Because this formula will not work when the first term is multiplied with r. Just like this question. In this question, this formula will not work. In this question. Why? Because first term is multiplied with 1 by 10. First term is not alone. A is not alone. When we derived the formula, A was alone. But here A is not alone. Okay, get my point. A should be alone. Here A, if only 2 was there and the series, rest of the series was starting from here, then that formula could work, but here it won't work. Here you'll have to solve it just like this. So this is the question we stopped at. And if we look over here, we only realize that we can say that a plus d multiplied with r is equal to 4 and a plus 2d multiplied with r square is equal to 4. Both of them are equal to 4. If the question is saying that this is an AGP, then we have to definitely believe it, right? Because it's given. And if we are believing it, then we know the format. We know how an AGP looks like, right? When AP and GP both are merged together and there is a common ratio, there is common difference also. In that case, we get an AGP. So this is what I have. Now, if I look at this and if I fix this a little bit, I can say that A plus D whole square multiplied with R square should be equal to 16. Correct? Can I say that? If I square the first one and then I have this is equal to 16, correct? And then this is as it is, a plus 2d multiplied with r square should be equal to 4. So this is 16 divided by 4. The upper one, I squared the upper one and divided both of them. A plus 2d into r square will become equal to 4. This thing is given to me equal to r and I squared that side. Right? Now, why did I do it? Because I know a first of all. First of all, I know A. What is A? A is given to me as 3. First term is given to me as 3. Second term should be, of an AGP should be A plus D into R. Getting my point? So that should be my second term. Now, if I want to find out D, I have to get rid of other terms. So I can cancel R square, R square. That's why I squared. Right? Now 3 plus D whole square divided by 3 plus 2D is equal to 4. I just need to solve this and I'm done. Right? So if I solve this, 12 plus 8d should be equal to 9 plus d square plus 6d. Correct? Let's solve this out. So d square plus d square minus 2d minus 3 is equal to 0. Correct? So 1 minus 3, d is equal to, from here I get d is equal to 1 or d is equal to minus 1 or d is equal to 3. Right? Do you get my point? Correct? Either d should be equal to 3. We can put it also. You can solve this. You can solve this. This is nothing but d minus d plus sorry, d square plus d minus 3d minus 3. This is how you solve, right? This is how you solve. You will take d common, then d plus 1 minus 3 common, then d plus 1. So d will be equal to either 3 or d will be equal to minus 1. If we believe it that d will be either equal to 3 or equal to minus 1. Now come back over here. Will be satisfied with our answer or not? Let's come back over here. If d is equal to 3, if d is equal to 3, a is also equal to 3. So d 3. Now minus 1 obviously we are not going to take, right? D minus 1, we can also take that also, but let's see that, let's say that d is equal to 3. I'm taking d is equal to 3. So 3 plus 3 into r should be equal to 4. Correct? If I'm taking d as 3. So that means r should be equal to 4 by 6. That means 2 by 3. If d is equal to 3, then r comes out to be 2 by 3. If my d is equal to minus 1, let's say I want to take minus 1 as my d. Suppose I want to take minus 1 as the common difference. So if d is equal to minus 1, in that case what do I have? 3 minus 1 into r is equal to 4. That means r is equal to 2. Correct? So what am I having right now? I am having That this series 3 4 4, let's check it. No, let's check it. 3 4 4, 32 by 9 is the next term. Okay, 32 by 9. So if I take my A as 3, my D is equal to 3, my R should be equal to 2 by 3. Let's say first term is 3 only, second term is 3 plus second term would be what? Should be what? According to our answer, A plus D multiplied with R is 2 by 3. So check 6, this is 6, 6 by 3, 2 2s are 4. This is my second term. Third term, what should be the third term? If our answer is correct, right? 3 plus 2 into D. Third term will be 3A plus 2D into R square. That means 2 into D would be 2 into D would be 6 multiplied with R square, that means 4 by 9. Are we correct? Yes, this is also equal to 4. And we can check fourth term would be 32 by 9. Even if we take A is equal to 3, D is equal to minus 1 and R will be equal to 2. In that case, R would come out to be equal to 2. Let's check according to this. Just check according to this. What would be your first term in this case? First term would be 3. Second term should be A plus D into R. That means 3 minus 1 multiplied with R, which is 2. Yes, this is coming out to be 4. If third term, let's check third term. A plus 2D, that means 3 plus 2 into minus 1, that means 3 minus 1. Sorry, 3 minus 2 multiplied with R square, that means 4. Yes, this is also correct. So both values of D are correct. D can be positive as well as negative, and we have to, it is already given in the question that we have to believe. Correct? So this was AGP in the last class. I hope you guys understood a little bit of AGP and the concepts related to it. I also told you the formula, direct formulas to be used. Now let's come upon to the next thing, which is summation part. Okay. After that, we'll go to AMGM. Let's understand the rule for sigma. Okay. Okay. Sigma notation. Sigma notation means this. Okay. Sigma notation just means this sign. This is the notation. Now, what all does it do? So, suppose I am writing K over here. Inside sigma, I'm writing K. And I'm saying that my K is equal to 1 from K equal to 10. This just simply means 1 plus 2 plus 3. So, I have to start from K equal to 1 and I have to stop at K equal to 10. Right? I have to stop at K equal to 10. That's it. This is what it means. This thing is called iterator. What is it iterating upon? It is iterating on K from K equal to 1 to K equal to 10. Right? So sigma over K, and iteration always happens on consecutive numbers like natural numbers 1, 2, 3, 4. From 1 to 10, I'm adding. This is what it means. This is expanded to this. Okay. Suppose if I'm writing sigma K square from K equal to 2 to K equal to 5. So this would simply mean 2 square plus 3 square plus 4 square plus 5 square. That's it. This is what it means. First of all, let's have an understanding about the term sigma. Okay, about the term sigma. Getting my point? हाँ बिल्कुल, लेजेंड गेमिंग यही काम करना और यही सब सीखना, बहुत बढ़िया. राइट? सिग्मा k equal to 1 to k equal to n. AK iteration is on k, so from k equal to 1 to k equal to n we have to add up, right? A1 plus A2 plus A3 till AN we have to add, right? What is iterating? K is iterating. So 1, 2, 3, 4 till n, from 1 to n. So this is what it means, right? If I do AR from R equal to 1 to n, this also means A1 plus A2 plus A3 plus A4 till AN, right? What is the iterator over here? R is the iterator over here, right? We are iterating upon R from R equal to 1 to R equal to n. Now, if suppose something like this I'm writing, sigma over AK plus BK. Okay. Now, what would this mean? Sigma over AK plus BK. Right? Iteration is happening on K only. Iterator is K. So, K is going to change. K is changing from 1 to N. To N. So, if I don't open this, what would this mean? This would mean A1 plus B1. First K is 1, then K will become 2 and add it. So A2 plus B2, then plus A3 plus B3, like this till AN plus BN. So can I not write A1 plus A2 plus A3 plus A4 till AN plus B1 plus B2 plus B3 plus B4 till BN? I can do that, right? There is no problem. If I can do that, then this means that I can break sigma over addition and difference. Addition and difference. Right? Addition and subtraction, I can break my sigma over. If there is a constant over here, suppose if there is a constant, what would this mean? This would simply mean, this thing would simply mean that C A1 plus C A2 plus C A3, right? Because iteration is happening on K only. The thing which is changing is K only. So C is being constant and C is common in all, C is going to be common in all of them. So why don't I put C outside the sigma and just apply sigma over AK? So if a constant is there inside sigma notation, you can take it out just how you take a constant. Now the thing is that what would this mean? Sigma over 2 from, and I put R is equal to 1 to R is equal to 10. This has a meaning. It looks like it does not have a meaning, but this has the meaning. This means that 2 is being added up 10 times. Right? 2 is being added up 10 times, so this will nothing but 20. Right? 2 is being added up 10 times. That's it. So if there is a constant number, suppose if there is a constant number, sigma over 1 from R is equal to 1 to R is equal to n, this would simply mean equal to n, because 1 is being added up n times. This simply means that 1 is being added up n times. Understood? Are we? Right. Now let's move ahead and understand more about sigma. Okay, sigma of 1 from k equal to 1 to n would be equal to n, because this means 1 is being added up n times, and this means that, right? So this is about sigma notation. I hope you can understand this. Now suppose if there is multiplication or there is division, suppose if I'm writing sigma over ak multiplied with bk, okay, and k is being iterated from 1 to k equal to 10, let's say, okay, k from 1 to k equal to 10, I'm iterating this. Now what would this mean? Can I break sigma over multiplication? Yes or no? We'll see. No, what would this mean? This means a1 b1 plus a2 b2 plus a3 b3 plus a4 b4 till a10 b10. Correct? This is the meaning of it. This is the logical meaning of it, because sigma is over this entire expression. But what is the meaning of sigma a k multiplied with sigma bk? Where k is iterating from 1 to 10. K is iterating from 1 to 10. This is different, right? Don't you think so? This is different because this means A1 plus A2 plus A3 till A10 being multiplied with another sigma, which is B1 plus B2 plus B3 till B10. And definitely you can say that these two are different things, that this is not same as this. So that means we cannot break sigma over multiplication and division, right? We can, obviously the same thing would happen with division also. Sigma over ak divided by bk will not be equal to sigma over ak divided by sigma over bk. Natural. Because what does this mean? This means a1 by b1 plus a2 by b2 plus a3 by b3. This means a1 plus a2 plus a3 till an divided by b1 plus b2 plus b3 till bn. Both are different things. Both are definitely different things. Don't you think so? Correct? Now, let's move a little bit more ahead. Let's understand general sigmas. Okay, this is what we should always know and remember, because this is going to help us solve a lot and lot of questions. This is going to be helping us in solving a lot of questions. This is what we need to remember. And by AP also, by the methods which we have learned for some summation of AP, some of the n terms of AP, by that also you'll be able to understand this. You can mark this. What does this mean? Sum of n natural numbers, k equal to 1 to k equal to n sigma over k. That means sum of n natural numbers starting from 1. Sum of this simply means sum of first n natural numbers. First n natural numbers. First n natural numbers. This is something which you need to understand and grasp, that I cannot say that sum of 2 plus 3 plus 4 plus 5 will be equal to 5 into 5 plus 1 by 6. No, I can only use this when the numbers, consecutive natural numbers, are starting from 1 itself. Sir, when will you an academy and test series come? Right now, I don't have the information for that, Aryabhata. Sir. Okay. Right? 1 plus 2 plus till n. Now, you see, sum of first n natural numbers can be given by n into n plus 1 by 2. Suppose if I'm doing 1 plus 2 plus 3, so 3 natural numbers, that means their sum will be equal to 3 multiplied with 3 plus 1 divided by 2. And I know that this is equal to 6. If I'm adding up first 10 natural numbers, let's say, so this will be nothing but 10 multiplied with 11 divided by 2. So it will be 55. You get my point? Right? So this we should know, that sum of first n natural numbers starting from 1 will be equal to n divided by n multiplied with n plus 1 divided by 2. And similarly, sum of squares of first n natural numbers, sum of squares of first n natural numbers will be defined as n multiplied with n plus 1 multiplied with 2n plus 1 divided by 6. Okay, this one you have to remember. And these are proven either by AP methods or by mathematical induction also. We can prove it right now. You don't need to worry about the proof. Just remember that this is the case. If you are adding up cubes, sum of the cubes of first n natural numbers will 1 cube plus 2 cube till n cube will be just square of this thing, n into n plus 1 by 2 whole square. Simple to remember. This is n into n plus 1 into 2n plus 1 divided by 6, and this is n into n plus 1 divided by 2 whole square. Now, the thing is, sir, how are the questions going to be? Let's see some questions. Now, before seeing some questions, I want to put your attention over one very important thing. What did we say about an AP? We said that any general term of an AP is A plus n minus 1 into D. We said this, correct? General term. Now, when I'm writing sigma Tn, okay, where n is from 1 equal to n equal to n. Okay, that means n is starting from 1 and it is going till n. What would this mean? This would mean T1 plus T2 plus T3 plus T4 plus T5 till Tn, isn't it? Won't this be? And what do we call it? Sum of all the terms is called as sum of n terms. Sum of n terms of an AP. So naturally, if I'm applying sigma over Tn, that means nth term, general term, if I'm applying sigma over general term of an AP, it should be obvious and it should be natural that sum of n term should be obtained. Let's see, can we obtain it or not? Let's see. Okay, so now what is Tn? I am applying sigma over A plus n minus 1 into D. This is my Tn, this is the general term, where n is starting from 1 to n. Okay, now addition, so I can break the sigma, right? So sigma over A from 1 to n plus sigma over n minus 1 into D. That means sigma over nd from 1 to n minus sigma over D from 1 to n. Correct? I can do this. Right? Nd minus D, no? So I break the sigma because there is addition. Right? I have broken sigma only on addition. Now, what would be sigma over A? A is being added up n times. A is being added up n times. So that means this is nothing but an plus sigma over nd. D is a constant, common difference, so it's a constant. I can put D outside. This will be sigma over n from 1 to n. Correct? And what will be this? Minus D is being added up n times, so this is nothing but dn. Okay, right? Now this is an plus D multiplied with what? Sigma over n, and n is iterating from 1 to n. That means 1 plus 2 plus 3 plus 4 plus 5 till n. That means sum of first n natural numbers. Correct? Sum of first n natural numbers, how do we write it? This is nothing but n multiplied with n plus 1 divided by 2. Correct? Minus dn. Can you see what I'm trying to do? Right? When you solve this, you get n divided by 2. N divided by 2 you can take common. right? Or you can take an LCM, okay, and it will come as 2a plus n minus 1 into d. When you're solving this, you are getting exactly the sum of n terms of an AP. But what do we learn over here? What do we learn over here? We learn that if you apply sigma over general term of any sequence which is recursive, which has a rule, recursive sequence means if there is a rule, then there will be general term. You'll be able to write the general term. If you are able to write the general term, when you apply sigma over the general term formula and solve it, you'll get the formula for sum of n terms of that sequence. Amazing thing, isn't it? For example, for example, let's talk about this. Now this is a series. I don't know what is this AP, GP, because when I solve this, this is 3, this is 15, this is 35, and we keep on going like this. Nothing obtained, right? Is this an AP? Is this an GP? It will take time for me to think. What smarter thing would I do is, I want to know what is SN. Okay, general term if we want to write 1, 3, 5, right? This thing 1, 3, 5, 7, 9, 11. What is the general term over here? What is the general term over here? If you use AP also, no? Tn will be equal to 1 plus n minus 1 into 2. Common difference is 2. What is this? What is this? This is 2n minus 1. General term. So general term is 2n minus 1 over here. Wow, great thing. General term is 2n minus 1 for this part, these parts, right? Only these parts I'm talking about, the first parts, right? This, and like this. Now about the second sequence, that means 3, 5, 7, 9. What will be the general term over here? Same thing, 2n minus 1? No, I don't think so. Tn will be, how will we calculate Tn? A plus n minus 1 into d, which is again, but a has changed and d is again 2 only. But this is what? This is 2n plus 1. So here the general term is 2n plus 1. So basically the thing is, now you should remember that if the odd numbers are starting from 1, the general term of that odd number sequence would be 2n minus 1. If they are starting from 3, then the general term for that odd number sequence would be 2n plus 1. Sorry, did we understand this? All right. If we have understood this, then what we can do over here, we can write Tn, the general term of this sequence. This is a sequence only. 1 into 3, comma 3 into 5, comma 5 into 7, comma 7 into 9. Correct? This is a sequence. Can we write the general term of this sequence? Yeah, we can write. This looks like 2n minus 1 multiplied with 2n plus 1. This is the general term of this sequence. What's the problem? You put n is equal to 1. What do you get? 1 into 3. You put n equal to 2. You get 3 into 5. You put n equal to 3. You get 5 into 7. Correct? N equal to 4 would give you 7 into 9. So this is the general term. This is Tn. Correct? Now what I'll do, I'll apply sigma over Tn. Before that, I'll try to solve Tn a little bit. 2n minus 1 into 2n plus 1 will be 4n square minus 1. Correct? Now I can apply sigma over Tn where n starts from 1 and goes till n. Why? Because I need to find sum of n terms. When I'm applying sigma, this Tn, sigma over Tn would give me Sn. That means sum of n terms. Correct? This will be nothing but T1 plus T2 plus T3. T1 plus T2 plus T3 means 1, T3, T4 till Tn. That means 1 into 3 plus this same thing only I'll receive. So I'll apply sigma over 4n square minus 1. I'll break this sigma 4n square minus sigma over 1, right? From 1 to n, from 1 to n. Here 4 will come out, sigma over n square minus sigma over 1 would give me n only. 1 being added at up n times. And I know what is n square. Sigma over n square means n is starting from 1 and going till n. That means 1 square plus 2 square plus 3 square plus 4 square. Sum of squares of n natural numbers. That will be nothing but 4 multiplied with n into n plus 1 into 2n plus 1 divided by 6, correct, minus n. This will be my answer. The thing is that if we are aiming towards finding the sum of n terms of a recursive sequence. Write its general term and apply sigma over it. You just need to remember sigma, sigma n square, sigma n cube. More than that, it won't come. Okay, more than that, these are all good questions and which have appeared or similar questions have appeared in PRMO. On the basis of that only you are doing. Okay, Satya? All right, all important questions, I'll think about it. All right. So what did we have? 4 multiplied with n, and if we solve it, if we solve this thing, we are getting this particular formula. Right? When you solve this, no, you'll get this formula. This will be your final answer. And now suppose if you want to find sum of 100 terms of this. So you put 100 instead of n in this formula. If you suppose they ask you to find the sum of 100 terms of this particular recursive sequence, then you just need to find the formula for sum of n terms and then put n as 100 in this formula. I hope you get my point. Okay, now let's see this. Sum of n terms of squares of odd numbers. Sum of squares of n odd numbers. What will be the formula for that? Let's try and understand. So 1 square plus 3 square, general term, Tn if I want to write. How will I write Tn? Odd numbers are starting from 1. So that means 2n minus 1 whole square is my general term. Right? So Tn is nothing but 4n square plus 1 minus 4n. Correct? Now I'll apply sigma over Tn, where n starts from 1 and goes till n. This means T1 plus T2 plus T3 plus T4 plus T5. Right? That means 1 square plus 2 square, 1 square plus 3 square plus 5 square plus 7 square and so on till n. Correct? So sigma would come on this 4 sigma 4n square plus sigma over 1 minus sigma over 4n. This will become what? 4 into n plus 1 into 2n plus 1 divided by 6. This will become n. This will become 4 into n plus 1 divided by 2. We'll solve this to get the final answer. Correct? So 2 2's. This will become n into n plus 1 into 2n plus 1 divided by 3 plus plus n minus 2n into n plus 1. Okay, so I think n into n plus 1 you can take common. N into n plus 1 will come out common for you. And then here inside you'll have 2n plus 1 divided by 3 plus 1 minus 2. This will be your final answer. We have to find the sum up to 10 terms. So this is our sum of n terms. This is our sigma over Tm would give us Sn, right? Sum of n terms. Here only if we need to find S100, sorry, sum of 10 terms. So we need to find S10. S10 will be what? 10 multiplied with n means 10. 10 plus 1, that means 11. Multiplied with 2 into 10 plus 1, that means 21 by 3, that means 7. Right? 2 into 10, 20 plus 1, 21 by 3, 7 plus 1, 8, minus 2, 6. So this is our answer. That's it. 66, 660 will be our answer. Sum of 10 terms will be nothing but 660. This is how you need to solve a sum of sequence, just like that. Are we clear to this? Uh, just check once. Okay, shall we move ahead? Okay, now let me give you a question from 2018 PRMO. Okay, from here only, over here only. Let's try this. Let's see if we are able to do this or not. Okay, the question is, I'll write from PRMO 2013. Okay. Okay, what does the question say? Question says, question is let m be the smallest odd positive integer. odd positive integer. Let m be the smallest odd positive integer for which this thing 1 plus 2 plus 3 till m is a square of an integer, is a square of an integer. Okay, and let n be, and I'm writing here, and let n be smallest odd, I've written, no, n is smallest even positive integer. N be the smallest even positive integer. Okay, even positive integer for which 1 plus 2 plus 3 till n, till n is a square of an integer, is a square of an integer. Is a square of an integer. Then you tell me uh, the value of m plus n. Come on, try this out. The question is saying let m be the smallest odd positive integer for which 1 plus 2 plus 3 till m is a square of an integer, and n is the smallest even positive integer for which 1 plus 2 plus 3 till n is a square of n integer, is a square of an integer, is a square of n integer, n integer. Okay, so how will we solve this question? Very, see, it's just the language. Most of the times PRMO questions you'll see, it's just the language which will bother you. You'll always know the concept and something to do about with the question, something to do with the question. Let's see. Now, what information do we have? What do we know already over here? We know that something like this 1 plus 2 plus 3 till m is square of this sum is square of some integer. Let's say k is that integer. Okay, let's say k is that integer and m is the smallest odd integer, smallest odd positive integer. That's what they said, no? M is the smallest odd positive integer for which 1 plus 2 plus 3 till m is a square of an integer. What is this 1 plus 2 plus 3 till m? This will be sum of m natural numbers, sum of first m natural numbers. So that can be written as m into m plus 1 divided by 2. Can't we write that? We can write it like this. This will be m into m plus 1 divided by 2. And this thing should be square of an integer, not odd or even. Square of an integer. That's why question is written very carefully. This is just a square of an integer. So we'll check. Let's say m is equal to 1. If we put m is equal to 1, what does it give us? 1 into 1 plus 1, that means 2 divided by 2 is equal to 1. And 1 is the square of an integer. 1 is the square of an integer. Suppose if we took m as 2, then it will be 2 into 3 by 2, that means 3. Correct? Which is not the square of an integer, but 1 is. So that means m is equal to 1. That means what do we find? That m should be equal to 1. Why? Because m is the smallest positive odd integer. This is odd, and the sum of one natural number is giving us the square of an integer, right? Sum of 1, m is, so we are summing up only one natural number. Sum of 1 will be 1 only, right? Sum of 1 will be 1 only. I'm saying 1 plus 2 plus 3 till m can be written as m into m plus 1 divided by 2. Correct? Now the question is telling you that sum of m is the smallest odd positive integer for which this sum is becomes the square of an integer. So what is the smallest odd positive integer? 1. Correct? Smallest odd positive integer is 1. So sum of one odd number will be 1 only. Correct? And 1 is the square of an integer, which is also correct. 1 is the square of 1. 3 is not the square of an integer. 1 is the square of an integer. That means m is equal to 1. From here, what do we find out? That m definitely is equal to 1. Now, what is about n? let n be the smallest even positive integer for which this sum 1 plus 2 plus 3 till n is the square of an integer. Okay, let's check. So we know 1 plus 2 plus 3 till n. What is n over here? N is smallest. No, n. What information have they given about m? N. N is the smallest even positive integer. Smallest even positive integer. Okay, and this sum should be equal to square of an integer. This sum should be equal to square of an integer where k is an integer. Okay, this is what the question is telling us. So we know that sum of n natural numbers will be equal to n into n plus 1 divided by 2. Now we want this thing to be square of an integer. We want this thing to be square of an integer. Correct? We'll check. We'll put n is equal to 1. What do we get? 1 into 2 by 2, that means 1. When we put n is 1 is not the square of an, is 1 the square? Sorry. Can we put n is equal to 1? We cannot put n equal to 1, no, because they have said that n is smallest even positive integer. So we'll have to start with 2. So we'll put n is equal to 2. What is n equal to 2 going to give us? 2 into 2 plus 1, that means 3 divided by 2, which is equal to 3. And 3 is not the square of an integer. Then next even number we'll try. 4. 4 will give us 4 into 5 divided by 2, which will be 10. And 10 is not the square of an integer. N equal to 6 we'll check. So 6 into 7 divided by 2, which is 21. And 21 is also not the square of an integer. We'll check n is equal to 8. Now 8 into 10 divide 8 into 9. Sorry. 8 into 8 plus 1. Na? 8 into 9 divided by 2 is equal to 36, which is square of 6. That means when n is equal to 8, 8 is that smallest odd integer. 8 is that smallest, 8 is that smallest even integer. So sum of first 8 numbers will become the square of an integer. So n will be equal to 8. What do we get? N equal to 8. And our answer will be m plus 1. N, that means equal to 9. This was the answer. How easy was this? It's just the interpretation that we have to take care of. What do you think? Correct? All right. Let's do a couple of more. Are we clear? Yes, very good. Now, something like this. Don't worry about the where are the questions from, but this question can be also asked in your Olympiads, PRMO, IOQM, also. And this was asked recently, and not recently, but in 2020 in JEE Mains. Now, but we have to understand what is it saying. Here we need to understand what is the sigma saying. Okay, sigma is over 1 plus 2 plus 3 till k. So naturally one thing which comes in our minds are this means that sigma over this means this is nothing but sum of k natural numbers, k into k plus 1 divided by 2. Now we'll put k equal to 20 and this will become 20 into 21 divided by 2 and answer will be 210. How many classes more of this lesson? I think 2 more. Okay, 2 more. Okay, sigma, we have started doing PYQs now, so we have reached a good level. Now 2 more and we'll be done. Okay, then you'll be able to attempt all the questions and solve them. Right, this comes in our mind. But here the understanding of sigma will help us understand that this is not what we are supposed to do. What is the iterator? Iterator is k. Correct? Iterator is k. Right? Iterator is k. And summing up, we are doing sum up till k. So this would mean sigma over this would mean then first k is 1. So we'll just add it till 1. Then k will be 2. So we'll add two numbers 1 plus 2. Then k will be equal to 3. Then we'll add three numbers, 1 plus 2 plus 3. Then k will be equal to 4. So we'll add four natural numbers. And we'll keep doing this till 20. We'll keep doing this. Why? Because k is till 20. 9. 1 plus 3 plus 6 plus, right. That thing only. 1 plus 3 plus 6 plus 10 plus 14 plus 19. Very good, very good. Right. Correct. 2, 4. You can also solve it with, if you are thinking, you can also solve it with method of difference. But you see how helpful will summation be over here. Summation will be very helpful over here. So Shreyansh has written something. He's written 1 plus 3 plus 6 plus 10 plus 14 plus 19, right? So here there is one more approach which students learn, method of difference, which we can also use over here. So this is same thing only. This is what it is asking, but the question, the asking of question is way different than what we can think. But you see, if we can understand this, we can solve that also. Suppose Shans, that thing came. What does the question say? Question is saying this only. This is what the question is saying, Mithil. This sum we need to find. Right? First 1 plus 3 plus 6 plus 4 into 5 by 2, that means 10. Right? 14, then 19. This is what we need to find till this sum. 20 into 21 by 2 till 210. 1540. Shreyans is saying. But can we do something else? See, inside sigma itself, there is a summation series. Inside sigma itself, there is a summation series. So this summation series, so we know, na? 1 plus 2 plus 3 till k. That means sum of k consecutive natural numbers starting from 1. Okay, so this means k into k plus 1 divided by 2. And now we'll apply sigma over here. K equal to 1 to k equal to 20. Problem solved. So 1 by 2, because it's a constant, will come out. Inside what we'll have? K square plus k. From 1 to 20. So 1 by 2 stays outside. Sigma over k square from 1 to 20 plus sigma over k from 1 to 20. This will become 1 by 2, right? Sigma over k means sum of squares of first 20 natural numbers. That means n into, sorry, 20 into n plus 1. That means 20 into 21 into 2n plus 1. That means 2 into 20 plus 1. That means 41. Divided by 6 plus sum of first 20 natural numbers. That means 20 into 21 divided by 2. And this will be our answer. This thing will be our answer. Got my point? After this, which lesson? After this, PNC ma'am is teaching right now. Geometry also is going on. Let's see. Let's see. Let's get over with this first. Whatever. Okay. We'll decide. Calculate this. Please calculate this. Two threes, to 10, 3, 7, 17 to 41 plus 210. 210 multiplied with 1 by 2. This thing. So 2870 plus 210 divided by 2. I think 313080 divided by 2. Yes, your answer was correct. 1540. 1540 was correct, chance. Very good. Right? This would be the answer. 1540. Okay. This can also be asked. Now let's do one more PYQ. Let's do. Okay. Then we'll do the other type of questions. Let's do one more PYQ. Then I'll teach you if more sigmas do come. Okay. Okay. Let's do this. Question is simple. This question was asked in 2013. Okay. Question is very simple. It is asking you the maximum what is the maximum possible value of k today. Because of crunch of time I couldn't get this typed. Next time I'll get this typed so that we can save the time. For which 2013 can be written as sum of k consecutive positive integers. Can be written as sum of k consecutive positive integers. Sum of k consecutive positive integers. Good question. You have to tell me what is the maximum possible value of k for which 2013. Sir, have you taught double sigma? No, I didn't teach till now. I'll teach. I'll teach you double sigma also. Double sigma is going to come. Don't worry. Okay. Before that, try to solve this. What is the maximum possible value of k for which 2013 can be written as sum of k consecutive positive integers? Read the question very carefully. This is the most, sir, I learn all the concept, but I cannot be able to solve the questions. Beta, maths is like that. Okay, don't give up. If you give up on solving the question, with everybody the same thing happens. Learn the concept, but difficult to solve the questions. See the solution once. From the next question, again fight very well. If you stop fighting and keep looking for the solution and give up, math is not your cup of tea then. But it's not that difficult also. It's not that hot of a tea, but okay, keep trying, keep fighting, be a good fighter, and so on. Quadratica. I don't know. What is the maximum possible value of k for which 2013 can be written as sum of k consecutive positive integers? Very, very carefully you'll have to read this question and understand this question. Okay, because you can do one mistake. You know what's the most important thing to read about in this question? This thing. K consecutive positive integers. It's not anywhere intending or implying that we are talking about first k natural numbers. The formula which we have learned, no, n into n plus 1 divided by 2 is for the first n natural numbers starting from 1. That formula is not for any consecutive sequence of natural numbers. It's not for that. Yeah. So how do we solve it? What is the maximum possible value of k for which 2013 can be written as sum of k consecutive positive integers? By consecutive positive integers, let's say something like this is happening. Okay, a plus 1, a plus 2, a plus 3. Correct? This is what's happening. Sir, 1 minute. Acha, theek hai. 1. All right, I'll give you a minute. Come on, solve it. Maximum value we have to look at. Can you see that? Maximum. Shall I start? Okay, let me explain. Let me keep explaining. You do. All right. A plus 3 like that like this sequence is going. Right? Like this first number, second number plus third number, fourth number, like this. Like this. We started from A and consecutive numbers, so difference is going to be 1. Correct? Consecutive numbers, so difference is going to be 1. Do you believe that? Okay. And what will be the any general term? We are talking about k positive numbers, k positive consecutive numbers. Correct? K positive consecutive natural numbers. So here first second term is a plus 1, third is a plus 2, fourth is a plus 3. So kth term will be a plus k minus 1. Correct? It will be a plus k minus 1. Sorry. formula, that sigma formula is not going to work, but we know n terms. This is an AP only. We know sum of n terms of an AP, right? What is the formula for sum of n terms of an AP? Right? How many terms are we adding? K terms. Sir, K divided by 2. K terms we are adding, no? K terms we are adding. What is the question? I'll make you read this again. What is the maximum value of K for which 2000 can be 13 can be written as sum of K consecutive positive natural numbers? So sum of K consecutive positive natural numbers, it's not starting from 1, Shreyansh. It's not starting from 1. Otherwise, I would have used K into K plus 1 divided by 2. Who said it is starting from 1? That's the question. That's the beauty of the question. Nowhere it is saying that we are not talking about sum of first K consecutive natural numbers. We are talking about sum of K consecutive positive integers. Okay, so we have just this formula. K by 2 into first term, that means 2a, plus n minus 1d. Instead of n minus n, we are talking about K terms. So K minus 1 into d, which is 1 only. D is 1 only. This should be equal to 2030. And in this, what should be the maximum value of K? That's what we need to find. In this, what should be the maximum value of K? Okay, Ji. Okay. Now think. What do you think? Now tell me. Okay, let's sort this a little bit. What else we can do? Right? Let's sort this a little bit. We know one thing. Okay, we know one thing, that A is positive. Yes or no? Because K consecutive positive integers. So A is positive. Right? Here in the bracket somewhere we can write A is positive. Not even 0. Positive means positive. 0 is neither positive nor negative. A is positive. Okay. So K divided by 2, this side something like this. What we can do is 4026. This will become, so 2a plus K minus 1, okay ji, is equal to 4026. Okay, and now so our A will be equal to 4026. Acha, 4026 divided by K also, here divided by K. Okay, it will be 4026 divided by K plus 1 minus K divided by 2. Here 2 will also come. This is what we are getting. And we only have one piece of information, that this macha A is positive. This boy A is positive for sure. That's what we know. Now we'll check at, bhai, if this value is decreasing, then only we'll be able to find. Then only we'll be able to find our answer. Otherwise, we cannot find. This particular value should be decreasing. We know K is a natural number, right? So if we put K is equal to 1, what are we getting? On K equal to 1, calculate. 4026 plus 1, 4027, minus 1, 4026 divided by 2, that means 2013. Okay, 2013. What is the asked in the question again? What is asked in the question again? Maximum possible value of K. So that 2013 can be written as the sum of K consecutive positive integers. But till now we just reached K equal to 1. Now we'll check at K equal to 2. Check at K equal to 2. Value should be decreasing, and definitely this value is decreasing. K equal to 2, that means 2013 plus 1, 2014 minus 2, 2012 divided by 2, right? 2012 divided by 2. Getting my point? Value is decreasing, yes or no? You tell me, value is decreasing, yes or no? By one way is that you could factorize the right part. Yeah, some student is writing that this also could be factorized. Sir, I start preparing for you can, beta. You start. If you keep thinking about how to complete the syllabus, then it will never get completed. Right? The key to avoid procrastination is start today. Start now. That's it. At K equal to 2, what are we getting? 1006. That means values are decreasing now. So you tell me what can be the maximum value of K. You try 3, 4, 5, 6, everything now. At K equal to 2, this is 2013 plus 1, and at K equal to 3, this would be 1342 minus 3 plus 1 divided by 2, that means 670. You'll have to check like that. Okay, but we cannot check like this. Yeah. Wait. We'll have to do something else also. We'll have to check the factors of 4026. We'll have to check the factors of 4026. That also we'll have to take in account. Otherwise, we'll keep doing this k equal to 1, k equal to 2. You're getting my point, right? You'll have to check the factors of 4026 because this k is an integer. So factors of 4026 you'll have to check. Okay, 4026 factors you'll have to check. Check the factors, guys. This is going from okay, 2 also. Right, so 2 and 4, 2013 will be 1, then 3, from 3 it will go at 1342, 3 6 18 213731. Okay, and this will go from 3 again, 3 to 1 1, no 3, it won't go from 3, it will go at 11, 6 or 66, yeah, 11 66 and then 1 and then 61. 61 is prime, right? 61 into 1. So yeah, we can check with 61. The highest one is 61. Check at 61, no? Directly check at k equal to 61. We can check at 6, 33, 22 and 61. Right? So k equal to 61. Let's check at k equal to 61. What is the value that we are getting? 4026 divided by 61 plus 1 minus 61 divided by 2. If this is the least, we can check, right? Because whatever k is, it has to be a factor of 4026. Whatever k is, k has to be a factor of 4026. So we just need to check the factors of 4026. Are you getting my point? Yes or no? So this will come as 66 minus 61 plus 1, 3. This is coming out as 3. Now check at 60. There is no other factor, right? There is no other bigger factor. So 61 would be our answer. Even if we check at 62, no, it's not going. There will be a negative value. You see, values are decreasing. So at k equal to 61, we are getting 3. At k equal to 61, we are getting this value 3. That means our answer is nothing but k equal to 61. This is our answer. Because k has to be what k needs to be. K needs to be the maximum possible value for which 2013 can be written as sum of k consecutive positive integers. So k should be 3 only. K is equal to 61. That means 2013 can be written as the sum of 61 consecutive positive integers. Yeah, Siri, tell me. Tell me quickly about this. About this, do we have a question? Hanji? Come on, Siri. Okay, thank you, Zoltar. So you see, PRMO questions, if we have understood the concept and if we are reading and interpreting the question very correctly, then we'll be able to solve PRMO questions very easily. Yeah, tell me, Siri, whatever it is. Okay, a couple of more. All right, one question I'll give you. You can solve it. Right, you can solve it. This question is from uh, PRMO 2018. Oh, sorry, 15 or 18. Pata nahi. Year is not written. Okay. You have to find the. Okay, this is the series 1 3 3 3 5 5 5 5 3 4. Okay. This is the series. You have to find this series 2016th term. Find 2016th term of this series. This is PRMO 2015. Give it a try. Come on, guys. 1 3 3 3 1, then 3 times 3, 5 times 5, 7 times 7. Okay, come on. What will be the 2016th term of this sequence? I'll give you a minute for this. Easy this is. 2016th term of this sequence. All right, we'll start with this, sir. Show that n square plus 20 by n is divisible by 48. N square plus 20 into n is divisible by 48. Sound is not clear. Better now? The sound is clear now? Is the sound okay, guys? Hello, hello. Hello. Yeah. Right. So sorry, I think there was a lag or some interruption. I hope it's better now. We were. Can you explain the above question? So series saying n square plus 20 into n is divisible by 48. There must be some information about n also, bache. There must be some information about n, otherwise it's not true. It's not always. Okay. Now, if it is divisible by 48, then you can do something about it. I think your question is half complete. Yeah, the question was to find its 216th term. I hope you guys tried solving this. Now, what do we know already? What do we know already? We know that, we know this, right? Sum of one odd natural number is equal to 1 square. Sum of two odd natural numbers is equal to 2 square. Sum of three odd natural numbers is equal to 3 square, right? Sum of four odd natural numbers is equal to 4 square, right? We know this, correct? We know this information already. Sum of one natural number will be equal to 1 square, like this. Okay, but how do we use this, sir? We don't need to find the sum, we need to find 2016th term. But what is the pattern? See, one term, so 1 square. Now, second natural number, till second odd natural number, we have 4 square, like 2 square, right? 4 terms, right? Till here we have one term, till here we have 2 square terms, till here how many terms we have? 5 plus 3 plus 1, that means 3 square terms, right? Till here how many terms do we have? 4 square terms. And these are 4 odd numbers till now. Till here we have 16 terms. You can see that till here we have 16 terms, and we have 4 natural number, 4 odd numbers till now. Till here 1 term, till here 2 square terms, till here 9 terms, so 3 square, and till here 4 square, so 16 terms. Now we need to find the 2016th term. Okay, so that means some square number near 2016. I know 45 square is equal to 2025. If we calculate 46, no, 44 square, let's calculate 44 ka square. So 44 square would be 1936. Okay, 44 square will be 1936. Okay, so 44 square is 1936 and 45 square is 2025. We need to find 2016th term. What does this mean? That means till till 44th natural number, till 44th odd number, we will have 1936 terms over here. Till 40, till second odd number we have 4 terms, till third odd number we have 9 terms, till fourth odd number we have 16 terms, which is 4 square. So till 1936, till 44th odd natural number, we will have 1936 terms. We need to reach at 2016. Okay, so 2016 minus 1936, if we do, how much do we get? 2016 minus 1936, if we do, okay, 80 terms we have, right? We didn't even have to, yeah, 80 terms, right? 80 terms to go. That means we have to go 80 terms. That means, right, till 1936th term, we will have, till 1936th term, we will have 44th odd number. Which is 44th odd number? 88 is our 44th odd number, right? Till 1936th term, 1936th term, we will have 44th odd number, which is 88. 44th odd number will be 88, no? Correct? 44th odd number, second odd number is 3, third odd number is 5, right? 3 2s are 6 minus 1. 44 odd number will be 88. 44th odd natural number will be 87. 87, right? 44th odd natural number will be 87 only, no? So now we can calculate. And what will be the first odd number which is after 44? It will be 89. Correct? So 1937th term, the 1937th term will be 1981 again. Right? So we have so the 80 terms, then after 80 terms, we'll have to subtract 45 more. So 45 times 45 will appear. So our answer will be 89, right? Till 89th term, this will keep going on. Till 89th terms, this will keep going on. So that means 2016th term, 2000 till 2015th term, till 2015th term we will have 89, and then 2016th term will be our 91. This will be our answer. Okay, I hope you have understood this. Very good question. Logical, no sequence and series. We just needed a simple information how to go, how to approach the question. Right? Understood my point, right? Till 44th odd natural number, which is 88, we'll keep having 1986, 1936. Then 89 will come for 45 times. And then we'll have 91th term. Till 89th term, we'll have 40, like 44th odd number only. Till 1936th term. Then 1936 plus 45, we will have 89, and then for 2016 we will have 91. This is how we'll have to calculate this. Now some more things, a few more type of questions I'll show you. Just give me a minute. One more type of series which I needed to show you, which is just a minute. Array. The one which Shreyansh was talking just now. I want to pay your attention towards that also. Okay. This type of sequence, right? This is also something which you should know how to solve. Find the nth term of the following series, right? Suppose if we have something like this 5 plus the, if you are given with sum and you have to find the nth term of this series, how will you do that? Now whatever is given to you is sum of n terms, right? 5 plus 7 plus 13 plus 31 plus 85, like this. Now directly if we see, this is neither forming an AP nor forming a GP, but if we look at the difference, 7 plus 5 is 2, then 13 minus 7 is 6, then 31 minus 13 is 18, correct? And this is 54. So 2, 6, 18, 54 is forming a GP for me, but directly I'm not able to see, in this I'm not able to see that if there is an AP or GP. But suppose difference of the terms is forming an AP. This is called telescoping. This is what we call telescoping. Now difference of these terms is forming an AP form, is forming a geometric progression for me. 2, 6, 18, 54 is a geometric progression with common ratio of 3, right? So in this case, what can I do? In this case, what can I do? Now this is going to be till some term Tn, right? Tn. This is going to be till some Tnth term, right? Nth term. What am I going to do is, I'll write the same thing again. Sn only I'll write. I'll write the same thing again, but I'll shift the terms. I'll shift the terms. 5 plus 7. The method to do this is just shift the terms like this. 5 plus 7 plus 13 plus 31, right? Till second last term and last term. Last term will be Tn, second last term will be Tn minus 1, but obvious. Why did I do this? Because when I'm subtracting this, when I'm subtracting over here, I can see that Sn minus Sn will become 0. Subtract this side. So 5 minus 0, 5 plus 7 minus 5, 2. 13 minus 7, 6. 31 minus 13, 18. Right? 85 minus 31, 54. Right? Tn minus Tn minus 1. Correct? And because we are subtracting, here we'll have minus with Tn because we are subtracting these two. Now see how magic will happen. This thing I know is a sequence which I know to solve. Geometric progression. Simple. Right? This minus Tn I'm going to bring over the left side. And this side I'm going to have 5 plus 2 plus 6 plus 18 plus 54. Till how many terms are these? How many terms are these? N minus 1 terms. Right? Because we have shifted the series. So these are n minus 1 terms. Because we have shifted the series, no? Till here we had n terms. These are n minus 1 terms. Getting my point? We have shifted the series. So this sum is for n minus 1 terms. Got my point? Till n minus 1 terms. Now, Tn will be equal to what? 5 plus. This is sum of n minus 1 terms. What is the sum of n minus 1 terms? For a geometric progression, a into 1 minus r to the power n divided by 1 minus r. That means 2 into 1 minus a is 2, 1 minus r is 3, 3 to the power of n minus 1 divided by 1 minus 3. That means, or we can do ulta also, because here negative will come. So to get rid of negative, we'll write 3 to the power n minus 1 minus 1 divided by 3 minus 1, which is 2. That's it. So 5 plus 3 to the power n minus 1 minus 1, that means 4 plus 3 to the power n minus 1 will be its Tn, nth term, any term. Correct? See, first term, if you see T1, what will be T1? 4 plus 3 to the power 1 minus 1. That means 4 plus 3 to the power 0. That means 4 plus 1. So 5. What will be second term? T2. 4 plus 3 to the power 2 minus 1. That means 4 plus 3, which is 7. Third term, T3. 4 plus 3 to the power 3 minus 1. That means 4 plus 3 square. 9 plus 4, 13. Got my point? So this is how you can calculate the general term of a sequence where directly you are not able to observe anything, but your differences are telling you something. The difference between the terms is telling you something. Okay, let's see this. Okay. Yeah, this question was asked. This is one question. Okay, let's see this. If we observe that directly we are not able to observe anything, 11 minus 5 is 6. 11 minus 19 is 8. This is 10. This is definitely 12. Okay, AP is forming. What we'll do, we'll apply method of difference. What we'll write, we know that sum of n terms for this thing is given to me as this. Okay, for n terms till some term Tn. Right? This is being added. Now I'll shift it because difference is working, so I'll shift it. 5 plus below this will come Tn minus 1 and here will be Tn. Okay, now I'll subtract both the sides. So 0 will be equal to 5 plus 11 minus 5, which is 6, plus 8 plus 10 plus 12, and likewise till Tn minus Tn minus 1. Minus Tn. Minus because we are subtracting. Minus is coming because we are subtracting. Main topics are these only, beta. Recursive series is one of the main topics. PNC is one of the main topics. Geometry is very important in IOQM. So these three you should pick first, I think. Right? Recursive series, combinatorics, and your geometry. Okay. These three things are must. Okay. Now minus Tn I'm shifting on this side. So it will become positive Tn, and this side I have 5 plus. This is sum of AP. How many terms are there? N minus 1 terms are there. How many terms are there? N minus 1 terms are there. Correct? Right? N minus 1 terms are there. So sum of n minus 1 terms is equal to n minus 1 divided by 2 into 2a, that means 12, plus n minus 1 minus 1, that means n minus 2 into d. D is equal to 2. D for this AP is equal to 2. That's it. So this is our Tn. Tn is equal to 5 plus n minus 1 divided by 2 multiplied with 12 minus 4, that is 8, plus 2n. So it will be equal to n, so Tn will be equal to nothing but 5 plus n minus 1 multiplied with n plus 4. And yes, this is our formula for nth term. We can check also. Put n is equal to 1. So 5 plus 0 will be equal to 5. Put n equal to 2. 2 minus 1, 1. 2 plus 4, 6. 6 into 1, 6. 6 plus 5, 11. Third term. Put n equal to 3. T3 will be equal to 2 into 7. That means 21 plus, 2 into 14 plus 5, 19. Yeah, correct. And when you put n equal to 3, you'll get 29 also. My geometry is weak. Beta, practice from the books recommended. Okay, practice that. Are we clear? So what are they asking? The sum of first 20 terms of this series. Sum of first 20 terms they are asking. Can we find sum of first 20 terms? By Tn we got, Tn is what? We got Tn is equal to 5 plus n minus 1 into n plus 4. This is our common term, this is our general term. What do we need to find? Sum of 20 terms. So first we'll need to find the sum formula. So we'll have to apply sigma over it from n equal to 1 to n equal to 20. Okay, what is this? Sigma over 5 plus n square plus 4n minus n, that means plus 3n. Okay, minus 4. Sigma over this entire thing we'll have to apply. Okay, from 1 to 20. So this will be sigma over 5 minus 4, 1. So this will be n square plus 3n plus 1 from 1 to 20. Right? Break the sigma. Sigma of n square plus 3 into sigma of n plus sigma over 1. Or sigma over 1 we know already is equal to n, where n is equal to 20. We are finding for 20 terms, so this will be equal to 20. What will be this? N square. N is 20, so 20 into 21 into 2 into 20 plus 1. That means 41 divided by 6. Plus 3 multiplied with 20 into 21 divided by 2. Plus 20. This is what should be our answer. This is what should be our answer. Let's calculate this. So 2 3s, 10, 7, 10. Okay. So 70 into 41. 2870 plus 63 into 10. So 630 plus 20. So 2870 plus 650 is going to give us 3520. Let's check. Do we have this option? 3520 is an option. Okay. So this is how you can solve these kind of series also. No need to worry. And these do come in IOQM sometimes. But if you can write the general term, the basic idea which we have learned today is, if you are able to write the general term of any recursive series, you can apply sigma over it to solve the question. Sigma is such an amazing thing. And only 3 formulas of sigma you need to know. You just need to know the rules, and that's fine. Now I'm going to give you a homework question. Today's homework, please note this down. Your homework question is, your Sn is given to you like this: sigma from k equal to 0 to k equal to n, and sigma is applied over this 1 divided by root of k plus 1 plus root over k. Okay. This is your Sn. Then find, what you have to find is, find sigma from n equal to 1 to 99. Okay. On 1 divided by Sn plus Sn minus 1. Okay. This is what you need to find, the value of this. Okay, till 99 it is. Here it is 99. Okay, we'll start from here in the next class. So let me give you a little bit of kind of introduction towards what we are going to do. Okay, one or two practice questions I'll make you do. So there is one thing called telescoping, right? There is one thing which we understand, which we call as telescoping of the recursive series, right? Telescoping means, the fundamental idea behind the word telescoping or telescopic series is that series might look very big, but when you look closely with telescope, when you look closely with a telescope, you will see that no, series is not that of big also, it's very small, and you know, we can solve it very easily. For example, the series which is over here, if we look at this series, now what happens is whenever you are, this is not 1.2 for your information, this is 1 multiplied with 2, okay, 1 into 2 and 2 into 3, so this is 1 by 2 kind of, this kind of series, this is this kind of series, this is 1 by 2 plus 1 by 6 plus 1 by 12, right? So 2 into 1, then 2 into 3, 1 into 2, then 2 into 3, then 3 into 4. Now whenever this happens, what you can do is, you can, you closely observe the difference between these terms, right? The terms which are being multiplied in the denominator, you closely observe the difference between terms. So 2 minus 1 is 1, 3 minus 2 is 2, 4 minus 3 is 1, 3 minus 2 is 1 and 4 minus 3 is 1. The difference between the product terms is constant. Okay, so what we can do, we can write the same thing as 2 minus 1 divided by 2 into 1, right? Plus 3 minus 2 divided by 3 into 2, plus 4 minus 3 divided by 4 into 3, right? And likewise it will keep going on. So n into n plus 1 is the general term, right? 1 by n into n plus 1 is the general term. If I talk about the general term seems to be like this. Tn is what? Tn is 1 divided by n into n plus 1, right? Where n is starting from 1 and going till n, right? This is our general term. But here, this kind of series we don't need to solve by using the general term. So any term, let's say the nth term, we write 1 by n into n plus 1. Okay, this is the nth term. Now if we see, now a minus b divided by ab is what? A divided by ab minus b divided by ab, correct? This is what we are going to do, right? A minus b divided by ab is nothing but 1 by b minus 1 by a, correct? So same thing we can do over here. That means 2 divided by 2 into 1 minus 1 divided by 2 into 1 plus 3 divided by 3 into 2 minus 2 divided by 3 into 2 plus 4 divided by 4 into 3 minus 3 divided by 4 into 3, right? Here also, this term also we can break and write. We can write it as n plus 1 minus n divided by n into n plus 1. Right, so last of the terms will be 1 by n minus 1 by n plus 1, right? The bigger term we are writing first, so it's better that n plus 1 by n, this will be what? 1 by n minus 1 by n plus 1, right? If we pay attention, what is happening? 1 minus, this is what? 1 by 2, plus this is what? 1 by 2, minus this is what? 1 by 3, this is what? 1 by 3, minus 1 by 4 plus 1 by 4 will be there, and it will keep going on like this. When we see this, these terms are going to get cancelled. This is what we call telescoping. That means when we looked closely, the series is not that big also. It is very small series. Okay, n plus 1 minus n upon n into n plus 1. Yeah, that's correct. Okay, so you can see that till here, last term, everything is going to get cancelled. All the terms, we started from here, till the last term, everything will get cancelled. So whatever this is, sum of all the n terms will be nothing but 1 minus 1 by n plus 1. Right? Only last term will remain because there is nothing to cancel it. Second term with third term with fourth term, last term will remain, nothing is there to cancel it. So 1 minus 1 by n plus 1. This is our sum of n terms. What are they asking? So we'll solve this n plus 1 minus 1 divided by n plus 1. So this is nothing but n upon n plus 1. This is sum of n terms. We can clearly see, and just understand this, learn this very closely, right? 1 by n, okay, or you can simply write it like this also, 1 upon 1 minus 1 by n plus 1 is your, here is your answer. Okay, 1 minus 1 upon n plus 1 is your final answer. If you look here also, same thing. Here 7 minus 3, here you will do 7 minus 3 divided by 3 into 7. The difference is constant. 7 and 11, difference is constant. 11 minus 7 divided by 7 into 11, right? Here what will you do? 15 minus 11 divided by 11 into 15, till nth terms, right? So 2n plus 1 into 2n plus 4, okay? 2n plus 1 into 2n plus 4 is your general term. You can write like this. 2n plus 4 is your general term. If you don't want to apply sigma this way also, you can do. So this will become what? 1 by 7 divided by 3 into 7 will be 1 by 3 minus 1 by 7 plus 1 by 7 minus 1 by 11 plus 1 by 11 minus 1 by 15, and it will keep going on like this. So here what terms, but one thing which we need to do, because the common difference is 4, so 4 is being multiplied in the top, so we'll have to divide by 4 also to balance the things, right? 1 by 4 also we'll have to do, correct? So what will this become now? This will be 2n plus 4 minus 2n plus 1. 3. 2n plus 5 it will be, na? हाँ यार, 2n plus 5 it will be. n is 1, so 2n plus 1 will be 3, and 2n plus 5, yeah, 2n plus 5 it is, 2n plus 5, yes, 2n plus 5 will be your general term, divided by 2n plus 1 into 2n plus 5. So when you telescope it, all these terms are going to get cancelled. What will you have eventually? 1 by 3 will remain, minus, which term will remain from here? 1 by 2n plus 1 minus 1 by 2n plus 5. So 1 by 3 minus 1 by 2n plus 5 will remain. The last term will remain. This will be your sum of n terms. That's it. Now if you want to find the sum of 100 terms, just put n as 100 over here and you will have sum of 100 terms. This is what we call telescoping. Alright guys, did we understand this? Did we understand this? Are we clear over here? Okay ji. Right, now let's see some questions which are specifically for RMO and IOQM. Okay, let's do one more like this. For example, here also what do you have? Here also telescoping will happen, because 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 4 is 2. That way you can do the telescoping here also. Suppose if I do 4 minus 2 divided by 2 into 3 into 4, right, plus here 5 minus 3 divided by 3 into 4 into 5, plus 1 divided by, plus here we'll do 6 minus 4. 6 minus 4 divided by 4 multiplied with 5 multiplied with 6. Right, keep doing that, and here we'll have 102 minus 100 divided by 100 into 101 into 102. Why did I do this? Because I know that the difference, this difference is fixed. This is 2. This is 2. So I'll just divide by 2 to make things balance, so that things get balanced. Now what is happening? See, 1 by 2. Over here what do we have? 1 by 2 into 3 minus 1 by 3 into 4. Plus 1 divided by 3 into 4 minus 1 divided by 4 into 5 plus 1 divided by 4 into 5 minus 1 divided by 5 into 6, right, this way. So these terms are getting cancelled. All these terms will get cancelled. Here what will you have? 1 divided by 100 into 101 will get cancelled. 1 divided by 100 into 101, this will get cancelled, right, minus 1 divided by 101 into 102 will remain. This will remain. So basically what do we have? 1 by 2 into 1 by 6 minus 1 divided by 101 into 102. Okay, this thing is given to you equal to k divided by 101, and likewise you can find your k also. So telescoping means looking closely. This is what the scenario is. Are we clear? Okay. So you can see your answer will be 286. 286 will come as your answer. When you solve this, you'll get k is equal to, acha 34k they have asked, so 34k will be equal to 206. Okay ji. So this is one thing, and this is used a lot of times in our questions also, PRMO questions. Now let's do some practice with some PYQs, or previous year questions, and some good questions based on recursive series. Alright. For example, let's start with this question. In a geometric series of positive terms, the difference between the fifth term and fourth term is 576, and the difference between the second and first term is 9. What is the last two digits of the sum of first 5 terms of this series? Basic GP question. Okay, we should have knowledge of AP GP in good depth. Okay, good in-depth knowledge we should have for AP GP, AGP, and telescoping if we want to solve the questions of PRMO. Okay, so they are saying geometric series of positive terms and the difference between the fifth and fourth term. So AR square, AR cube, right? AR to the power 4, AR to the power 5. This is what we have. AR square. Here it will be AR, here A. Okay, so fifth term is AR to the power 4, right? Fifth term will be AR to the power 4, and fourth term will be AR cube. So T5 minus T4 is given to us as 576. By this we understand that A is the first term, R is the common ratio. So AR to the power 4 will be the fifth term, and AR cube will be our fourth term. This difference is given to us as 576. No problem. Then they said the difference between second and first term, second term and first term. Second term will be AR, first term will be A. This difference is given to us equal to, this is given to us, first term is 9. So we understand that AR minus A is equal to 9. Right? From the first equation, what do we understand? So AR cube, if I take common, then I have R minus 1 over here. Okay. And from this one, if I take A common, then R minus 1 I have, and 576 divided by 9. I just divided these two equations. This is first and this is second, because I want to solve, no, I want to get rid of A. So I got rid of A directly, and I got rid of R minus 1 also, and R cube I am directly getting. This is 9 8s are 50, 9 6 are 54, 3 6 9 4s are 36, so 64. I get R cube is equal to 64. Now R definitely has to be positive because it is the geometric progression of positive terms. So definitely there is only one solution, that R is equal to 4. Now they are asking what is the last two digits of the sum of first 5 terms of this series. Sum of first 5 terms, sum of 5 terms. That means what is the sum? A into R to the power n minus 1 divided by R minus 1. This is our sum formula, sum of 6 terms. So that means A into R to the power 5 minus 1 divided by R minus 1, right? What is our R? 4. So A, and if R is 4, we can also find A na. If R is 4, then AR minus A, that means 4A minus A is equal to 9. That means 3A is equal to 9. That means A is equal to 3, R is equal to 4. A is 3, R is 4. So 3 into 4 to the power 5 minus 1 divided by 3. That means 4 to the power 5 minus 1 will be our answer. And last two digits we need to tell. So can you tell me the last two digits? For cyclicity you can use, right, 4 to the power 5, otherwise also you can 2 to the power 10, 1024 minus 1, that means 1023. This will be 1023. What have they asked? What is the last two digits? 23 is the last two digits of the sum of first 5 terms. S5 we need to find out. So this is our formula. I hope we are clear. Any comments, anything? Next question. Next question. Okay, let's go ahead. Next, this is a very good question. Try it. Give it a try. It is saying that there is a sequence recursively defined, that this sequence is recursive. They have already told, so you have to believe in it. Okay, f0 is 0, that means 0th term they are saying is 0, f1 is equal to 1, and fn is the remainder when fn minus 1 plus fn minus 2 is divided by 3 for all n greater than equal to 2. Thus the sequence starts like this: 0 1 1 2 0 2, and this the sequence also they have given. Now they are asking what is this sum, f2017 to f2024, what is this sum? They want to know this. So how, whenever this type of thing happens, that they are giving you terms to make the sequence, you don't know which type of sequence is this. So best approach is that you understand this sequencing, this term definition. Term definition means what do we mean by Tn, what do we mean by Tn plus 1, T0, something like this. So f0 they are saying that this is equal to 0, f0 is equal to 0, f1 they are saying is equal to 1. f0 is maybe 0th term, 0th position, some they have defined it like this. Okay, position. Now fn, any general term, fn is defined for n greater than or equal to 2, because 0 and 1 they have already given. Now fn is defined for n equal to 2 or greater than 2. fn is what? Fn is the remainder obtained when fn minus 1 plus fn minus 2. This thing is divided by 3. This thing is divided by 3. First of all, you tell me, what is the remainder when we divide 1 by 3? What do you think? What is the remainder when 1 is divided by 3? What is the remainder, guys? You tell me, what is the remainder when 1 is divided by 3? Can you tell me? Can you think of it? Right? For example, if I want to find second term, f2 will be remainder of what? Remainder when second f2 minus 1, that means f1, plus f2 minus 2, that means f0, right? So f1 minus f, just a second. Okay, f2 minus 1, okay, f2 minus 1, that means f1 plus f0. This sum is divided by 3. So f0 plus f1 will be equal to 1. That means remainder of 1 divided by 3. What is the remainder when 1 is divided by 3? The remainder when 1 is divided by 3 is 1, is equal to 1. Right? You can believe it. If you don't believe it, then just think like this. When I am dividing 1 by 3, what am I doing? 1 does not go in 3. So 3 zeros are 0 and remainder will be equal to 1. If I am dividing 2 by 3, so 3 zeros are 0 and remainder will be 2. Okay, now you can believe, right? Mostly students do know this, but remainder, after that you apply decimal. Decimal you apply after getting the remainder. Okay. So, alright, so remainder is 1. Yeah, 0, 1. First, 0th term is 0. First term is 1. F1 is 1. Then F2 is, this is F2. F2 is what? F2 is again 1. Then F3 will be equal to what? F3 will be remainder when F2 plus F1. 3 minus 1, 3 minus 2 is divided by 3. 1, that means remainder when F2 is your 1 and F1 is 1. So 1 plus 1 is divided by 3. That means remainder will be equal to 2. Right? Remainder will be equal to 2. Similarly, if we write F4, F4 will be remainder when F3 plus F2, that means 2 plus 1 is divided by 3. So F4 will become 0. What will be F5? When F4 plus F3 is divided by 3. So F4 is 0, F3 is 2. Right? 0 plus 2, 2 divided by 3, remainder will be equal to 2. F6, you can check also, this series is going like this. Right? F6 will be what? F6 will be, you have to write some terms to see the recursion. because right now we are not able to see the recursion, no. So it's better we write some of the terms so that we can see the recursion. F6 will be what? F6 will be F5 plus F4 divided by 3, that means 2 plus 0 divided by 3, that means again 2, right? F7 will be equal to what? F7, this plus this divided by 3, that means remainder will be equal to 1. What will be F8? F8. So you see the first term has not repeated yet, right? F8 will be what? 1 plus 2 divided by 3, remainder will be 0. F9 will be equal to what? 0 plus 1 divided by 3, remainder will be 1. F10 will be equal to what? 1 plus 0 divided by 3, that means remainder will be again 1. You see, if we see 0, 1, 1, 2, 0, 2, 2, 1, again 0, 1, 1 has come. Okay, you see, can you see this? Again 0, 1, 1 has come. Is it repeating? Write some of the terms. You will realize. Write some of the terms. Write some terms. Again 1, 1 has repeated. Now again if you see F11, if you see F11, I am going to write some of the terms. 1 plus 1 divided by 3, remainder will be 2. F12, 2 plus 1 divided by 3, remainder will be 0. F13, 2 plus 0 divided by 3, remainder will be 2. F14, 2 plus 0 divided by 3, remainder will be 2. Right? Correct? F15 will be what? 2 plus 2 divided by 3, remainder will be 1. F16, 1 plus 2 divided by 3, remainder will be 0. Now it has repeated. Now the things are repeating. After how many terms the things are repeating? What do you think? After how many terms the things are repeating? 0, 1, 1, 2, 0, 2. So I'll write 0, 1, 1, 2, 0, 2. Okay, 0, 1, 0, 1, 1, 2, 0, 2. Again 2, 1, 0, 1, 1, 2, 0, 2, 2, 1, 0. Now you see 8 terms, right? 1, 2, 3, 4, 5, 6, 7, 8. After 8 terms, this thing has again repeated. No, 0, 1, 1, 2, 0, 2, 2, 1. Again 0 came. 8 terms. So you can notice the recursion now. Are you able to notice the recursion? Right? We are easily able to notice the recursion. After every 8 terms, the recursion is happening. So 2016, right? After every 8 terms. So 2016 is your multiple of 2016. One second. 1, 2, 3, 4, 5, 6, 7, 8. No, 1. Right? 2016 is a multiple of 2016 is a multiple of 8. Just check once. Just check once. 2016 is a multiple of 8, definitely. Now tell me the answer. You can tell right now. Pick your answer. Wait, I'm not able to see your comments. Let me just. After every 8 terms. Yeah, all 8 terms. So till 2016 is a multiple of 8, definitely. So till 2016. Again 0 will, 2016 will be 0 again, it will start from starting. 2016 will be 0 again. Okay. 2017 will be 1, then 2, then 0, 2, 2, 1 and again 0. Right. Then just the sum of all these. So how much is the sum? 2, 4, 5, 6, 7, 8, 9. 9 should be our answer. 9 should be our answer. The series is recursive, correct? After every 8 term, you are getting 0. 8 multiple of 8, last multiple of 8 before 2017 is 2016. So F 2016 is going to be 0, right? And when F 2017 you will see 1 plus 0, remainder again will be 1. So F 2017 will be equal to 1. F 2016 will be equal to 0. Alright ji? Okay, 9 will be our answer. I hope this question is clear for you all. Let me check if there is. Good. Good. Why? Okay, next. Consider read this question. Read this question. Okay. Consider the set of numbers 1, 10, 10 square, 10 cube, 10 to the power 10. The ratio of largest element of the set to the sum of other 10 elements of the set is closest to which integer? GP question straight away, right? Largest element of the set will be 10 to the power 10, and ratio, what we need to find, ratio of the largest element of the set to the sum of other 10 elements. There are 11 elements over here, and 10 power 10s and 1 is also there, so 11 elements here. So other 10 elements, that means 1 to 10 to the power 10, sum of these. So largest element of the set is 10 to the power 10. Now divided by sum of other 10 elements, that means 1 plus 10 square plus 10 cube till 10 to the power 9. Okay, till 10 to the power 9. So we know how to find the sum. This is 10 to the power 10, and sum of 10 terms of a GP whose common ratio is 10. First term is 1, r to the power n, common ratio 10, 10 to the power, how many terms are there? How many terms are there? 0 to 9. That means there are total 10 terms. 10 to the power 10 minus 1 divided by 10 minus 1. Divided by 10 minus 1. Correct? Okay ji. This is our sum. Now this is going to be closest to 10 to the power 10 by 9, right? Obviously this is, they are asking you closest integer. Closest to which integer? This thing is closest to what? 10 to the power 10, because 1 is not making much of difference, so we can approximate it to 10 to the power 10 upon 9, approximate value, right? And 10 to the power 10 divided by 10 to the power 10 upon 9's approximate value will be equal to 9. So the closest integer which is it equal to is 10 to the power 9. So if we have studied carefully, if we know the concepts of AP, GP, formulas and all these things, these questions are not going to bother us. Okay. This question I gave in as a homework in the last class, right? This is the reason we started with telescoping, right? How telescoping happens. For example, this is what? This is sum of n terms. Sn is defined to you as sigma over k equal to 0 to n, and 1 divided by square root of k plus 1 plus square root of k. Okay. Now this way we are not able to apply anything. Why? Because this looks like this. If we magnify this, what does it look like? 1 divided by square root of 1 plus square root of 0 plus 1 divided by square root of 1 plus 1. That means 2 plus square root of 1. Now k is, first k was 0, then k was 1, then k will be equal to 2. So square root 3 plus square root 2, right? 1 by, then next of the terms will be square root 4 plus square root 3. This is the situation. Okay, this is what this sigma means. But when there are irrational term in the denominator, we are not being able to do anything about it, right? We are not able to do anything about it. But if whenever such type of thing happens, you know what you do is you can telescope only, you can make it a telescopic series only when there is a difference in between, right? Addition, how will terms get cancelled? So terms are not getting cancelled over here. What you'll do about it is that you'll rationalize this. How do you rationalize? You multiply and divide with the conjugate of this thing. That means square root of k plus 1 minus square root of k, will multiply it and divide it with. Right? Why did we do this? Because now this is going to become from k equal to 0 to n. This is becoming what? square a plus b into a minus b. This is a plus b into a minus b. That means k plus 1 square root of k plus 1 whole square. That means k plus 1 minus square root of k square. That means k. So k plus 1 minus k will be equal to 1. So this thing is 1. This denominator thing is 1. And numerator thing is what? Square root of k plus 1 minus square root of k. Now telescoping can happen. Now we can hope for the terms being cancelled. So how? If we open this again, what is this? Put k equal to 0, so we'll have square root 1 minus square root 0, right? Plus, put k equal to 1, so square root 2 minus square root 1. Put k equal to 2, so plus square root of 3 minus square root 2. K equal to 3, if we put square root of 4 minus square root of 3. Okay, till n. So square root of n plus 1 minus square root n. Square root of n plus 1 minus square root n. This is going till n. K is iterating from 0 to n. So now you see terms are getting cancelled. This is getting cancelled. This is 0 only, right? This will get cancelled. This will get cancelled. Okay. So last of the terms. See, terms started getting cancelled from here, no? So square root of this, square root of n plus 1 minus n, this negative term will get cancelled, right? What will remain? Square root of n plus 1 will remain. So this thing which is given to us, k equal to 0 to n, from square root k plus 1 minus square root k, this is nothing but square root of n plus 1. The answer is square root of n. The answer till here is square root of n plus 1. Okay, ji. Now this is my Sn, sum of n terms. This is Sn only. Now they are asking you to find they are asking you to find the value of this, n iterating from 1 to 99, and find 1 by Sn plus S of n minus 1. So I know that my Sn is nothing but square root of n plus 1. Okay, I need to find what? I need to find n iterating from 1 to 99. N is from 1 to 99. And 1 divided by Sn plus S of n minus 1 plus Sn minus 1. This is what I need to find. So basically, if I put this over here, what do I have? I want n is equal to 1 to 99, sum of n is equal to 1 to 99, where Sn is Sn. So Sn will be 1 divided by square root of n plus 1, and S of n minus 1. S of n minus 1, just instead of n you put n minus 1. So n minus 1 plus 1 will again become n only. So square root of n plus 1 plus square root of n. Isn't this the same situation which we had earlier? Correct? This is the same situation which we had earlier, right? Again, what we'll do, we'll write it as n from 1 to 99, and this will become square root of n plus 1 minus square root of n divided by 1, right? Reciprocaled again. Rationalized again. And if I look at this closely, what is this? N equal to 1, that means square root 2 minus square root 1. Plus now n will be equal to 2, so square root 2 plus 1, 3 minus square root 2. Plus n will be equal to 3, so square root 4 minus square root 3. Right? Plus square root 5 minus square root 4. It will keep going on. Till what? Till 99. So at 99, what will we have? Square root 100 minus square root 99. Now negative terms, we have started cancelling from negative terms. So 99, square root 99, because previous term before 99, what will be the terms? Before 99, put n is equal to 98. So square root of 98 plus 1, that means 99, minus square root of 98, right? And plus this. So this will get cancelled. 98 minus 98 will also get cancelled. Only square root 100 will remain. Alright, only square root 100 will remain. All the terms will get cancelled, because obviously n plus 1, square root n plus 1 is going to remain. So that means we already know the answer. Square root of 100 is remaining. Only square root 100 will remain. Rest everything is getting cancelled. Oh no, why did we cancel square root 1? Why did we cancel square root 1? Square root 1 is not going to be there. Right? Why did we cancel square root 1? We cannot cancel square root 1. Square root 2 is getting cancelled, and Square root 1 will remain. Yes, square root 1 will remain. This term will remain. No, first negative term is going to remain. Let's check here also. Acha, here square root 0 was there. That's why we didn't consider. So here square root 1 will also remain. So this will be 10 minus 1. That means our answer will be equal to 9. Answer will be equal to 9. Okay. This is how we were supposed to do this question. Telescoping is happening. Basically, you have to open and check what is happening, and finally you will have answer. Okay. To telescope, to make the series telescopic, or in such cases you have to rationalize and then do. You need a negative sign, you must remember. Okay. Next, the first term of the sequence is 2014. This question came in RMO, pre-RMO 2014, and that's why the question also contains the number 2014. Okay. The first term of sequence is 2014. Each succeeding term is the sum of the cubes of the digits of the previous term. Okay. Okay. What is the 2014th term of the sequence? Whenever such question comes, no, recursive sequence, or if you think that recursive sequence can form, you write the terms. Okay, you write the terms. So term 1 is what? 2014. Term 2. Each succeeding term is sum of the cubes of the digits of the previous term. That means term 2 will be 4 cube plus 1 cube plus 2 cube. Okay. So 64 plus 1, 65 plus 8, 73. 73. Okay. 73. Term 3 will be what? 7 cube plus 3 cube. Right? 7 cube plus 3 cube. 49 sevens are 343, na? 343 plus 9. 352 you'll have. And just check, I'm doing the calculation correct, no? 343 plus 27. 343 plus 27, this will happen, no? 343 plus 27 we are doing. 380 will be our answer. I think something recursive will form. So far, though, I'm not seeing anything. But 370. Okay. Alright, just check writing 3-4 terms. You also write. I'm sure that you'll observe what is happening. Check a couple of more terms. Okay. T4 will be what? 3 cube plus 7 cube. 370 only. T5 will be what? 3 cube plus 7 cube. 370. How easy this was. We just had to write some terms. So obviously after the second term, all the terms are going to be equal to 370. Because 3 cube plus 7 cube is always going to be equal to 370. All the terms, so 2014th term, be it any term, this will also be 370. What's the problem? Now the sum cannot change. Now the terms cannot change, right? 2014, 73 will give you 370, and after 370 you cannot do anything. All the terms will be equal to 370. So 2014th term is also 370. So I think this was the easiest question in 2014 then. What do you think? Chaliye, next question. Let U, V, W be not Rayleigh numbers, real numbers. Real numbers. Real numbers in geometric progression such that U is greater than V and V is greater than W. Okay. U to the power 40 is equal to V to the power N is equal to W to the power 60. Find the value of N. They are asking us to find the value of N. So because they have already given us that U, V, W are in geometric progression. U, V, W are in geometric progression. We know if A, B, C are in geometric progression, then B square is equal to AC. So we already know that V square will be equal to U, W. u multiplied with w. Okay, this we already know. Now what we can do is, we already know, okay, we can use this now. Now we are going to use this. What we can do is, v to the power n is some w to the power 60 divided by n, okay, like that. Or if we can create everything in w to the power 60, try to create everything in w to the power 60. U to the power 40 is equal to w to the power 60. For example, we have u to the power 40 is equal to w to the power 60. This is given to us. So u will be equal to what? W to the power 60 divided by 40. This we know, right? So u will be equal to what? W to the power 3 by 2, right? U will be equal to w to the power 3 by 2. Now v square is equal to u into w, and u itself is w to the power 3 by 2. So w to the power 3 by 2 into w we can do, and 3 by 2 plus 1 will be 5 by 2. So v square is equal to w to the power 5 by 2, and we can also say that v will be equal to w to the power 5 by 4, right? This 2 will also come, no, 5 by 2 divided by 2, so 5 by 4, right? V is equal to 5 to the power 4. Now v to the power n is equal to w to the power 60, right? Both sides, if we take power n, v to the power n will be equal to w to the power 5 by 4 to the whole power n, right? Right, and this v to the power n is equal to w to the power 60. So basically what did we get? We got w to the power 5n by 4 is equal to w to the power 60. Correct? It's already given, no? V to the power n is equal to w to the power 60. We got v. First we converted everything in w. We got v. We put power n on both the sides. Yes, we can put, right? And real numbers they are, no problem. So 5n by 4 will be equal to 60, and I got n. 5n by 4 will be equal to 60. So n will be equal to 60 into 4 divided by 5. 48 will be our answer. N will be equal to 48. Okay, n will be equal to 48. Very easily we could solve. We just needed to use the property of our GP. This thing. We just needed to use v square is equal to u into w. Why? Because the terms are in GP, and just like in AP, if 3 terms are in AP, if ABC are in AP, then we know that A plus C, arithmetic mean, will be equal to B. And if A, B, C are in GP, geometric progression, then geometric mean A and C will be equal to B square. A into C will be equal to B into B. Okay. Okay. Next. 1, 2, 3 till, this 1, 2, 3 till n, where n is greater than 2, are written on a board. This is 2017 question. Are written on a board. 2 numbers m and k. This is 1. First of all, this is 1. This is n. Yeah, this is n. This is 1. This is n. If the question is not clear, m and k. This is not dot. This is a comma. Sorry for the typing mistakes. Integers 1, 2, 3 till n, where n is greater than 2, are written where n is greater than, n is greater than 2. There is something fishy in this question. Let me check this question once again. Just a minute. Where is this question? Yeah, 1, 2, 3 till n, n is greater than 2 are written on the board. 2 numbers m, k such that, and the average of the remaining numbers is found to be 17. Chale, try this question. No, question is correct. They are saying integers 1 till n, where n is greater than 2, are written on a board. Okay. 2 numbers m and k. There are 2 numbers m and k such that these numbers lie between 1 and n. Both m is also between 1 and n, and k is also between 1 and n. Are removed, and the average of the remaining numbers is found to be 17. What is the maximum sum of 2 numbers removed? What is the maximum sum of 2 removed numbers? Very logically, very mathematically you will have to think about this question. This is a good question. Okay, come on, give it a try. Now, how can we approach? First, let's see how will we approach. They are saying m is between 1 and n, and k is between 1 and n. What we do is, they want us to maximize the sum, right? I know that sum of this 1 plus 2 plus 3 till n, this is equal to n into n plus 1 divided by 2. I know this sum of first n natural numbers, the sum is equal to n into n plus 1 divided by 2. So sum I know. Average of these will be equal to what? Average. Average will be equal to n plus 1 divided by 2, because you will divide the sum divided by total number of numbers. So n into n plus 1 divided by 2 upon n. Okay. Now they are saying two numbers m and k are removed and the average of the remaining numbers is found to be 17. So basically what they are saying is that when you two numbers are removed, no? So average including m and n, somewhere let's say 1, 2, 3 plus 4, somewhere m is coming and somewhere k is coming, right? And n is over here. So right now the average is total n numbers. Okay. Now what we are doing, removing two numbers. What we are doing is removing two numbers. So right now the sum is n into n plus 1 divided by 2. Now I want to remove m and n. So now what will happen? N into n plus 1 divided by 2 will be the sum of all n numbers minus m plus k. Right? Two numbers m and k I am removing, and divided by what? N minus 2. Two numbers are removed, no? Two numbers are removed. So total number of numbers, sum divided by total number of elements is the average. This is what they are saying. This is equal to 17. Now they are asking us what is the maximum sum of the two removed numbers. So minimum sum will be what? Minimum sum will be what? N is always greater than 2. So minimum sum will be when 1 and 2 are removed. Maximum will be when n and n minus 1 are removed. Correct? Right? Maximum will be when n and n minus 1 are removed. So minimum, let's say, if we remove, let's remove the smallest of the numbers. 1 and 2 are the smallest of these two numbers. Let's remove 1 and 2. What will be the average? N into n plus 1 divided by 2 minus 3 divided by n minus 2. Two numbers are removed, no? So n minus 2 over here. What will be the value of this? Let's calculate. N square plus n, leave it like this, n into n plus 1 minus 6 divided by 2 into n minus 2. Okay, so how much this comes? N square plus n minus 6, 3 and 2, let's see. So this, we can factorize this, no? N square plus n minus 6 divided by 2 into n minus 2. Can we factorize this? Plus 3 and minus 2, yeah. N plus 3 and n minus 2. So this will be n plus 3 into n minus 2. Okay. And divided by 2 into n minus 2. We can write it like this, n minus 2 got cancelled, and we have n plus 3 divided by 2. This will be the minimum sum obtained because we are removing the smallest of the numbers, first two, right? Now let's remove the last two numbers, n and n minus 1. Now let's remove n and n minus 1. Suppose we are removing the last, whatever is the possibility. Okay, why? Because maximize, if you want to, why am I doing all this? Because if you want to maximize, right, something, if you want to maximize something, you need to create a inequality, and to create that inequality I need some information for m and n. So I am seeing what is the maximum range, right, smallest and largest. Now my m plus n will remain between these two only, no? Okay, so if I removed n and n minus 1, suppose these two numbers I am removing, so my average will be n into n plus 1 divided by 2 minus n plus n minus 1 minus n plus n minus 1. So 2n minus 1, 2n minus 1. Here I will get 2n minus 1 divided by n minus 2. Now let's calculate this. So n square plus n minus 4n plus 2. Okay, divided by n minus 2. Now this will be n square minus 3n minus 2 divided by n minus 2. So minus 2 minus 1, no, 2, 1 minute, something's wrong. Minus plus, this will happen, no? So plus 2. Wait, here we did something wrong. Just a minute. So let's write a couple of more steps, not a problem. N square plus n minus 2 into 2n minus 1 divided by 2 into n minus 2. This is what we are getting. So this will be n square plus n minus 4n plus 2, minus 4n plus 2 divided by 2 into n minus 2. Okay, so now this is minus 4n here was here, minus 4n, n minus 4n plus 2. So minus 3, this will become n square minus 3n plus 2 divided by 2 into n minus 2. So minus 2 minus 1, n minus 2 into n minus 1, right? This will become n minus 1 divided by 2, right? N minus 2 into n minus 1 are the factors, n minus 2 will get cancelled and we'll have n minus 1 into 2. Okay. So this is our average when we are removing the last of the two numbers, right? Last of the two numbers. And now let's remove m and n. So when we are removing m and n, we have n into n plus 1 divided by 2 minus m and k. M and k, na? M and k there were. M and k there are. M and k. Yes, m and k are there. Minus m plus k. Okay. Divided by n minus 2 because two numbers are removed. Right. Now let's solve for m and k. Now we can solve for m and k. Come on now. Now tell me. Let me read the comments if there are any. Are we able to understand? No, sound is not. Sound is clear only here. On my system, it's showing clear. Hanji. So now whatever our average is going to be will be between these two, right? N minus 1 by 2 and the other one which we got. Whatever our average is will be between these two. Whatever our average is, with that average will be between n plus 3 by 2 and n minus 1 by 2. Am I correct or not? Tell me. Whatever average we are getting, because we found the outer limits, no now. However, whatever average we get, it is going to be lesser than this. Why is this not getting connected, man? Okay, I hope this thing is clear, right? Whatever average we are going to get in this case will definitely be between n minus 1 by 2 and n plus 3 by 2. So far we have got this thing. Okay, ji. Now what was the average given to us? Average was given to us as 17, right? 17, right? So my 17 has to be between this thing. 17 has to be between n plus 3. It has to be greater than n plus 3 by 2 and it has to be smaller than n minus 1 by 2. Am I saying the correct thing or not? It has to be smaller than n minus 1 by 2 and it has to be greater than n plus 3 by 2. So I'll solve this thing. I'll say, okay, 70, I want n plus 3 by 2 to be less than 17. So my n will be equal to 34 minus 3. That means n should be less than 31. Correct only we are doing, no? And n minus 1 by 2 should be greater than 17, right? So now this gives me 34 plus 1, 35. N should be greater than 35. Arey, we did ulta we did. Ulta we did. Right? N 17 should be greater than n plus 3 by 2 and less than n minus 1 by 2, right? So I'll get n will be between 35 and 31, right? N will be between 35 and 31 by solving this. Why did I do this? Because minimum average I can get is n plus 3 by 2. Last two numbers if I get. If I remove the largest of the numbers, minimum average I'll get. And if I remove the smallest of the numbers, maximum average I'll get. So maximum average is this, minimum average is this. So whatever is 17, 17 is going to stay between these two. And with that I get n will be between 31 and 35, and n is an integer. So n's possible values are 32, 33 and 34. These three possible values I can get for n. But obvious, correct? If this is obvious, then I'll just check over here. On n is equal to 32, you check what value you are getting. 32 will be 16 into 33 minus m plus k divided by 32 minus 2, that means 31. Okay. This should be equal to 17. This is equal to 17. So what are we getting for m plus k? So find the value, no? M plus k will be equal to 16 into 33 minus 17 into 31, right? And if you put n is equal to 33, what are we getting? M plus k. So this will become n into n plus 1, that means 33 into 34, 33 into 17 minus m plus k, right, divided by n minus 2, that means 30, n minus 2 it was kya? So this will be 30, and here also we'll have 30, okay, right? If n minus 2, so this will be 31 equal to 17, so you'll get m plus k is equal to 17 into 31, okay, 17 into 33 minus 17 into 31. Right, this will be your m plus k value. Now you just need to check which is the maximum. In the third case, n is equal to 34. For n is equal to 34 also you can check the value of m plus k. One maximum you will get. I think at 34 you should get. I'll calculate it quickly. I'll just calculate quickly. N is equal to 34. So for n is equal to 34 you will get 34 into 35 by 2, that means 17 into 35. So this will become 33 minus 2, 31. Okay, so we'll have 17 into 31 minus 17 into 35. Wait. 17 into 35 minus 17 into 31. Yeah, 17 into 35 minus 17 into 31 you are going to get. Let's check the answer. 17 into 35 minus 17 into 31. 68 we are getting over here. Then 17 into 33 minus 17 into 31, although we can calculate it also. Right, this will be your maximum of the values. Right, for n is equal to 34, for n is equal to 34 we are getting 51, right? So 51 will be your maximum value. When n is equal to 32 you got m plus k is equal to 18, right? Just put it equal to 17, right? Just check. I'll write and calculate once again. Just this thing you need to check, okay? For n is equal to 32, n is equal to 33 and n is equal to 34. I'll just calculate and tell you 33 and n is equal to 34. So for n is equal to 32 you will be getting m plus k is equal to 18. M plus k will come out to be equal to 18. For n is equal to 33, what were we getting? Just a minute. We were getting 34. And for this one we are getting m plus k is equal to 51. Anyway, at n is equal to 34 we are going to get the maximum value, which is 51, and 51 will be our answer. maximum of m plus k will be equal to 51. Good question. This is how you are supposed to solve this. I hope this made a lot of things clear. Chaliye, let's go ahead. This type of question you must have solved earlier also. This came in 2018. I hope you know the method to solve it. So we have 6 plus 66 plus 666 plus, so here we have 100 times 666, 666, 100 times. This is last digit contains 10066, 106, right? All these 6's are 100. Okay. Anybody who has solved this type of question? Anybody who has solved this type of question? Right, very regular type of question. No, many students must have solved it somewhere or the other. Very regular type of question. Right, if you are solving number series also, number system questions also, then also you will get such type of a question. Then also you definitely get what is the idea? First you take 6 common. First what you will do, you will take 6 common, right? So this will become 1 plus 1 1 plus 1 1 1 plus 1 1 1 1, and you will have 1 1 1 1 1 1 1 1. This will be 100 times 1, 100 ones. Okay. Now what next step should be? Try to create 9s, because you need to make a GP. This is not a GP right now. This is not a GP right now. Right? This is not a GP right now. So what you do? GP, how can you create? In terms of 10 you try to create GP. How do you do that? You divide by 9 and multiply by 9 inside. So inside what will you have? 9 plus 99 plus 999 plus 9999, and here 100 9s. Okay, here you will have 100 9s. You divided by 9, multiplied with 9. Now what is the idea? Next is you will have 6 by 9, and all these 9s, 9 can be written as 10 minus 1, 99 can be written as 100 minus 1, right? 999 can be written as 1000 minus 1. Okay, correct? Okay, 10 to the power 100, right? Because minus 1. This is 10 to the power 3 minus 1. This is 10 to the power 1 minus 1. 10 to the power 100 minus 1. Last term will be 10 to the power 100 minus 1. Okay. So 6 by 9. 1 we have 10 plus 10 to the power 10 square plus 10 square 10 to the power 3. Right. Likewise. Are you able to understand this? Clear, right? Right, minus 100. Now 100 terms are going to be there, obviously. Right, 100 terms are there. Can we see that? 100 terms are there, no? Because last term contains 106. So 100 terms are there. If we are subtracting 100 times, if we are subtracting 100 times, that means here what we'll have? Here we'll have 10 to the power 100 and minus 100. Correct? If we are subtracting 100 times, that means 100 will come, negative 100 will come. Okay. This series we know how to solve. This is a GP, 10, 10 square. This is a GP. First term is 10. Common ratio is 10. How many terms we are looking for? We are looking for 100 terms. Till here we have 100 terms. 1, 2, 3, 4. Till here we have 100 terms. So 10 to the power 100. 10 to the power 100. R to the power n minus 1 divided by 10 minus 1. That means 9. Divided by 10 minus 1. That means 9. Right? And minus mein this 100 is also there. Minus mein this 100 is also there. Now this is what 2, this is what 2 is 2 by 3. Okay, let's write it as 2 by 3. Then here we have 10 to the power 100 minus 1. Now think about what is the question asking. Question is asking how many times does the digit 7 occur in number n. Right? So we'll have to solve it a little bit more to understand how many 7s will occur over here. Okay, whatever this is 10 into 10 to the power 100 minus 1. Right? What will it have? 10 to the power 100 will have some 100 zeros, right? Correct? 100 zeros will be there. Now 100 zeros, 10 to the power 100 into 10, this will be 10 to the power 101 minus 10 divided by 9 minus 100. Let me write one more step. So 2 by 3 into, not 10 to the power 100 minus 10. This will have 9s, 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 right? How will this be? 10 to the power 100 and 10 to the power 1010 zeros? matlab 1 after 1 1 0 1 zeros minus 10 if you do. So last digit will be 0, remaining 100 digits will be 9, right? After 100 zeros, and from that you are doing minus 10. So last digit will be 0, but remaining by minus 10 if you do, last digit will be 0. All these will become 9, no? Right? So how many 9s are going to be there? Think about it. How many 9s? 100 9s will be there and last digit will be 0. So this will be 9, 9, 9, 9. 100 9s will be there and last digit will be 0. So till here we'll have 100 9s. 100 9s will be there. Last digit will be 0. And this is divided by 9 and minus 100 is there. Okay, minus 100 is there. Correct? Now you tell me this 2 by 3, this 2 by 3, all these will be 1, 2 by 3, right? All these will be 1, 1, 1, 1, 1, 1, 1, 100 ones, last digit will be 0, minus 100, right? Because we are dividing by 9, right? Now after doing minus 100, last 4 digits will be what? 1, 0, 1, 0. Last 4 digits will be 1, 0, 1, 0. Before that, 98 times 1 will come. Before that, 98 times 1 will come. Correct? I am writing it on the next page. 2 by 3. Right? What did we have? 1, 1, 1, 100 times 0 minus 100. So, minus 100, 2 zeros, 0, 0, 0, 1 and 0, 1. Right? So, suppose we have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, over here 0 and you are subtracting 100. So, 0, 1, 0 and 1. 4 will be 0, 1, 0, 1. And remaining of the digits will be 1 only. Same 1 will come because we are subtracting 100. So 1, how many times 1 is going to come? 100 times 2 zeros less, so 98 times this 1 will come. Think about it on your own. Then only you will be able to understand and do it. Right? 98 times 1s will come. Then last will be 0, 1, 0. Last will be 0, 1, 0. Okay? Till here, 98 times 1 is going to come. Now this you are multiplying with 2 by 3. Okay, so 2 if you multiply inside, this will become 2, 2, 2. 98 times 2, 0, 1, 0, 0, 2, 0, 0, 2, 0. Right, 2, 0, 2, 0 will be last and this divided by 3. Okay. Now try dividing and you will see there is a pattern here also. Try dividing, you will see there is a pattern here also. Try dividing 4 2s only, you will understand that there is a pattern. So this will come like this: 7 4 0 7 4 0 7 4 0. This is going to repeat itself, right? Till 96 of the, only the last one, only this 0 to 0 will not get divided, remaining all will get divided. Last will have 3 4 0. Till here will have 7. Till this 2 will have 7. Last may will have 3 4 0. All these, this is a repeated pattern. 96 times, when you divide, no, you will understand 96 times 7 is going to come. Right? After every third digit 7 is coming. So in 96 every third digit divided by 3, 33, 32 and plus this 7 will also come. Right? Plus this 7 will also come. So there will be 33 7s. There are going to be 33 7s. Do it on your own, then only you will be able to understand. Right? Divide this. Divide just 4 2s by 3. You will see 7407. Right? You will understand 7407 is going to repeat. Okay. 3 7s are 21, 1 2, 3 4s are 12, 0, 3 7s are 21 again. Right? So same thing is going to repeat. 740 740 740 will repeat. For the last one 0 to 0 will have 340. Right? Here we'll have 340. 2020 will be giving us 340. Okay ji? Right. Let's go ahead. Next question. 33 7s are going to be there. This is one question. Right? This came in 2021 IOQM. Okay. So we'll have to simplify this. Whatever is there in sigma, if we see, what is it saying? If we put k is equal to 1. So 2 into 1 plus 1, that means 3, divided by 1 plus 1, that means 2 square, plus, then put k is equal to 2. So 4 plus 1, 5, divided by here what we'll have? 4 plus 2, 6 square. Right? Third term will be 7 divided by 9 plus 3, 9 plus 3, 12. 12 square. Okay. So no pattern. In this way we are not able to see any of the pattern. Okay. In this way we are not able to see any of the pattern. What shall we do? Any idea? Any idea? Come on, tell me. Come on, try this. Give it a while. Try this question, guys. So we will have to simplify it a little bit, obviously. Okay, we'll have to simplify it a little bit. But how? See, if we take k common from the denominator, let's say, if we take k common from the denominator from here, k, so we'll have k plus 1, right? And this 2k plus 1 also can be written as k plus 1. Correct? First idea, first thought of approach that we can do, right? So what am I going to do is, in the denominator I have k square into k plus 1 whole square. Can I write it? K common. So k into k plus 1 it will be. So k square into k plus 1 whole square. And here I am writing k plus 1. Okay. Sigma is over this. 1 to n. Right? 1 to n. Now what am I going to do is sigma. Okay. Now k. Now I can split it. K divided by k square into k plus 1 whole square. Plus k plus 1 divided by k square into k plus 1 whole square. Either I can split and do something. So try. Can we do something like this? What do you think? Or should I split it like this or some other way? Because I want to make telescopic series, something like telescopic series. Otherwise, I don't have any idea how will I take this forward. So this way I am not seeing anything which we can do about it, right? Instead, we can, if we separate k square, suppose if we do like this, 1 by k square plus 1 by k square just like that, plus k plus 1 divided by k square into k plus 1 whole square. If I do like this, what happens? Something better? Can you see? Or, right, k, or one more method is there, that if I do 1 divided by k into k plus 1, I don't want square, right? So 1 divided by k into k plus 1, I can keep it like this only, right? Multiply it with k into k plus 1 divided by k into k plus 1. This way if I see it, this way. Why? Because we have learned we have learned how to make a telescopic series. This one we can make. This is 1 divided by n into n plus 1. If you remember the starting questions, here something telescopic will be formed. But remaining I am not able to form anything. Correct? And here also I will be able to split it. So now same thing I am writing like this. K plus 1 minus, okay, leave it, k plus 1 minus k divided by k into k plus 1. This one I am writing like this. Just like the starting questions which we did. If you understood those, you will be able to understand these also. And here what am I going to do is, k divided by k into k plus 1, that means 1 divided by k plus 1 plus 1 divided by k. Two multiplications I have formed, right? And now this thing, if you observe, the first bracket, this is what? 1 divided by k minus 1 divided by k plus 1. Correct? And the second bracket is 1 divided by k plus 1 divided by k plus 1. Wow, this is something I can deal with, because this is a square minus b square now. This is what? A square minus b square now. Correct? So my sigma is nothing but, sigma is I have broken down my sigma as 1 by k minus 1 by k plus 1 by k plus 1 into 1 by k minus 1 by k plus 1. Right, I could have done with other forms of fact, like if I solve and factorize, no, that way also I'll be able to do it. But still, now this way, this thing is looking much more better to me now. Right? Why? Because this is 1 by k square minus 1 by k plus 1 whole square. Correct? A square minus b square. K is iterating from 1 to n. Right? Now if I write the terms, now if I start writing the terms, right, if I expand this, k is equal to 1 means 1 by 1 minus 1 by 2 square. Correct? Plus k is equal to 2 means 1 by 2 square minus 1 by 1 plus 1, 1 by 3 square. Okay, plus k is equal to 1 here, k is equal to 2, k is equal to 3 now. So 1 by 3 square minus 1 by 3 plus 1, that means 4 square, plus 1 by 4 square minus 1 by 5 square. Correct? In the end, what will I have? In the end, 1 by n square minus 1 by n plus 1 whole square. Before this, if before this, what will be the term before this? Right? Put n minus 1, no? At n, that is the term. At n minus 1 will be what? At n minus 1, what are we going to have? 1 by n minus 1 whole square plus minus 1 by n square. Correct? So which of the terms are getting cancelled? This, all these will get cancelled. Even this will get cancelled and this will cancel this one. What will remain? What will remain? Can you see it? What will remain now? Right? Which of the terms are remaining now? Only one is remaining and the last term. That means 1 by n plus 1 whole square. Negative of that. So my sum of n terms is nothing but 1 minus 1 by n plus 1 whole square. This is my sum. This is my sum, which is given to me as 0.9999. This is my sum. Okay. So my 1 minus 1 divided by n plus 1 whole square is given to me as 0.999, 0.9 bar. Right? 0.9 bar. Okay, so you will do just 1 minus 0.999, that means 0.001. How many 9s were there? Let's see if they were finite or not. 0.9999. Okay, so what you can do is, now you will just simply do 1 by n plus 1 whole square will be equal to 1 minus 0.9999. Okay, right, this is what we are getting. Now we can find our answer very easily. Okay, this will be 0.0001, right? This will be 0.0001, 0.0001. So 1 divided by 10,000. That means 1 by 10 to the power 4. Okay, ji. 1 by 10 to the power 4. We can find n from here now. Any problem? Anybody? Right? 1 by 100 square is equal to, simply just do no. N plus 1 will be equal to 100. So n will be equal to 99. This is the sum of 99 terms, and they asked n only, right? They asked n only, yeah. So try to make a telescopic form. This is how you can do such questions. All right, let's move ahead. Okay, that's, I think, all for now. Some of the more things which I wanted to. Achha, we did multiple sigma also, right? If we have more than one sigma, have we discussed those type of questions? I think we have, right? I think we have. Method of difference also we have discussed today. Telescoping also we discussed. So almost all the things we have discussed, and we have seen some PYQs also of IOQM today. So I think we are now sufficient enough, able enough, if we have followed all the 4 lectures. Now we have enough information and have enough knowledge to solve the PYQs of PRMO or IOQM. Okay, so do solve as many of them as you can. Today also we have solved somewhere around 8 to 9 PYQs, 9 to 10 PYQs, more than that I think, right? First ones which we solved, no, those were also PYQs. Okay, those were also PYQs. So yeah, we are good to go. Now you can solve as many questions as you want.